One minute, you're setting up a new space station orbiting Jupiter. The next, you're plunging right into the middle of a giant red cyclone of death. What would the storm of all storms look like on the inside? How would it compare to storms back on Earth? And which one of Jupiter's tremendous forces would strike the lethal blow? This is What If, and here's what would happen if you fell into Jupiter's Great Red Spot. The Great Red Spot is the biggest storm in the solar system. At about 16,300 kilometers wide, well, it's large enough to swallow the Earth whole. It's a lot like a hurricane, only instead of lasting a few weeks, this giant storm has been rampaging for at least 300 years. And instead of forming from warm air, this monstrosity gets its energy from the dense atmosphere of Jupiter. Fueled by an abundance of the planet's hydrogen and helium, the Great Red Spot reaches 500 kilometers into its atmosphere. Oops, you should have built your space station a little farther away. Okay, well first, how on Earth would you even get to Jupiter? Well, if you traveled light and followed the route of the Voyager spacecraft, you'd arrive on Jupiter in just under 600 days, but this journey wouldn't be as simple as just pointing yourself at what appears to be a very bright star in the night sky. Roaming the solar system in a spaceship is a little more complicated than that. You see, the Voyager never intended to land on Jupiter, only to pass it on the way to interstellar space. So if you followed Voyager's path, you'd whip right past your target. For this to work, you'd need to follow the lead of the Galileo spacecraft, launched in 1989. Just like Galileo, you'd swing by Venus and then back around Earth for a little gravity assist. This way, you'd have the right speed to park in Jupiter's orbit. Only the trip would now take you 6 years instead of 600 days. By the time you reached Jupiter's moon, Europa, the planet would appear 22 times larger to you than a full moon did back on Earth. And you'd still need to get a little closer. Now you'd be mesmerized by the planet's swirls and stripes. These are colored red, brown, and white, thanks to the sunlight reflecting off massive clouds made of ammonia and ammonium sulfide. Finally, you'd feast your eyes on the Great Red Spot, a giant twirl of the atmosphere rotating counterclockwise. It looks a lot bigger than you could imagine. But before you even begin your descent into the Great Red Unknown, your life would already be in grave danger. Jupiter's powerful magnetic field would shower you with intense radiation. I mean, luckily, you'd be equipped with a highly advanced protective suit, but it wouldn't be able to protect you from everything. As you approached the storm, you'd realize that you made a big mistake in your mission prep. Your plan was to build your space station at the same altitude as the International Space Station, 400 kilometers into Jupiter's atmosphere. Yeah, except this storm is as deep as 40 Mariana Trenches. So it would swallow you up before you could finish your project. But now it's too late. You'd be plummeting through the storm and you'd get your first real glimpse of how powerful it is. You'd be thrown around at wind speeds of about 400 kilometers per hour. To give you a sense of how insanely powerful that would be, hurricanes are ranked into 5 categories based on strength. A Category 1 storm has wind speeds up to 153 kilometers per hour, strong enough to snap large trees. In the middle, a Category 3 hurricane can hit 208 kilometers per hour. These storms could result in devastating damage, including pulling roofs right off of houses. Lastly, a Category 5 hurricane back on Earth has wind speeds of 252 kilometers per hour or higher. That packs enough of a punch to collapse buildings, but that's still only half as strong as the winds in the Great Red Spot. Thankfully, your body can withstand wind gusts as high as 800 kilometers per hour, but that doesn't mean it would be refreshing in any way. Without the protective face gear, your skin would look as if it was melting straight off of your face. So make sure to hold on to that helmet tight. Not that you'd be able to do much else besides staying on a violent downward trajectory at this point. As you were falling into Jupiter, you'd see how clouds around you would change. First, you'd get a real close-up view of those ammonia and ammonium sulfide clouds you were mesmerized by before. Then you'd pass through clouds made of water, just like the ones on Earth. The temperature and pressure all around you would be changing too. Sadly, none of this would be comfortable for you, especially not at the same time. Where the atmospheric pressure is similar to that of sea level back on Earth, it would be a very chilly minus 110 degrees Celsius. And where the temperature was bearable, the pressure would be 8 times greater than what it was back on Earth. Now, the chances of surviving up to this point would be slim. I mean, look no further than the fate suffered by the Galileo probe. As it descended further and further into Jupiter, it encountered extremely high temperatures. And what do you think happens to a probe in that environment? Yeah, it vaporizes. Without a spacesuit strong enough to withstand all that heat and pressure, you'd end up disintegrating, just like the probe. Now you'll be one with the gas giant forever. I find our big buddy Jupiter one of the most fascinating planets in the solar system, and I love learning more about it. Well, in addition to watching what-if videos, there's another way you can learn, one that's quick, visual, and effective. I'm talking about Imprint, an app where you can learn interactively at your own pace, building a habit around understanding the world without the need for hours of studying. Those precious minutes you're spending doom-scrolling social media, you could use them to dive into courses on science, technology, and history. Imprint offers bite-sized, illustrated, and animated lessons, helping you quickly grasp complex topics. Whether you're curious about the psychology behind habit building, the history of ancient civilizations, or the latest tech innovations. With millions of users and over 30,000 5-star reviews, it's no surprise Imprint has been named App of the Year by Google and an essential education app by Apple. It's all built on the science of learning, with repeated concepts and quick quizzes to make sure everything sticks. Start learning with Imprint today, free for 7 days, and as a What If viewer, you'll also get 20% off an annual premium subscription. Just click on the link in the description and start transforming your screen time into something truly enriching.
What if Jupiter gained just a little bit more mass during its formation period and then ignited to become a star? How different would our solar system have turned out? Would having another star in the middle of the solar system mess with the orbits of the planets? And would we see it from here? This is What If. And here's what would happen if Jupiter became a star. Jupiter has more than twice the mass of all the planets in the solar system combined. It doesn't have a solid ground and is made up of the same elements as the Sun. And yet, it's not a star. Jupiter doesn't have enough mass to initiate a fusion reaction in its core, the necessary requirement to be accepted into the star club. If only we could find 79 more Jupiters and crash them all into the one we have now, we'd be able to build a second star in the solar system. What would that be like? 80 Jupiters crushed together would make a star out of the gas giant, but that star would be nothing like the Sun. Jupiter would be massive enough to become a red dwarf, a small, cool, hydrogen-burning star. And, as every red dwarf out there, it wouldn't be too bright. 0.3% of the Sun's luminosity is the most light that Jupiter could hope to spit out. Because Jupiter is 4 times further away from us than the Sun, the Earth wouldn't get much heat from it. By and large, Jupiter turning into a red dwarf wouldn't change anything for life on Earth. You'd still be able to see it from Earth. A Jupiter star would appear red and a bit brighter than the Moon at its full phase. Would it at least have a gravitational impact on the solar system? Not as much as you might think. The former gas giant would slightly shift the orbits of the other planets, but not enough to set them on a collision course with one another, or to launch them out of their orbits into outer space. The only threat we'd face would be space rocks from the asteroid belt that Jupiter might send towards the Earth. We'd need to learn how to detect and destroy them before they could reach our planet. Other than that, not much would change for the solar system. Things would get a lot more fun if Jupiter was replaced with a Sun-like star. If our gas giant became 1,000 times more massive, the solar system would go wild. Asteroids would crash into planets, and planets would change their orbital course. It's hard to predict what would happen to Earth in this gravitational mess. It could be anything from being pulled a little too close to Jupiter's star and getting scorched, to being left drifting alone in the void of space. In any case, it wouldn't be too pretty. In the real world, Jupiter is forever destined to be a planet, and that's for the best. The observable universe has a diameter of about 92 billion light years. Within it are planets, nebulas, asteroids, the list goes on. But what would happen if we got rid of a single planet? Specifically, our largest planet, Jupiter. How important is this gas giant to our solar system? How would it affect life on Earth? And how would this change Earth's development? This is What If, and here's what would happen if Jupiter never existed. If Jupiter was no longer in our solar system, having one less planet to aspire to travel to would be the last thing we'd have to worry about. This gas giant ranges from 600 to 1,000 million kilometers away from Earth. But despite it being so far away from us, we'd experience direct implications right here on Earth. Why is this? Well, to say that we'd notice Jupiter's absence here on Earth is a bit of an understatement. This is due to Earth not being around, at least not in the current state as we know it today. Sure, it would still be some sort of planet, but it's very unlikely that there would be any complex life forms. No fish, animals, and certainly no humans. Earth has been hit by tons of asteroids and other space rocks. According to some experts, they may have brought water and other essential substances down to Earth. But although some asteroids can be good, there's plenty of bad ones. Some would be big enough to wipe out entire civilizations, just like what happened to the dinosaurs 65 million years ago. This is where Jupiter's role comes in. Although it has slipped up a couple of times throughout the history of our solar system, Jupiter has been protecting us. As millions of asteroids have been heading towards Earth, Jupiter's gravitational pull has grabbed the asteroids. This puts them in Jupiter's orbit and unable to reach Earth. Without our giant protector, Earth would be hit by a lot more asteroids. And it's unlikely that another planet would step in to fill Jupiter's place, considering that the gas giant is the only planet big enough to attract all these asteroids. This means Earth would get hit by thousands more asteroids than it ever has before. Some would be small and could maybe help Earth, bringing us new elements. But it's possible Earth would get hit by a couple of big ones. Enough to destroy anything that would be evolving on the planet. And maybe enough to destroy Earth itself. So, we know we probably wouldn't be here if Jupiter had never existed, but what if it suddenly disappeared today? Our solar system would have developed in the exact same way, but Jupiter suddenly blinked out of existence. For more on how our solar system as a whole would shift and get all out of sorts, you can check out our episode, What If Earth Was the Only Planet in Our Solar System? But if only Jupiter disappeared, it might be a good thing. Despite being our protector, occasionally Jupiter messes up and might miss a couple of things. Jupiter threw a comet towards us 350 years ago. Luckily it missed us, but it wouldn't have been anywhere near Earth in the first place if it wasn't for Jupiter. Despite Jupiter occasionally throwing some space rocks our way, it has largely helped us throughout history. So I'm going to say it's probably best to let Jupiter stay in our galaxy.
Jupiter may be the biggest planet in the solar system, but its days are numbered. Because today, we're using Earth's biggest, baddest bombs to blow the gas giant into oblivion. How many nukes would you need to do the job? What obstacles would these rocket-bound bombs encounter on the way? And would one nuclear explosion ignite the entire planet? This is What If, and here's what would happen if we nuked Jupiter. Nuclear weapons are so powerful that even the low-yield versions, like those dropped on Japan by the United States in World War II, have the explosive equivalent of 15 to 20 kilotons of dynamite each. What makes them so volatile is that they harness the intense energy-releasing power of nuclear fission or fusion. These are the same processes that happen in our very own sun. So be careful when moving these things out to Jupiter. One false move and you could be incinerated by a fireball as hot as the center of the sun. In order to blow Jupiter to bits, one single bomb wouldn't necessarily be up for the task. Good thing for this scenario that there are a lot of nuclear weapons on Earth. Maybe the safest plan would be getting them all off our planet anyway. Given the top-secret nature of military activities, it's hard to know the exact number, but estimates put the global arsenal at about 12,700, with the United States and Russia battling for top spot with 5,500 to 6,000 weapons each. Okay, there's no use in delaying. Let's get these rockets off Earth as fast as possible. The distance between Earth and Jupiter fluctuates from about 590 million to 970 million kilometers. In the past, missions like the Galileo space probe took nearly 5 years to make the journey to the gas giant. But our rockets wouldn't take this long. Galileo had to be slow enough to enter Jupiter's orbit. We just need to hit the planet head-on, so you'd only be looking at about 550 to 650 days to get the job done. You shouldn't be too reckless and speedy, though. You don't want to nuke something else by accident. Now, bypassing the Moon and Mars would be easy enough, but getting safely through the asteroid belt would be like navigating a minefield. There are millions of asteroids riddled between Mars and Jupiter, and while the average distance between them is a not-so-worrisome 966,000 kilometers, sometimes it can still get a little cramped in there. And Jupiter is partly to blame for this. The planet's massive gravitational influence causes many of these to group into clusters known as families. Carelessly navigate through one, like the Flora family, and you'd better hope none of our rockets would collide with any of its 400 asteroids. For the best chance of success, you should aim to transport your rockets through the Kirkwood gaps. These are nearly asteroid-free regions in the belt, because you'd hate to see all of our planet's nukes detonate themselves in a blinding chain reaction before reaching our target. As the first of our bombs exploded on Jupiter, you'd see bright flashes back here on Earth. just like when the Shoemaker-Levy 9 comet slammed into Jupiter in 1994. But that only released 5% as much energy as the Tsar Bomba, the largest bomb ever created. So with thousands of our nuclear bombs, Jupiter's days would have to be numbered, right? Well, not exactly. Even though our nukes could produce an explosion hotter than the Sun, this wouldn't cause all the hydrogen on Jupiter to ignite. It just isn't dense enough to sustain nuclear fusion. And even if every bomb was detonated, Jupiter wouldn't blow up completely either. In order to do that, we'd need to unleash as much energy as the Sun releases over 160 years, all at once. And for that highly energetic result, about 1 billion nukes would be required. Somewhat more than the 12,700 in our arsenal. To build that many bombs, you'd need a combined mass of material that would almost be twice that of the largest moon in the solar system, Jupiter's Ganymede. No small feat, since it's bigger than Pluto and Mercury.
Ever feel like the Earth is just too small? Well, let's make it bigger. Much, much bigger. Welcome to a new Earth that is just as big as Jupiter. In what ways would Earth change? What things would stay the same? And how would this affect you? This is What If, and here's what would happen if Earth were the size of Jupiter. A super-Earth is a planet with a mass up to 10 times bigger than the Earth. But don't let the name deceive you. These super-Earths aren't anything like the Earth you know. These planets could be rocky or covered entirely in ice. They could even be gaseous like Neptune. But if you want to make the Earth as big as Jupiter, get ready to make a super Earth. While Earth, as it exists now, is much smaller than Jupiter, it is a pretty dense rock compared to the gas giant. Our new planet would be massive, about 1,300 times bigger than Earth today. And that's not the only thing that would be different. Jupiter has a radius about 11 times that of Earth. Get used to a little more gravity when you walk around. Yeah, 11 times more. So, if Earth was this huge, how soon would the gravity completely crush your body? This change in size would have enormous implications for you and all other life on Earth. The first thing you'd notice with 11 times the surface gravity is that you would weigh more. And there's not much a diet plan could do to change that. You'd be 11 times heavier than you are now. So, if you currently weigh 70 kilograms, well, get ready to start lugging a hefty 770 kilograms around. Would you even be strong enough to carry your own weight? Well, you'd be heavier than the world deadlifting record of 501 kilograms held by Game of Thrones star Hafthor Bjornsson. So, yeah, good luck. But if you were a couch potato, this could be good news. Getting up from the couch wouldn't be an option. You wouldn't have the muscle strength. Even breathing would be a near impossible task. Scientists have concluded that the maximum gravitational field that humans could adapt to is about 5 times the gravity of Earth. Well, now double that, and that would be your new normal. And you wouldn't be the only one feeling heavier. All that gravity would result in increased atmospheric pressure. Yeah, you'd feel the air pressing down on you. This would have severe environmental impacts. Water molecules would need more energy to escape their liquid form.
That means the boiling temperature of water would be much higher than 100 degrees. And the freezing point would now be way below 0 degrees. It would be harder for you to make ice. And even the large chunks of ice, like icebergs, could melt away. And there would be disruptions beyond life on the surface of Earth. Introducing a massive planet into the solar system would create some serious instabilities. Our moon would experience extreme changes in tidal forces. This gravity could be strong enough to pull the moon apart into teeny tiny pieces. The only remnant you'd have left would be a new ring of debris forming around Earth. The sun would still be 250 times more massive than our new Earth, so Earth wouldn't steal any planets away, but our super-Earth could have some effect on their orbit, just as Venus and Jupiter impact our orbit and climate today. The Earth would affect the orbits of other celestial bodies like asteroids. Our gravitational pull could be strong enough to eject these objects from the asteroid belt and set them on a collision path with you. And that would be bad news. Remember, you wouldn't be able to move a muscle to escape. So maybe it's better if Earth stays the same size as it is now. Uh-oh! Looks like somebody left the gas running on Jupiter. Don't do anything stupid like lighting a humongous match. What would a match need to be made of to ignite this gas giant? How big would it have to be? And how much damage would this explosion do to our solar system? This is What If, and here's what would happen if you lit a match on Jupiter. Okay, you've heard me say this before. Jupiter is the largest planet in our solar system. It's 300 times more massive than Earth, but it's less dense than our home. With no solid surface, this planet is almost entirely gaseous. It has an atmosphere composed of 90% hydrogen, about 10% helium, and trace amounts of methane and ammonia. With so much hydrogen present, pretty much all of Jupiter must be flammable, right? So, if you lit a match, how much of that wooden stick would burn off before it all goes kaboom? Okay, before you go ahead and strike that match, there's one big catch you didn't account for. Fire needs oxygen. Without any oxygen in Jupiter's atmosphere, it would be impossible for the planet to erupt in flames. Not only that, but lighting your match would be difficult, to say the least. Usually, when you drag a matchstick across the red strip on your matchbox, you start a series of small chemical reactions that end in a flame. When you apply friction to the box, red phosphorus converts to white phosphorus. This mixes with the oxygen in the air and ignites. Without oxygen, this ignition wouldn't happen. But since you're so determined to set Jupiter on fire, you'd have to find a way around this obstacle. For starters, you'd need to reinvent the matchbox. You'd need one that could ignite the match without the need for external oxygen in the atmosphere. So you could lose the white phosphorus in your match. Instead, you'd need a match that could generate enough heat from friction to break down potassium chloride on the matchstick into oxygen. The flame would keep burning as long as the matchstick coating lasted. But one matchstick wouldn't provide you with the oxygen you'd need to ignite Jupiter. You'd need a lot more. Again, considering that Jupiter is the most massive planet in our solar system, you'd be burning off an astounding amount of hydrogen. To be precise, about 1.4 multiplied by 10 to the power of 27 kilograms of the stuff. For hydrogen to combust, you'd need about half as much oxygen present in the atmosphere as there is hydrogen. As you might have guessed, you'd need to gather a lot of oxygen. And because molecules of oxygen are way heavier than molecules of hydrogen, the total mass of oxygen we'd need would be about 6 times the mass of Jupiter. Yeah, there isn't enough oxygen in the entire solar system for this to happen. Sorry to disappoint you, but Jupiter won't be erupting in flames anytime soon. And before you try to get creative with your methods, let me tell you that even the most energetic impact that ever occurred on the gas giant didn't cause a single spark. In 1994, the comet Shoemaker-Levy 9 crashed into Jupiter. As it entered the atmosphere, it broke into multiple pieces. Some were as large as 1 kilometer in diameter. The total impact of all these pieces was massive. So massive that the total kinetic energy was many times more powerful than the Hiroshima nuclear bomb. But still, no flames. Still feeling destructive? Well, maybe you could see what would happen if Jupiter and Saturn collided. The two biggest planets in our solar system in one telescope view. Catastrophe is imminent. If Jupiter and Saturn suddenly were on a collision course, which of the two planets would emerge victorious? How would the composition of these planets affect the outcome? And what impact would this have on the rest of our solar system? This is What If, and here's what would happen if Jupiter and Saturn collided. On December 21st, 2020, Jupiter and Saturn were closer than they've been in nearly 400 years. This legendary event has an epic name: the Great Conjunction. You could see both planets in the same telescope view. They appeared as a single star in the evening sky, but they were still pretty far from an astronomical collision. If the two gas giants came a little closer, it wouldn't be the first time Jupiter has gone head-to-head with another planet, and you can probably guess who won that battle. Both Jupiter and Saturn are almost entirely gaseous, primarily consisting of hydrogen and helium. And while they may have solid cores, there's no sharp transition between the layers. Jupiter would have some significant advantages. It's about 3 times as massive as Saturn, with almost double the volume. And it's moving faster too. Jupiter's rotation speed reaches 13 kilometers per second, while Saturn rotates at just below 10 kilometers per second. But Saturn brings a wild card to the fight. Within its 2 rings, there are at least 150 moons and moonlets. If the planets drew closer together, Jupiter's strong gravitational pull would cause these moons, moonlets, rocks, dust, and ice to accelerate toward it. Some of them would be torn apart. That's what happened when the comet Shoemaker-Levy 9 collided with Jupiter in 1994. Originally, the comet was nearly 2 kilometers wide. But by the time it crashed, Jupiter's gravity had torn it to pieces. And those fragments smashed into Jupiter with the force of 300 million atomic bombs. Yeah, and that heated Jupiter's atmospheric temperature to nearly 40,000 degrees Celsius. Titan, Saturn's largest moon, is over 2,000 times larger than that comet, so the force of it alone colliding with Jupiter would be massive. If Jupiter and Saturn collided, they would begin to merge. Their atmospheres would mix. That would raise the temperatures in the top layers of the gas giant's atmospheres. It would get so hot that Jupiter would experience a chemical reaction, gaining more iron, silicates, and even water. Eventually, Jupiter would absorb Saturn, or most of it. Scientists at Sun Yat-sen University in China modeled a scenario about what happened when a massive planetary embryo, about 10 times the size of Earth, collided with Jupiter 4.5 billion years ago. The impact was so energetic that it destroyed Jupiter's original compact core. This formed a more diluted core composed of a dense mix of liquid metallic hydrogen and helium. But if Jupiter collided with Saturn, that event would be 10 times more massive. Large amounts of material would spread out in space, and then all that material would come together into a single planetary object. We'd call it New Jupiter or Jupiternus. And maybe that new planet would cause more trouble in the solar system than you might expect. Jupiter is sometimes referred to as a failed star. That's because its size and composition are similar to a brown dwarf. But Jupiternus would be more massive and have higher internal pressure. If the temperature was high enough, this could cause nuclear fusion in its core. Yeah, Jupiternus could become a star. And the impact of having 2 stars in our planetary neighborhood would be huge. It could even mean the end of life on Earth. Now, don't worry, if these 2 planets merged, Jupiternus would have a mass 30% greater than Jupiter, but for nuclear fusion to ignite, the planet would need to reach a mass of 75 Jupiters. So, life on Earth would go on, but this would be a spectacular show with tons of gas and debris expelled. Maybe it would all be illuminated by the sun, giving us a beautiful, glittering end to Saturn as we know it. Hey, at least this time Jupiter didn't go on a rampage and swallow every planet in our solar system, including Earth. You start your day hearing wild news. Jupiter has just swallowed Saturn. And it doesn't stop there. Jupiter is on its way to swallow every planet in the solar system. How big would Jupiter get? What would you see from Earth? And would Jupiter get rings like Saturn? This is What If, and here's what would happen if Jupiter swallowed every planet in the solar system. Jupiter has swallowed a planet before. Around 4.5 billion years ago, a protoplanet slammed into the young Jupiter. The protoplanet was 10 times Earth's mass, made of rocky and icy material. Jupiter's core broke apart and denser material mixed with hydrogen and helium. A few billion years later, the heavy material settled back into the dense core that we see today. Now, swallowing a single planet is one thing, but could Jupiter eat up all 7? In this scenario, you're going to see the planets get swallowed from largest to smallest, although we're saving Earth for last. Jupiter's first victim would be Saturn. From Earth, you could see these gas giants as 2 bright stars. And if you were to look up at the night sky as Jupiter swallows Saturn, well, all you'd see is Jupiter getting super bright. But if you were closer to the action, you'd see complete chaos. Jupiter is only 3 times heavier than Saturn, so it would be swallowing a planet that's almost its size. First, their moons would collide, creating massive amounts of debris. Some moon remnants would rain down on Jupiter, and some of the debris would float in space. As Jupiter was crashing into Saturn, Jupiter's surface temperature would become hotter than the Sun's outer layer. Whatever remained of Saturn would mix in with Jupiter's atmosphere. They would become one. Now, swallowing Saturn would increase Jupiter's mass and gravity by 30%. Jupiter would also sport prominent new rings from the shattered moons. Next, it would envelop the two ice giants, Uranus and Neptune. The 27 moons of Uranus would collide with the rings of Jupiter, adding to the floating debris. Uranus has an icy core made of water, methane, and ammonia, but Neptune's inner core is rocky. Regardless, both cores would melt as the planets crashed into Jupiter. Now, Jupiter would be almost 40% heavier, and it would head towards its first rocky planetary snacks. The rocky planets, Venus and Mars, wouldn't even make it to Jupiter's core. They'd burn up in Jupiter's atmosphere as if they were mere asteroids. Then, we'd see our last planetary neighbor disappear inside this bulked-up Jupiter. Mercury is even smaller than Jupiter's largest moon, Ganymede, so it would get ripped apart by Jupiter's rings, adding to the speedy debris. Now, only Earth and Jupiter would be left, and Earth would be in big trouble. But how would Jupiter go about swallowing our planet? Even in its normal state, without swallowing 6 planets, Jupiter's gravitational force affects Earth. Yeah, every 405,000 years, the pull of Jupiter and Venus makes Earth's orbit wobble. It causes hotter summers, colder winters, and more rainfall in the tropics. And now, Jupiter's gravitational pull would be over 40% stronger. But Jupiter's pull would still be no match for the Sun's gravitational force, so Jupiter would have to come for Earth just like it swallowed all the other planets in our solar system. Jupiter doesn't have a hard surface like the rocky planets. You could say Jupiter is a big, dense ball of gas. Its surface is defined as the point where its atmospheric pressure is equal to Earth's. Well, so could Earth simply pass through? No. Just like the rest of the planets, Earth and all life on it would be toast. First, we'd be bombarded by asteroids while passing through Jupiter's rings. I doubt anyone would survive this, but if they did, they would see the Earth igniting as it enters Jupiter's atmosphere. Jupiter is so massive that even if it were to swallow its 7 planetary neighbors, it wouldn't even double in size. As our biggest planet, Jupiter's immense presence helps to hold our solar system together. Its massive size and gravitational pull give it a dense atmosphere, a turbulent mix of hydrogen and helium. This results in unfathomable storms that have lasted for centuries. But let's imagine Jupiter came in closer contact with an even bigger object, the Sun. Would the Sun strip Jupiter of its atmosphere? And if so, what would that look like? What makes Jupiter such a unique gas giant? What is Jupiter's core made of? And what are hot Jupiters and hot Neptunes? This is What If, and here's what would happen if Jupiter lost its atmosphere. Jupiter's gravity is nearly 2.5 times stronger than Earth's, making it difficult for any atmosphere to escape. Thankfully, it also keeps out incoming asteroids. Jupiter has dense layers of gas consisting of 90% hydrogen, 10% helium, and a few traces of ammonia, sulfur, methane, and water vapor. It has an extended, dilute core made up of rocky material, ice, hydrogen, and helium. And unlike Earth, there's no sharp transition between Jupiter's core and its outer atmosphere. Scientists believe the core could have been formed from a head-on collision about 4.5 billion years ago between Jupiter and a planetary embryo 10 times more massive than Earth. A recent discovery of the exoplanet LTT 9779b by NASA's Transiting Exoplanet Survey Satellite, or TESS, may unlock even more answers to Jupiter's formation and possible destruction. NASA's discovery of the Jupiter-like exoplanet LTT 9779b has captivated the scientific community with its miraculously close orbit to its star. While Jupiter maintains a safe distance from the Sun, LTT 9779b is so close to its star that its atmosphere is evaporating at an accelerating pace. What makes it so unique is that close orbits are usually reserved for Earth-like or Jupiter-like planets, but LTT 9779b is somewhere in between, closer in scale to Neptune. With an ultra-hot temperature of about 1725 degrees, astronomers have unimaginatively named it Hot Neptune. Oh yeah, clever guys. Personally, I would have gone with the Blue Inferno. Astronomers believe that the exoplanet may have formed further away from its star and has slowly made its way closer and closer over millions of years. The closer it gets to its star, more and more of its atmosphere evaporates, giving it a squished, almost football-like appearance. American football. LTT 977b is losing its atmosphere because it has surpassed the critical distance where a planet begins to lose mass due to the tidal forces caused by another celestial body. This is known as the Roche limit. Luckily, Jupiter is far enough away from the Sun to maintain its mass. And its moons are far enough away from Jupiter not to be absorbed. So, why do most gas giants, like Jupiter, reside so far away from the Sun? Well, all planets were built in the same way. The Sun's gravity pulled dust and rock together, while the Sun burned off gases such as hydrogen and helium in the inner solar system. The outer parts stayed cool. This provided just the right temperature and materials for planets to form atmospheres. Some astronomers have suggested that there are Earth-like planets out there that may have once been gas giants. For unknown reasons, they have entered the Roche limit and lost all their atmosphere, becoming hot Earths. There are even hot Jupiters out there, like the exoplanet 51 Peg, which is similar in scale and orbits its star every 4 days. For Jupiter to start losing its atmosphere, it would need to come closer to the Sun and surpass its Roche limit. While this isn't likely to happen, if Jupiter got nudged toward the Sun, it would slowly start to spiral closer and closer to it. It would lose more mass with each orbit. Eventually, it would get so close that it would orbit the Sun in a single day, 88 times faster than Mercury's orbit. The Sun's strong solar winds would give Jupiter a tail of gas like a comet. This enormous amount of gas could cloud the light of many stars, making our night sky much less impressive. During this slow process, Jupiter would be squished and eventually lose its atmosphere. It would be left looking like a barren, rocky planet, like Mercury, but about the size of 11 Earths. As we continue to explore and discover more exoplanets like hot Jupiters or
hot Neptunes, scientists can better understand planet formation, which is vital to our understanding of the universe. The Earth has been hurtling towards Jupiter for the past 242 days. And now, it's about to make impact. Now, we're so close to the giant planet that it's the only thing that fills our sky. Ground temperatures on Earth are rising uncontrollably. Our atmosphere is igniting into flames, and the scientific community is scrambling to provide answers. What will happen when the two planets collide? Is there any chance that we could pass right through the gas planet? And how would this collision transform Jupiter forever? This is What If? And here's what would happen if Jupiter swallowed Earth. One way that scientists could find answers would be by looking into the past, because this wouldn't be the first time that Jupiter has collided with another planet. Nearly 4.5 billion years ago, Jupiter was involved in a violent collision with a planet 10 times the mass of the Earth. In that case, the collision completely transformed Jupiter's core, but what happened to the other planet? And what can that tell us about our own planet's chances of surviving a crash into the gas giant? To get some answers, let's travel back to 4.5 billion years ago, when Jupiter was just a young planet trying to find its place in the universe. Back then, Jupiter's gravitational pull became 30 times more powerful in just a fraction of a million years. This destabilized the orbits of nearby infant planets and caused some of them to crash into Jupiter. It's believed that one such planet was 10 times the mass of Earth, and it was mainly a silicate ice core. The planet hit Jupiter with an impact speed of 46 kilometers per second. Jupiter only lost a small amount of mass from the collision, but its original core was completely changed. Before the impact, Jupiter had a dense central core of heavy elements, and the rest of the planet was made up of hydrogen and helium. After the impact, the infant planet's silicate ice core merged with Jupiter's, causing Jupiter's core to become diluted. The heavy elements spread out and mixed with the outer layers of Jupiter. While this collision was a defining moment for Jupiter, it meant the end of the road for the other planet. So, what are the odds that the Earth's fate would be any different? Well, let's find out. The Earth orbits around the Sun at an average velocity of 29.78 kilometers per second. At this speed, if the Earth were to just leave its orbit around the Sun and head straight for Jupiter, it would take about 242 days to get there. Throughout our journey, Jupiter would shine like a bright star, growing bigger day by day, hour by hour. By day 6, Jupiter would appear as bright as our moon. Soon, we would start to notice our daylight becoming dimmer. We'll only get about 50% of our normal sunlight when we reach Mars's orbit. Luckily for us, the Earth's atmosphere would act as a buffer, so we wouldn't experience the cold right away, but that will only last a while, so you'll need to invest in some heavy-duty winter gear. To put it in perspective, Mars has a surface temperature of minus 63 degrees. So that's basically what we'd have to look forward to. Once we speed through Mars's orbit, we'll pass through the asteroid belt. We'll get to see beautiful meteor showers lighting up the sky, but we'll also be at risk with colliding with some of those meteors, so let's keep moving. After 242 days of traveling through our solar system, we would finally reach our destination, Jupiter. As the Earth is pulled into Jupiter, our planet's velocity could increase until it reaches 60 kilometers per second. That's 250 times faster than an airplane flies, so you'll want to hold on tight. Oh, and did we mention that Jupiter has 79 confirmed moons orbiting it at all times? So there's a serious risk that we could collide with any of them as the Earth is pulled in closer. And if we do happen to avoid all those moons, things would only get worse. As we crash into Jupiter, both planets' atmospheres will be compressed, rapidly increasing the temperature and essentially setting the air on fire. But at least we won't have to worry about colliding with Jupiter's core, because we'll never make it there. Our planet is too small and would burn up in the atmosphere before that ever happens. But this would have a huge impact on Jupiter, as the Earth's remains would completely mix into its atmosphere. So if you ever notice our planet going off course and heading towards Jupiter, you might want to jump off along the way. Maybe right as we pass over Mars. This is What If, and here's what would happen if the Sun exploded tomorrow. That star at the center of our solar system, that super hot ball of plasma that gives us heat and energy, and amazing complexions. Well, it's a ticking time bomb. The Sun is 4.5 billion years old, but it's only expected to last about another 5 billion years. After that, the Sun will expand, becoming a red giant. Then, it will shrink to become a white dwarf, a dying star, cooling for the next several billion years. Of course, we'll all be long gone before any of that happens, but still, can you imagine what it would be like to watch the Sun blow up before your very eyes? With a name like supernova, you'd think that a solar explosion would be the most magnificent fireworks show the world has ever seen. But in reality, you likely wouldn't see anything. The Sun is 150 million kilometers away from Earth, and it takes 8 minutes for light from the Sun to reach us. And while that may seem super far away, in supernova terms, we don't stand a chance. For Earth to be completely safe from a supernova, we'd need to be at least 50 to 100 light years away. But the good news is that if the Sun were to explode tomorrow, the resulting shockwave wouldn't be strong enough to destroy the whole Earth. Only the side facing the Sun would boil away instantly. The lucky other half would experience a rise in temperature that would be 15 times hotter than the Sun's current surface temperature, and permanent darkness. And without the Sun's mass keeping us in orbit, Earth would likely start floating off into space, while its remaining inhabitants desperately struggle to stay alive. There is a chance that our planet could lock into orbit around another star that might provide the same light and heat as our Sun, but by the time that happened, we'd all be long gone. If we knew in advance the day that the Sun would explode, then we could buy ourselves as many as 1,000 years of time, provided we had the resources to sustain ourselves for that long. And we could. Just a few meters below the ground you walk on, the Earth is maintaining a temperature of about 17 degrees. So if we had enough time to prepare, civilization could continue to live by moving underground into a huge network of fortified bunkers. Within a week after the explosion, the surface temperature on Earth would drop to minus 18 degrees. Within a year, temperatures would plummet to about minus 73 degrees. At this point, the oceans would begin to freeze from the top down. Within 1,000 years, Earth's atmosphere would freeze and collapse, leaving anything left on the surface exposed to cosmic radiation and meteor impacts. Hopefully, by that point, we'd have found ourselves a new home. The good news is that if the sun were to explode, and it will eventually happen, it wouldn't happen overnight. When the sun does die, it will be a long, slow, arduous process taking place over billions of years. The sun will get hotter and brighter, and it will start to expand. During this process, it will lose its outer layers to the cosmos, leading to the creation of other stars and planets, in the same way that the violent burst of the Big Bang created Earth. Who knows? Maybe new life could form. Can you imagine another Earth? A new humanoid species? It's hard to predict how our galaxy might look billions of years from now, and it's especially hard to imagine our solar system without the great golden anchor that keeps us all together. But one day, in the very, very distant future, the sun will expand, and then it will shrink, maybe leaving room for a new star to take its place. Trees are falling, ecosystems are collapsing, and our infrastructure is crumbling. Crops are failing, and water is scarce. Earth is becoming a dead planet. On the plus side, there's never been a better time to buy property. But who can think about real estate when they can't leave their own home, let alone get out of bed, let alone breathe? This is What If, and here's what would happen if the Earth was as big as the sun. Everyone knows the sun is big. I mean, look at it. And that's just how big it looks from about 150 million kilometers away. Just imagine what it would look like if you were standing next to it. Never mind. The sun accounts for 98% of the mass of our entire solar system. And compared to the densest planet, which is our very own planet Earth, the sun is more than 1,000,000 times more massive. In fact, it would take roughly 1,300,000 planet Earths to fill the entire sun. But what if it only took one? Earth would be a very different place if it were the same size as the sun. Just imagine our whole planet's topography being stretched out. Continents would expand, providing much-needed relief in places where overpopulation inhibits the quality of life, and owning a nice plot of land might actually be more affordable than it is on today's planet Earth. But now we'd also have to consider that every body of water on our planet would have more area to cover. This means that lakes, rivers, and even the oceans would be shallower, making them more susceptible to evaporation and potentially drying out. Marine life would undoubtedly suffer since shallower water would gain more heat from the sun, jeopardizing sea creatures that need colder water to survive. With other smaller water sources beginning to dry up, wildlife on land might have to relocate or travel much farther for fresh water, which would also put them at risk. Us humans would be in an equally precarious position. Not only would we probably start fighting over the limited fresh water that's available, our food crop yields would also start shrinking. Food crops need a certain amount of soil to grow in and to absorb the nutrients they need. If our world was as big as the sun, then, like the water, our soil would have to be spread out to cover a much larger space. Less soil would mean less food, while the demand for food would stay the same. There's also another issue that we haven't considered, which, when we factor it in, makes life on Earth pretty much impossible. Earth being the same size as the sun is hard enough to imagine, but when you consider a sun-sized Earth having the same mass as the sun, it doesn't only jeopardize our survival, it disrupts our entire solar system. Think about it. With the Earth as big as the sun, you'd pretty much lose the moon either way. But if a planet has more mass, it will also have a stronger gravitational pull. In this case, gravity on Earth would be 28 times as strong as it is now. we'll get to how this affects you in a moment, but first, let's look at the bigger picture. The reason why our solar system moves the way it does now is because the Sun's mass is so great. Its gravitational pull forces other planets into its orbit. The Sun currently has 98% of the mass in our entire solar system, but now the Sun and the Earth would each have 49% of the mass in our solar system. Would this result in some sort of binary system in which the Sun and the Earth orbited each other? How would this new rivalry affect the orbits of the other planets in our solar system? And would a significantly higher gravitational pull mean that Earth would get hit by a lot more asteroids? Well, there'd be a lot more to worry about than just asteroids. Our satellites would also probably crash down to Earth, while buildings and bridges would crumble and collapse under the increased gravitational pressure. Only thick trees that were low to the ground would remain standing, but it's unlikely that much else could shoulder the added weight. You would be significantly heavier, and you probably wouldn't be able to walk anywhere. Think about it. If you weigh 50 kilograms on Earth right now, it would feel like you weighed 1,400 kilograms on a sun-sized Earth. The cruel twist is that as gravity increases, time would slow down. So you might be able to live longer, but it would probably be a long life spent lying in bed with aches and pains. Luckily, we can wake up from this nightmare because the Earth will never be as big as the Sun. In fact, our planet is actually getting smaller. Our atmosphere leaks, and so we end up losing several hundred tons of mass to space every day. So take a nice deep breath and be glad it's that easy. It's not always a good idea to mess with proportions, and bigger definitely doesn't always mean better. With the vastness of the universe, everything in it seems so spread out. But some objects are closer than you might realize. Every now and then, a random interstellar asteroid passes through the Oort cloud, the wall of icy debris at the very edge of our solar system. But what if a rogue star unceremoniously rampaged right through the Oort cloud? How bad would it be if it brought other planets along for the ride? This is What If, and here's what would happen if another star entered our solar system. What if I told you that a rogue star has already invaded our Sun's territory? A dim red dwarf dubbed Schultz's star crossed the Oort cloud some 70,000 years ago. It passed just 0.8 light years away from the Sun, and then it made a turn in the opposite direction without causing much trouble. Right now, another rogue star is moving in our direction. Gliese 710 has about 60% of the mass of our Sun, and it's traveling across the galaxy at 52,000 kilometers per hour. How long do we have before this stellar invader makes its way into the solar system? And what will happen when it does? If another star rampaged through the solar system, the extent of the chaos it would cause would depend on the size of that star and its trajectory. When Schultz's star passed through the Oort cloud, it came 5 times closer than Proxima Centauri, the closest star to our solar system. Schultz's star didn't have much effect on Earth, although around the same time, early humans almost got wiped out by a massive volcanic eruption. But that was pure coincidence, right? In any case, before Schultz's star turned away minding its own business, it did change the orbits of about 10% of comets and asteroids in the solar system. But what if it was a bigger incoming star, like Gliese 710, that's currently making its way towards us? Gliese 710 isn't scheduled to make its first contact with the solar system for another 1.29 million years. But when it does, it could shake the Earth quite a bit. At first, the rogue star would make its way into the Oort cloud. At this point, it wouldn't affect us directly, but it would send massive chunks of space rock showering the solar system. About 170 meteors, comets, and asteroids would hit the Earth every day. That's 10 times more than what's bombarding our planet right now. Comets and meteors might not seem like a big deal since most of them are small and they often fall in unpopulated regions, but back in 1908 in Siberia, it only took one asteroid to obliterate 80,000 trees and blow out windows 60 kilometers away. If the same asteroid were to hit New York, the entire city would be in the impact zone. All that if just a single star, smaller than the Sun, slightly made it just inside our solar system. What would a more massive star do? Well, if a star larger than our Sun entered the Oort cloud, it would disrupt the orbital cycle for every planet it passed. Since there are such large distances within the solar system, this disruption would happen over the span of millions of years. It would be an almost slow-motion chaos of debris waves. It might even set some planets on a collision course. And that's not the worst it could get. If the rogue star had other planets and moons following it, our solar system would turn into a galactic soup with stars and planets being pulled out of their orbits. Massive collisions would create a rippling effect, disrupting planetary orbits even more. Eventually, the Earth would be knocked out of its orbit too, if it wasn't already destroyed by meteor storms and the remnants of other planets. Not to sound too dramatic, but there are estimates that 40,000 stars have entered the Oort cloud at some point in the history of the solar system, but they all came here on just visiting trips. Chances that any of those rogue stars will ever make it past the Oort cloud are close to zero. How much water would you need to extinguish the sun? How would we deliver such an enormous amount of water anyway? And would all that water even make it to the star? Wouldn't it evaporate before reaching the sun's burning flares? Whatever your plan is, be careful, because trying to put out the sun would only make it hotter. This is What If? And here's what would happen if we extinguished the sun. Before we dive into how things would go terribly wrong, let's talk about where we could, hypothetically, find all that water. I've got some ideas. How about the universe's largest ice cube? A gigantic space fire hose? Or an entire water world tossed into the sun? Okay, fine. Let's be a little more realistic. No giant ice cube will be passing our solar system anytime soon. That leaves us with one possible scenario. We'd have to sacrifice every single drop of water we have here on Earth. We would drain our oceans and deplete all the fresh water too. Then we'd build a very large fire hose and blast it at light speed towards the sun's core. And then... Wait, did I say there was just one option? I forgot about the possibility of using a water world. Leaving the Earth with no sun and no water seems a bit unreasonable. And we could avoid that ocean draining scenario if we found a way to throw an exoplanet into the sun. But not just any exoplanet. We'd be aiming for a real-life water world. And we just happen to know where to find it. Some 40 light-years from Earth, there's a planet primarily made of water with an atmosphere of steam. Scientists named it GJ1214b, but we'll call it the Water World. This planet is 2.7 times bigger than the Earth in diameter, and it weighs 7 times more than our planet. And it has much less rock and a lot more water than the Earth does. There would probably be enough water on the water world to put out the sun forever, but it wouldn't happen the way you might expect it to. If we were able to crash that water world into the sun, the first problem would be the water freezing in space. Same thing would happen if we could pull out a gigantic fire hose with all of the Earth's water and aim it at our star. The ice would continue shooting towards the sun, but it would face mass evaporation as soon as it hit the star's atmosphere. The water vapor would then break down to its basic ingredients, oxygen and hydrogen. And that's when something interesting would happen. The sun may seem like a huge fireball, but it's not exactly on fire. Inside its blazing core, the pressure is 340 billion times more than it is on Earth's surface. This immense pressure fuses hydrogen atoms together, making helium and giving off energy in the process. Since hydrogen acts like a fuel for our sun, pouring water on it would be like throwing gasoline on a fire. You'd see the sun turn bluish-white as it grew 6 times bigger. It would create an extreme heat wave across our planet, but at least we wouldn't be engulfed by the expanding sun, although there could be other consequences. We wouldn't be able to put out the sun with its own fuel, but if we fired enough water at it at the speed of light, it could break up the sun. The pressure inside it would drop, the hydrogen couldn't fuse together into helium, and that would shut the sun down. But with no sun to give us warmth and light, the Earth would turn into a frozen world. After just 1 year, Earth's temperature would drop below -73 degrees. Most of the plants and animals would be dead long before that. And what about us humans? Well, in the deepest parts of the oceans, geothermal vents could have kept us warm and supplied us with energy. But we just poured all of Earth's water into the sun, dooming ourselves to freeze. Lucky for us, the only thing in the universe that can do any substantial harm to the sun is the sun itself. And that would take billions of years to happen.
Imagine you were able to shrink the sun to the size of a basketball. At that point, the Earth would be reduced to the size of a sesame seed. That's how massive our star is. But what if this fiery ball of gas and plasma wasn't the biggest thing in our solar system? Would our planet still orbit the sun? Or would the sun rotate around the massive Earth? What would happen to our planetary neighbors? This is What If. And here's what would happen if the sun was smaller than the Earth. It would take the equivalent of 1.3 million Earths to fill up the volume of the sun. It's so big that it makes up over 99% of the mass of our entire solar system. It only looks small from Earth because it's 150 million kilometers away. If, hypothetically, the sun was smaller than the Earth would be uninhabitable. And the sun? Well, this massive star may no longer be a star. In the universe, size matters, and so does distance. It just so happens that the Earth is close enough to the sun that it doesn't freeze over like Mars. It's also far enough away that it doesn't get scorched like Venus. We're fortunate to be in the sun's habitable zone. This means that the size of our planet, the size of the sun, and the distance between the two of us is what's made it possible for life to evolve here on Earth. What would happen if the sun was smaller than our planet? A star's mass determines its color and temperature. Bigger stars are hotter and bluer, while smaller ones are cooler and redder. The sun is a white star, not as big as a supergiant, and not as small as a red dwarf star. You might think that by making it smaller in size, it would just turn into a red dwarf with a smaller habitable zone, but that's not the case. By definition, a star, whether it's a supergiant or a red dwarf, is only a star when there's thermonuclear fusion in its core. How small can stars get? Well, we haven't measured too many red dwarfs at this point, but the smallest one we came across has a mass of 10 Earths. That's very close to the theoretically necessary size of a star to sustain that fusion. Anything smaller than 10 Earths wouldn't be a star anymore, but rather a cold and dark stellar remnant. If, for any reason, the sun shrank smaller than the Earth, this shrunken sun wouldn't have the mass to create fusion and would burn out completely. Our solar system would lose its only star. Since the sun is the source of gravity that keeps us all in orbit, all planets, the Earth included, would float away into space in search of another anchor. That's no happy ending for life on Earth. Let's try this again. This time, let's make the Earth bigger than the sun, while the sun's size remains the same. Earth's mass would be at least 333,000 times bigger than it is now. A planet that big would generate enough heat and pressure in its core to become a star itself. Of course, there would be no life left on this hot star, but here's a cool thing. Our solar system would have not just one, but two suns. It would become a binary star system, with two stars orbiting around each other and planets circling them both. In either scenario, life on Earth would have no chance to survive. But life could possibly evolve on other planets, or even the Moon. About a third of all stellar systems we've found so far are binary or multiple ones. Some of them even have stable habitable zones.
A black hole is on a collision course with our sun. And there's nothing left for you to do except sit back and watch the destruction of our entire solar system. How exactly would this epic collision unfold? How would this black hole end up in our planetary neighborhood? And what would it be like to witness all this from Earth? This is What If, and here's what would happen if the sun collided with a black hole. A black hole is not much different than any other object that has mass, except it's dense, really dense. All the matter it possesses is compressed to an infinitely small point at its center, called a singularity. Most black holes are the remnants of massive stars. And just like the stars they used to be, black holes have a strong gravitational pull. The more matter compressed into its singularity, the stronger the gravity. There could be as many as 40 quintillion black holes in the observable universe. Many are located at the centers of their galaxies, like Sagittarius A star, the closest known black hole to us. It resides right in the center of the Milky Way. But black holes could also go rogue. After an extreme event like a collision between two galaxies, a black hole can break free and start to wander. There could be 12 of these rogue black holes in our galaxy alone, and one could be headed toward the sun right now. If a wandering black hole were headed toward our solar system, it would first reach the Oort cloud. That's the sphere of icy objects surrounding the solar system, 2 light years away from us. As soon as a black hole came too close, the icy bodies in this region would be ejected from their orbits. You wouldn't be able to see the black hole for yourself until it reached the ice giants, Neptune and Uranus. Looking through a powerful telescope, you could see the gases being pulled away from these planets. All the gases and dust torn from Neptune and Uranus would form a region around the black hole known as an accretion disk. This superheated collection of gas and dust would orbit the black hole, making it visible. As it continued on its destructive path, you'd witness Jupiter and Saturn meet a similar fate. You'd be able to see with your own naked eye these gas giants disappearing from our night sky. Rocky inner planets like Mars, Venus, and Mercury would also be sucked into the black hole and destroyed into nothingness as you watched in horror. Only Earth would be spared. Not really, of course. I just wouldn't want you to miss out on your front row ticket to the destruction of the solar system. As the black hole approached our sun, you might think it would swallow it in one blazing gulp. No, instead, the strong gravitational pull would begin to pull matter from the sun, just like a strand being pulled from a ball of yarn. Huge portions of gas would be ripped away from it, and they would spin around the black hole, joining the accretion disk formed by the gas and dust of all our neighboring planets. This tearing apart of the sun would keep going until our star no longer existed. What's left behind would be nothing more than a gas cloud. Only the very end of the tail of this cloud might be able to escape the fate of being pulled into the black hole. As the sun's matter was being absorbed, lethal amounts of ultraviolet and X-ray radiation would be released in fiery explosions. This radiation would be hurled right in your direction, back on Earth. You wouldn't know the ultimate fate of the sun for 8 minutes. That's how long the light would take to reach us, but instead of the light source of our solar system disappearing entirely right away, the black hole itself could become extremely bright. Possibly trillions of times brighter than the sun. And with the sun swallowed up, the stability of what's left in our solar system would be completely destroyed. An entirely new gravitational balance would need to be established. And in addition to all the lethal radiation raining down on Earth, extreme tidal forces would push and pull at the planet. This would cause massive earthquakes, volcanic eruptions, and tsunamis. Eventually, Earth would crack into pieces. Or maybe, in the best case scenario, unceremoniously ejected from the solar system. Well, the reality is you and everything on our planet would be pulled right into the accretion disk, along with all the other matter in our solar system. So now you'd have a new front row ticket to the inside of a black hole. Billions of years in the future, the sun will begin to die. And this is what our planet would look like. But what if we turn things up a notch or two? Let's upgrade our star from yellow to blue. How different would the world look? Could your body handle the increased heat? Or would all life on Earth die? This is What If. And here's what would happen if the sun was a blue star. Like any visible light, sunlight contains all the colors of the rainbow. But how we see a star, or any planet, depends on how hot the star is. The coolest stars in the universe have temperatures of about 1750 degrees and emit more red light, while the hottest stars have temperatures over 40,000 degrees and look bluer. Our sun has a surface temperature of 6,000 degrees, so it emits almost equal amounts of blue and red wavelengths. If you could see the sun from space, it would appear whitish. Hang on a second, the sun isn't yellow? Yeah, that's right. The sun only appears yellow to you because of Earth's nitrogen-rich atmosphere. Red light and yellow light have longer wavelengths and can reach your eyes easier. Blue light has a shorter wavelength and scatters more, giving the sky its blue color. But if our sun was a blue star, you'd never get to see a spectacular orange sunset again. Oh, and also you'd get fried instantly. Now, before making our sun blue, let's take a look at a couple of bright blue stars that we know of. On the cooler end of the blue star spectrum is Rigel, the brightest in the Orion constellation. Its surface temperature is about 11,000 degrees. While it's almost twice as hot as our sun, Rigel emits at least 40,000 times more energy. And Rigel's diameter is 79 times larger than our star. If our sun was that large, it would swallow Mercury, and temperatures on Earth would increase immensely. But why stop there? You could turn the dial up even further. If we imagine our sun on the higher end of the blue star spectrum, it could be like Eta Carinae. With surface temperatures of 40,000 degrees, this star is over 6 times hotter than the sun. But what's staggering is that Eta Carinae emits 1 million times more energy than our sun. If our sun was that hot, it would be 5 million times brighter than it is today. Violent ejections of plasma would scorch our planet regularly. And the sun would drench us in lethal amounts of UV radiation. There's no way you could survive the heat. If you stepped outside for just 1 second, it would be like stepping in an oven, only hotter. The blue sun would instantly burn all the tissues in your body to ashes and maybe even your bones. It would be game over for you. Just kidding, I wouldn't let you off the hook so easily. Okay, let's imagine that your body was we'd likely freeze up pretty quickly and die anyway. If there's one benefit, it's that all this chaos and destruction wouldn't last forever. Instead, it would end quite quickly. A star like Eta Carinae has a live fast, die young lifestyle. At its young age of about 3 million years, it's already nearing the end of its fuel supply. It could explode into a supernova sometime within the next 100,000 years. Our sun is about 4.5 billion years old, and scientists expect it to keep burning for another 7 billion years. So if we turned up the sun's heat, we'd be dooming our star and our planet to premature death. Not that many life forms would survive to see that day. The earliest life on our planet dates back to about 3.7 billion years ago. At that point, our sun was already 800 million years old. Back then, if the sun burned as hot and bright as Eta Carinae, it would have exploded as a supernova hundreds of millions of years before there was life anywhere nearby. So, our lives seem better with the sun burning at its current temperature.
The sun's core is shrinking. But as its core shrinks, the sun itself grows larger. And it will continue to grow until one day
it engulfs the Earth. How long can you survive? What will happen to the oceans? And will other planets be affected? This is What If, and here's what would happen if the Sun swallowed the Earth. Every 1 billion years, the Sun becomes 10% hotter. But here on What If, we're going to take billions of years and condense the action into 1 month. Get ready, because we're going to be moving really fast this time. Instead of 1 billion years, it would only take 4 days for the Sun to become 10% hotter. This means you'll see the Earth engulfed by the Sun in just 1 month. That is, if you're still around to witness the final event. On day 1, you'd be blissfully unaware of the tragedy about to befall Earth. Maybe it's a little hotter, but that's just weather. It happens. But by day 4, space agencies across the globe would be sounding the alarm bells. By this time, the Sun would be about 10% brighter and hotter. And while 10% doesn't sound like a lot, it will be the beginning of the end for us. As the Sun heats up, more and more water from Earth's surface will evaporate into the atmosphere. This will increase the greenhouse gas effect, causing global temperatures to skyrocket. All of a sudden, it will become very humid and very hot. But the Sun's high-energy light would bombard the atmosphere, splitting those water molecules into hydrogen and oxygen. Earth will begin to lose its water, and you won't be able to escape the lethal radiation on Earth's surface. If you want to survive, you'll have to go deep underground. But even under a protective layer of Earth's soil, you won't be safe for long. By day 16, the Sun would be almost 40% brighter. Our planet's oceans will boil, and there won't be any moisture left in the atmosphere. The beautiful, lush Earth that you grew up on will become a hot, dry, barren rock. Around day 20, the Sun would run out of hydrogen, so instead, it will start to burn helium in its core. The Sun is now a red giant star and would expand rapidly while losing its mass. The Sun's gravitational pull on Earth would be weakened, and our planet would begin to drift away from the expanding Sun. But not far enough. According to researchers Klaus-Peter Schroeder and Robert C. Smith, the Earth would only have moved about 0.0002 astronomical units. An astronomical unit is the distance between Earth and the Sun. While Earth is moving away from the encroaching Sun, the red giant would grow up to 1.2 astronomical units in radius. The Sun would be larger than Earth's orbit. It would swallow the planet whole. Once it's inside the Sun's atmosphere, Earth would collide with particles of gas and spiral inward. And Earth wouldn't be the only casualty of the expanding Sun. Mercury and Venus would be vaporized. The rings of Saturn would melt. Pluto would become much warmer. And if there is a liquid surface and a thick atmosphere on this distant dwarf planet, it might even become inhabitable. Unfortunately, 30 days doesn't give the human race enough time to prepare for such a catastrophic event. Welcome to your new landfill, a giant ball of burning gas that we call the Sun. With surface temperatures of 5,500 degrees, it could obliterate any type of trash we throw at it.
from pesky plastics to nuclear waste. And with everything we're launching into space these days, surely it wouldn't be too hard to send a little trash to the sun. But how much would it cost? What dangers would be involved? And why would it be easier to send a rocket right out of our solar system than it would be to get anything to the sun? This is What If, and here's what would happen if we sent our trash into the sun. Our planet is filling up with garbage. Yeah, at the rate we're going, by 2050, we'll be dealing with 12 billion tons of plastic sitting in landfills. That's 35,000 times the weight of the Empire State Building. Sure, it'd be nice to put it all in some giant rockets and blast it off, but there would be some serious risks involved. Like, what would happen if there was an accident while a rocket was in the Earth's atmosphere and all our trash and nuclear waste came raining back down on us?
The Sun is about 150 million kilometers away from Earth, so getting any trash there would be extremely expensive. To put it in perspective, the Ariane 5, a modern European rocket, has a payload capacity of 7,000 kilograms and costs approximately $200 million to launch into orbit. So to get all the planet's garbage headed off towards the Sun would take 168 million of these rockets just to remove our trash for 1 year. The price tag would be $33 trillion. And that's just the cost of getting the rockets into orbit around the Earth. If we wanted to get them from the Earth's orbit to the Sun, it would require 10 times more fuel. Okay, we get it. It would cost a lot of money, but that's just the beginning of our problems. You see, Earth moves around the Sun at 30 kilometers per second, in a direction that's basically always sideways relative to the Sun. If you were to launch a rocket from Earth straight towards the Sun, it wouldn't lose that sideways speed, and so it would miss its target. The only way we'd be able to get that rocket right into the Sun would be if we could cancel out all that sideways motion by slowing down the rocket by 30 kilometers per second. How tricky would that be? Well, put it this way, if we could speed up the rocket by 12 kilometers a second, it would have enough momentum to get out of the solar system. So let's simplify that a bit. To crash into the Sun, lose 30 kilometers per second. To get out of our solar system, gain 12 kilometers a second. Getting to the Sun takes 3 times the effort. For the sake of efficiency and fuel costs, it's better to go to the outer solar system, where the rocket's speed would be lower.
Then use a little booster juice to fire the engines enough that the rocket and its load of waste would fall into the Sun. Even if we were able to figure all this out and successfully deliver our garbage rocket directly to the Sun, it probably wouldn't be worth all the risks involved. The sky appears darker. The temperature is starting to drop. Our rivers are freezing, crops are covered in snow. People could go hungry. Is it just me, or is the sun dimming? Are we about to enter a solar minimum? Would this help fight global warming? But wait, why are NASA and Elon Musk so happy? This is What If, and here's what would happen if the sun dimmed down. The space rumors are true. We are at the beginning of a solar minimum cycle. And NASA expects it to be one of the weakest in the last 200 years. So, what is a solar minimum, and what's going to happen when it arrives?
speculate we are entering into another little ice age for the next few decades. Minus the woolly mammoths. Now, the flip side of this solar cycle isn't favorable either. When sunspot occurrences increase, it's called a solar maximum. During this time, the sun emits highly energized particles through space that are potentially dangerous to all electronics and power grids. An extreme solar storm could wipe out power for millions, if not billions, of people on Earth. In a flash, your phone's not working and Netflix is cutting out. The horror. Intense solar winds could also cause GPS and telecommunications satellites to malfunction. Would you even know how to get directions without a disembodied voice telling you which way to turn?
Recalculating.
Even worse, charged particles could potentially shut down essential life support systems and zap the electrical functions in any spacecraft that's home to astronauts, plummeting them to Earth. But what if the cycle permanently stopped at the next solar minimum? What if we dimmed the sun down? Could this cool the planet enough to reverse global warming? Well, totally understanding the sun is still a work in progress for the scientific community. Ideas about climate change and whether solar cycles might contribute either positively or negatively are plentiful. Unfortunately, according to NASA's Global Climate Change team, the news isn't really that glowing. They theorize that the warming caused by human-induced greenhouse gas emissions is 6 times greater than the possible decades-long cooling from a prolonged solar minimum. Even if the solar minimum were to last a century, global temperatures would still continue to rise. So, maybe we need to start looking for Earth 2.0 after all. But what does this mean in the short term for our space aspirations? And why is NASA so over the moon happy? Well, right now, NASA is working on the Artemis Lunar Exploration Program. This will put astronauts back on the moon by the year 2024, so think of using the solar cycles as predicting space weather. If you're sending anyone or anything into space, you want the conditions to be as ideal as possible. No surprises.
Banana!
Good space weather equals low levels of solar activity and radiation. If we can accurately forecast these conditions, even years ahead, we can better predict when the best time to safely send our astronauts into space might be. With this insight, we could also safeguard and prepare humanity for the harmful effects of high solar activity. At the very least, we could secure our vulnerable power grid during this time. Continued research into the relationship we have with our star and the rest of our solar system would be a huge help for us on Earth.
Humanity's nuclear arsenal is capable of destroying all life on Earth, over and over and over. Maybe it's time we dumped it far away. Now, we might want to inhabit other planets in the future, so how about our closest star? How many nukes could we throw at the sun? What would be the price tag for this mission? And could we accidentally destroy our only source of daylight? This is What If, and here's what would happen if we nuked the sun. The sun is mainly made of hydrogen and helium. The temperatures and pressures at its center are extremely high. So high that the hydrogen atoms fuse together and become helium. That process releases enormous amounts of energy that powers the sun. It's known as fusion. And you know what else uses fusion to power up? Yeah, that's right. Most modern nuclear weapons get their destructive energy from fusing hydrogen isotopes. This is why they're often called hydrogen bombs or fusion bombs. Around 5 billion years from now, the sun will run out of hydrogen and die. A dead sun is terrible news for Earth because we will die along with the star. Now, if humans managed to stick around for that long, we would be scrambling for ways to keep the sun fueled and running. And if we were also still interested in getting rid of our destructive hydrogen fusion bombs, could we nuke the sun and power it back to life? Well, first things first, we would need to gather each and every single nuke on the planet. This wouldn't be easy since the 9 countries that are known to possess nukes are extremely suspicious of each other. But if the other option is the guaranteed death of our only sun, they could be willing to give up their weapons of mass destruction for the cause.
Take my gun from me.
How big is humanity's arsenal, you might ask? Well, at least 13,000 nuclear bombs big, each of them with the explosive power of at least 100 kilotons of dynamite. The United States alone is estimated to have 650 bombs that are 60 times more powerful than the nuclear bomb dropped on Nagasaki during World War II. If you were overseeing this explosive operation, you would need to be extremely careful. After all, you definitely wouldn't want to have a surprise detonation. If every one of these fusion bombs went off, the explosion would lead to so much debris being injected into the atmosphere that it would trigger a nuclear winter. That's because sunlight would be unable to reach the Earth's surface. Cue the worldwide below freezing temperatures, ecosystems collapsing, and nuclear fallout. This accident would devastate all living beings, humans and animals alike. In trying to save the sun, humanity could block itself from all of its warm rays. Ironic, isn't it? So yeah, you'd need to handle with care. You'd also have to sharpen your fundraising skills. If a modern nuke has a mass close to the one dropped on Nagasaki, sending it to space would cost around $170 billion. And that's just for one bomb out of the 13,000. It's fair to say the whole world economy would need to bend and break in order to subsidize the survival of the sun. And humanity. Even if you did come up with the cash, there are far hotter challenges ahead. Like, how do you build a spaceship that doesn't melt as it approaches the sun? The closest a spacecraft has come to our star is 8.5 million kilometers. Even at that distance, it still had to endure temperatures of 1,377 degrees Celsius. Only thanks to a thermal shield made up of carbon composite material was it able to withstand the scorching heat. However we send our hydrogen bombs into space, it will have to incorporate a much improved version of this protection system. So add that to the bill. And there would still be a mountain of remaining technical obstacles, like finding the safest location to launch the nukes into space, or developing the technology that will allow us to monitor and control them from such a massive distance. But let's say you manage to do it. All our nukes are in orbit and within launching distance to the sun. This is it. You send the order to fire all the hydrogen bombs into our hydrogen-fueled star. Now, you wait to see how it begins to recharge. Just a little longer. And nothing seems to happen. The anchor of our solar system continues to die. But how? Well, as colossal as the power of our 13,000 nukes might seem, this punch is nothing compared to what the sun is packing. Right now, our star emits over 70 million times more energy per second than
all of our nuclear weapons combined. Even if it were running out of hydrogen to fuse into helium, throwing our hydrogen bombs at it to feed it would be like throwing a box of matches into a forest fire. You'd barely make a dent in the blaze. Yeah, that's a bummer, but at least you didn't destroy what little remains of our decaying sun. If that was your intent, you'd need something with a lot more firepower. Meet the antimatter bomb. When the Big Bang created the universe, it did so with an equal amount of matter and antimatter. Matter is what you, the Earth, the Sun, and most things are made of. Antimatter, on the other hand, is composed of subatomic particles with properties opposite to those of normal matter. Put a little simpler, it's the inverse of matter. When a particle of matter collides with an antiparticle of antimatter, they annihilate each other in a flash of energy. If enough of those two camps came in contact with each other, it would lead to a massive explosion, also known as an antimatter bomb. But here's the catch. Antimatter is incredibly rare. If you pooled together all the antimatter on the planet, you'd end up with only around 20 nanograms. A single nanogram is only 1/1000th of a gram. That is so little that even if it were combined with matter, you wouldn't even have enough energy to boil a cup of tea. Now, you could produce more antimatter, but that would cost you at least $2.7 quadrillion for just 1 gram. And remember, we're here to save the sun, not destroy it.
Oh, did you see that? Oh my god. Look at
Is it a meteor shower? Space debris? No, it's something much, much worse. Our nearest neighbor is a full moon no more. The moon exploded and splintered into millions of fragments. Enormous lunar rocks are hurtling toward Earth. Could this wipe us off the face of the planet? How could the moon explode in the first place? And if we do survive, how would losing the moon change life as we know it? This is What If? And here's what would happen if the moon exploded. Okay, so how on earth did the moon blow up? A blast mining operation gone wrong? A nuclear blast? A collision with a rogue planet? Whatever caused this catastrophe, you'd have to be packing some serious firepower to blow up the moon.
Guns. Lots of guns.
The largest nuclear bomb ever built, the Tsar Bomba, had the energy of over 57 million tons of TNT. Think that's strong enough? It's just a drop in the ocean compared to the amount of force you'd need to blow up the moon. You'd need the power of over 600 billion Tsar Bombas to destroy the moon. With anything less than that, the moon would just crack into pieces, and its gravity would pull it back together again. But if someone, or something, managed to explode the moon, it would spell bad news for us. The moon debris would scatter across the solar system, some into the abyss of outer space, and some headed straight for Earth. Earth's gravitational pull would immediately start to attract the moon rocks. As the moon's remains start to pick up speed, they would come crashing down into the atmosphere. Luckily, most of the smaller debris would burn up before it reaches us. Any larger pieces that got through would be traveling much slower than a similar-sized asteroid. The damage they'd cause wouldn't amount to much. But is it just me, or is it getting a little hot in here? The moon chunks aren't causing much damage, but the endless barrage of debris on our atmosphere would start to heat up the Earth. The whole world would start to get hotter and hotter, eventually getting to the point of incinerating all life. Talk about a bad way to go. Oh, and if you're thinking about trying to evacuate Earth, you better do it as soon as possible. The moon debris, combined with all the satellites it would destroy in space, would make any trip out nearly impossible. But what if you did manage to get out of Dodge or hunker down in the deepest parts of the Earth? What would life be like in the aftermath? Well, for some of us, it wouldn't get any cooler. The moon helps stabilize the Earth's axial tilt. It's what gives us seasons. With a new tilt, some parts of the Earth could be constantly exposed to the sun. In the worst case, the polar regions could start rapidly melting, raising sea levels and drowning out parts of the world. As the debris settles, the skies could look a little different. The remaining moon rock might cluster around the Earth, forming a giant ring like Saturn. But don't stop and stare too long. Every once in a while, some of the debris could rain down onto the Earth. Over billions of years, the moon's gravitational pull slowed down the Earth's rotation, giving us our 24-hour days. Without the moon, the Earth would start to rotate faster and faster. We'd have shorter days and stronger winds. Birds and insects would have a tough time surviving the harsh winds. Not only that, ocean tides would start to die down into tiny little waves. The moon's gravity helps create tides on Earth. Bummed out that you can't rip some gnarly waves anymore? Well, dude, there'll be a much bigger problem. It would wipe out all of the sea creatures that rely on the tides and ocean currents for survival. Our whole world would be literally flipped upside down. The Earth would burn up. Our days would be shorter, and the moon wouldn't be there to light up the night sky. Imagine if one day you looked up into the night sky and saw Mars or Saturn, where the moon was supposed to be. That would sure turn our Earth into an alien world. And not just because of the new view. How would replacing the moon change the Earth's orbit? What planet could we safely replace our moon with? And what planet would be the most disastrous? This is What If, and here's what would happen if another planet replaced our moon. We can thank the moon for predictable weather, ocean currents, and the circulation of important nutrients. The moon also helps stabilize the Earth's tilt. Take away the moon, and the Earth would go wobbling all over the place, and it would cause what I can only describe as climate change on steroids. But we wouldn't just let the moon take a day off. We would find it a replacement from another part of our solar system. So, what would happen if we swapped our moon with a planet that is 41 times its size? Before we get to that dramatic part, let's talk about Pluto. Pluto wouldn't look much different than our current moon. It would be smaller though, and this wouldn't be good for Earth. That's because Pluto's gravitational pull would be weaker than that of the moon. Earth would begin wobbling all over the place, and it would result in dramatic climate change. All sorts of natural disasters ruining your day. The moon's gravitational pull is responsible for our daily ocean tides. Because Pluto is smaller than our moon, our ocean tides would become weaker. This would devastate important ecosystems. Well, how about a planet that is slightly larger than our moon? Mercury would look exactly like our moon with its dark gray surface and asteroid craters.
And it's only 1.5 times the size, so its impact on our tidal systems and climate wouldn't be as disastrous. Out of all the planets in our solar system, Mercury would be the safest one to replace our moon. But I can't say that about Mars. Having the red planet in our night sky would be quite a sight. All the iron oxide on its surface would glow red. No more white moonlight shining through your window at night. Instead, everything would be bathed in an eerie red. Mars's stronger gravitational pull would make tsunamis smaller, but it would make normal waves massive. And because Mars would create stronger tidal forces, Earth's rotation would slow down. The days on Earth would become longer. I hope we'd still keep a 40-hour work week, because a 16-hour workday doesn't sound that great. Moving on. With Venus in our night sky, we might never experience darkness. Venus is the brightest planet in our solar system. It would reflect 60% more light than the moon. And because it's 3.5 times the size of the moon, it would force the Earth into a binary system. Earth and Venus would rotate each other. It would be beautiful and disastrous. Simulations of a binary system usually end up with planets colliding or merging. Neptune and Uranus are both ice giants and are similar in size. A huge portion of our sky would be taken up with a blue-green planet. Only Uranus would also stink horribly. No wonder this fart-smelling planet got such a name. Since both Uranus and Neptune are 14 to 15 times the size of the moon, their impact on Earth's rotation and tidal systems would be drastic. Beach houses would have to be built up on cliffs, far enough away from the reach of enormous waves. Now, seeing Saturn up in the night sky has to be my favorite. Its pale yellow color and ring system would be stunning, but there would be some complications. Because Saturn is so large, the Earth would quickly become its moon. And if Earth orbited around Saturn, it simply wouldn't be the Earth as we know today. Finally, moving on to the big guy, Jupiter. At 41 times the size of the moon, you wouldn't even be able to see the north and south poles of the gas giant. Similar to the deal with Saturn, Earth would become Jupiter's moon. Only it would get worse. Because Jupiter is so massive, the side of the Earth that's closest to Jupiter would experience a stronger gravitational pull than the opposite side. This would distort the shape of the Earth. All this pulling apart would create frequent volcanic eruptions and violent earthquakes. Jupiter's gravitational pull would tear the Earth apart. So enjoy the view while it lasts. The moon's surface is made up of long-dead volcanoes and impact craters from asteroids. But have you ever wondered what might be inside it? We could find out one day by digging a tunnel through the moon. How long would this take? What mysteries would we find inside? And how would gravity affect our dig? This is What If, and here's what would happen if we dug a tunnel through the moon. Unlike the Earth's layers, we don't know much about what's inside our moon. But we do know to get through it, you'd need to dig over 3,000 kilometers. And with today's technology, doing something like this would take about 1,300 years. But what if we managed to fast forward this with more advanced technology? What would happen then? To start our journey through the moon, we'd first want to choose an area that would give us a head start. The best choice here would be the South Pole Aitken Basin. This is a massive basin that's 8 kilometers deep. For comparison, the deepest hole on Earth is 12.2 kilometers, so this would save us a lot of time. Now, it's time to start digging. The first layer you'd need to worry about would be the moon's regolith, also known as the moon's outer crust. It may not seem like it at first, but this layer is surprisingly dangerous. Regolith is billions of years of crushed asteroids and moon dust. It's razor sharp and very fine, and can easily get into your suit and your drill, which will wear them down over time. And make sure you don't accidentally inhale any of this stuff, as it can cause lung cancer. You'll be digging through the regolith layer for up to 15 meters until you reach the lunar crust. This layer is made up of bedrock, and it's where you might make some money, since rocks in the crust contain lots of titanium and aluminum. You'll also be able to find iron, calcium, and magnesium. We could either bring these back to Earth or use them to help us colonize the moon. This layer is about 100 kilometers deep. Once you're through it, you'll then have to deal with the lithosphere. This layer used to be magma that would supply the moon's volcanoes, but thankfully it's cooled and is now solid. What we'd be less thankful for is that this layer is nearly 1,000 kilometers deep, so you'd keep drilling and drilling and drilling and drilling until you've finally reached the asthenosphere. What's different here is that this layer is made up of molten lava. At this point, your journey would definitely be over, as you'll be facing temperatures of up to 1,500 degrees. But we'll give you a special suit to help you survive this. Oh, and a special drill, too. Now, you wouldn't be drilling at this point. Instead, you'd be trying to swim your way through this magma. And as you get past this, you'll be met with another liquid. But this time, it will be liquid iron, which is the outer layer of the moon's core. Its radius is roughly 330 kilometers, so let's hope your suit can still withstand the immense heat. And as you drill your way through these thousands of kilometers, you'll notice that the gravity has been changing. As you reach the center of the moon, the gravity will reach zero and you'll be completely weightless, floating in the moon's inner core made of solid iron. So, now that you've reached the center, it's time to make your way back out. Through the outer core, out through the asthenosphere, then the lithosphere, inner crust, and finally the regolith layer. And drilling through wouldn't take as long as it did the first time. That's because the inner crust is about 40 kilometers thinner on this side of the moon, which is the side that faces the Earth. Digging through the moon has some benefits, but overall it wouldn't be worth it. After all, this project would take 1,300 years, and who wants to wait that long?
Alright, I think it's time for a change-up. Let's do a little spring cleaning and redecorate our solar system. Now, I know you're a big fan of the moon, but it's so last season. Let's get something fresh, something snazzier. How about Europa?
That I love. I absolutely love.
I know. The moon is a classic, but Europa could be a heck of an upgrade. Oh, and before you ask, the trade was mutual. The moon is just fine. So, we'll just moon swap with Jupiter. What's the worst that can happen? What secrets does Europa have in store for us? Would Europa be the perfect addition to our night sky? Or did we mess up really badly? This is What If, And here's what would happen if Europa was Earth's moon. Europa is one of Jupiter's 79 moons, so I don't think they'll mind if we borrow it. Covered by a thick layer of ice, with water beneath its surface, Europa is the 6th largest moon in our solar system. Because of its icy surface, Europa reflects a lot of sunlight, making it very, very bright. About 5.5 times brighter than our moon, to be exact. And to sweeten the deal, Europa has 3 essentials for supporting life, namely water, chemistry, and energy. Europa's water dissolves nutrients so they can be eaten by organisms. This means that our new moon can be used to transport chemicals within living cells. Plus, if we moved Europa to our current moon's spot, it would then be millions of kilometers closer to the sun. Sunlight might just be the one missing ingredient that's been impeding any life there from developing further. So, if we relocate Europa, we may eventually have some new neighbors. So, are you sold yet? Huh? You're not? Well, I've already filled out the real estate paperwork, so we're just gonna go ahead and do the swap. So, imagine looking up at the night sky and seeing, well, everything. Europa would light up the night sky and be a breathtaking sight. To make things even better, there would be no negative consequences at all. Okay, you copy. Look, I'm really not good with this whole real estate thing, so I'm gonna come clean with you. The first inconvenience you're going to have is trouble sleeping. Imagine a floodlight coming through your bedroom window. Maybe you could just get some new blinds? And it won't just be you who's having a hard time adjusting, it's going to affect wildlife as well. For example, a lot of rodents hide when the moonlight is strong to avoid becoming dinner for predators. But with a strong, continuous moonlight, they'll eventually be forced to go outside and into danger. This means the rodent population will decrease rapidly, and that would affect the entire animal food chain. Next, Europa will shake things up, but not in a good way. The mass of our moon is 1.5 times greater than that of Europa. This means that Europa would have a much weaker gravitational effect on the Earth. The tides of our oceans will become much smaller. They may stop removing pollutants and circulating nutrients. You know, stuff that the ocean plants and animals need to survive. If the tides are out of whack, it could have a devastating effect on ecosystems and lead to mass extinctions. Okay, well, it can't get any worse, can it? Look, don't be mad, but we may have messed up our entire planet. But just look at how pretty the moon is. See? Yeah, just take it in and... You're not buying it, are you? Our moon is responsible for stabilizing the Earth's axis. Without the moon's pull, this new gravitational shift will start affecting our planet's seasons and climate. We could be looking at a future where parts of Earth hardly ever see the sun and others never get a break from the sun. This would affect everything, and I mean everything. If our axis became tilted too much, we could be looking at another ice age. Thankfully, this process would be slow, so there would be time to prepare. The problem is, we're not sure we have what it takes. I mean, look at global warming. Just a few degrees difference can cause entire ecosystems to become disturbed or wiped out, and we've barely scratched the surface of solving that problem. So maybe we should give our real moon a call and see if it'll take us back. We were just so excited about something new and sexy that we took our moon for granted. I miss you, moon. The good news is, there are no real-world plans to move our moon. Swapping our moon with Europa could lead to some beautiful scenery, but at the cost of catastrophic consequences for Earth. The moon has been our friendly neighbor in the sky for billions of years. It's guided us home, kept us on time, protected us, propelled us into space, and has even launched dance crazes. It's hard to fathom what we would do without it, but for the sake of science, let's try to envision a moonless world. What would happen to Earth? Would humans still exist? And what would life be like? This is What If, and here's what would happen if the moon had never formed. So, how exactly did we get a moon in the first place? Scientists believe it started off with a splash. The giant impact hypothesis, also known as the Big Splash, theorizes that a Mars-sized celestial object named Theia came crashing into Earth 4.5 billion years ago, tossing vaporized particles of Earth's crust into space. At this point, Earth was still a baby, only 30 to 50 million years old and not much more than molten lava. Some scientists call this early Earth Gaia. Over time, the debris of Gaia and Theia joined together in a dance with Earth's gravity and formed the moon we know and love today. And lucky for us, our moon's orbit and gravitational pull tilt the Earth 23.4 degrees, creating tidal bulges that help slow the rotation of our planet just enough for life to safely exist. Or so we think. Despite a popular theory, having a moon is no longer a requirement for life to exist. So, could we really exist without our moon? How would we survive? Well, with a little gravitational help from our friends the Sun and Jupiter, life could still have evolved without a moon. But how? Well, with no moon to keep the Earth on an even keel, things might get a little wobbly. We'd have to put up with some extreme weather, our concept of time and seasons would drastically change, and we may evolve to look short and stubby. You can learn more about this in our other video, What If We Lost the Moon? There is, however, another hypothesis. In a study conducted at the NASA Ames Research Center in 2011, scientists performed complex simulations in which the Earth didn't have its moon and measured the effects on Earth's spin over time. The results were shocking. They discovered that the Earth's wobble would eventually stabilize due to Jupiter's immense gravitational pull, deviating no more than 10 degrees off its axis. Thanks, Jupiter! Scientists have also found that the Earth might have spun backward before the moon formed. This would mean that the sun would rise in the west and set in the east. Feeling dizzy yet? Our sky would be a lot darker than usual without the moon to reflect the light of the sun, but that would be perfect for stargazing. Mind you, we'd still have a little bit of light from Venus to help light our way in the dark, but the moon is 2,000 times brighter. At the very least, we wouldn't have to put up with wolves keeping us awake at night. Farmers would have to be careful with their crops without a harvest moon, and women's menstrual cycles would change. Despite these conditions, there's a lot more to our moon than just pure science. Without it, our whole idea of the universe could change dramatically, slowing our progress as a species. If it weren't for Italian astronomer Galileo's discovery of the moon's spherical shape in 1609, we'd probably still think the Earth was the center of the universe.
Houston, we have a problem.
An idea proposed by Aristotle in 284 BCE that was widely accepted for over 1,500 years. Our moon was instrumental in launching the space race, which propelled humans to the stars. In the words of Neil Armstrong, going to the moon was
one small step for man,
one giant leap for mankind. What if our moon had a twin? Seeing not just one, but two of these satellites in the night sky might be spectacular. But how would this second moon affect the ocean tides? Would months on Earth become longer or shorter? And would these two satellites inevitably collide to cause a massive explosion? This is What If. And here's what would happen if the Earth had two moons.
Despite what you think, the Earth isn't really the monogamous type. Along with the Moon, Earth has another Moon-like companion, a small asteroid wandering around it. But it's so far and so small that it can only be considered a quasi-satellite to our planet. In our scenario, we're talking 2 real moons, just like the Earth had during its formative period. Yep, we likely had 2 satellites once. Both of them formed when a Mars-sized protoplanet slammed into Earth and shattered into small pieces. So what exactly would happen if the Earth had another moon parked in orbit around it? Let's assume our second moon would be around 1,000 kilometers wide and about 1/30th the mass of our current moon. It would be about the same distance from Earth too, just like the sister satellite our moon had 4.5 billion years ago. Would we see this double moon from Earth? Absolutely. The second moon would just appear about 3 times smaller. Still, it would be a spectacular view. Along with 2 moons would come some big tides. The newly captured moon would have a much smaller tidal effect than that of our moon, but the tidal force from both satellites combined would make waves. Literally. Although those waves would be bigger, they wouldn't be devastatingly big. In the end, I think surfers will be pretty happy. The second moon might stay in Earth's orbit for tens of millions of years, until eventually, as the moon retreated further from the Earth, it would destabilize the other moon's orbit. Then, just like they did over 4 billion years ago, the 2 satellites would collide in slow motion. Because they'd be moving slowly towards each other, the debris from the collision wouldn't shower back on Earth. The small moon would splatter itself across our moon as an extra layer of solid crust. The new mountains of crushed rock visible from the near side of our moon would be the only reminders of its existence. Now, what if the second satellite happened to be the same size as the moon and orbited the Earth at half the lunar distance? This time, things wouldn't be so pretty. The second moon alone would produce tides 8 times greater than what we see right now. That would force people away from the coastal areas because the difference between high and low tides would now reach 300 meters. Constant tidal flooding would shrink the habitable area on Earth, but once we adapted to this new world, we'd get to enjoy a beautiful double moon. This time, the second satellite would look bigger from Earth due to its closer orbit. The moons would also have different phases, which means we'd have to come up with another way to measure a month. And then there's some worse news. The 2 moons would be slowly moving away from Earth and eventually would crash into each other. This collision would send debris back to Earth. It would be a shower of meteorites of epic proportion, and it could wipe us out entirely. Whatever debris didn't fall to Earth would form yet another new moon in Earth's orbit. Imagine living on the moon. You'd have the best view of Earth. You'd enjoy bouncing around in zero gravity and living your life as an astronaut explorer. Doesn't that sound nice? Except living on the moon won't be like this at all. So, what would it be like to actually live on the moon? Who will establish a base first? And why would moon dust be your biggest problem? This is What If, and here's what would happen if we settled on the moon. Let's make this clear. Just like America did in 1969, humans will land on the moon again in the next decade. Only this time, it's expected to be more permanent. What's less clear is exactly which country will be the first to land and establish a base. China, the USA, Russia, and India are all making strong efforts to get there. But there are also private companies, including SpaceX and Blue Origin, that have a lot more money to spend on going to the moon. But wait, why exactly are these companies doing this in the first place? Apart from exploring the galaxy and breaking new ground, there's another huge reason these groups all want to be the first to create a base on the moon. And that reason is money. The moon is chock full of different resources. It has gold, silver, and titanium in it. The idea here is to mine these precious resources and send them back to Earth. Another resource the Moon has is helium-3. It's incredibly rare here on Earth, but not on the Moon. That's because the Moon doesn't have an atmosphere, and helium-3 comes from the Sun's radiation. Over billions of years, the Moon has been absorbing this chemical, and lucky for us, it can be used for energy. Helium-3 is so powerful that just 100 kilograms of it could power the city of Dallas, Texas for an entire year. Oh, and it's also worth a cool $40,000 for just 28 grams of the stuff. With these resources holding incredible value, it's no secret these countries and companies want to be the first to establish a base. But even if they do, they won't really own it. Back in 1967, the United Nations decided that no one can really own space. This has the potential to cause huge tensions between various nations, possibly leading to war. But enough about all that drama. You are on the Moon. So, how exactly are you going to live here? Assuming we get to the Moon in one piece, which is already an incredibly difficult task on its own, you'll then have to worry about establishing a base. Experts suggest that we live on the Moon's south pole, as it gets the most consistent amount of sunlight. There are also massive fields of ice that we'll be able to harvest. Some other places on the Moon don't get any sunlight for nearly a month at a time. Luckily, you'll have robots to help you establish a base. There are many different ways they'll be able to help. One includes using moon soil to construct bricks and configuring them in a dome-like fashion, sort of like a moon glue. This would make traveling to the Moon a lot cheaper, as we wouldn't have to bring everything from Earth to make our base. But don't expect this base to be glamorous. It'll most likely be several meters underground to protect you from the sun's radiation. And as for what you'll eat, well, it'll be your standard dry astronaut food. The good news is that you should be able to grow some carrots and tomatoes. A 2014 Dutch study found that it's possible using soil on the Moon. And what would you drink? Unfortunately, quite a lot of it will be your recycled pee, as drinking water won't be available on the Moon, and it would be too heavy to ship there. Another thing you'll need to seriously worry about is moon dust. This magnetic dust gets everywhere. It'll get on your suit and even on your skin. Previous astronauts have had allergic reactions to it. It's also slightly sharp, so accidentally swallowing any would be a huge problem. But it's not just humans who need to worry about moon dust. It can get into machines as well, causing them to overheat. Before we settle on the Moon, this is one massive problem we'll need to solve. All these issues beg the question, would you ever really want to be the first to settle on the Moon? You'd most likely spend your time mining and just surviving, with little time to run around in low gravity. And besides, we all know that going here is just our first baby step to get to Mars. So maybe you should just wait for that.
What if the Moon suddenly began getting closer to Earth, to the point where it was on a collision course with our planet? Would Earth survive the crash? Or would a crash even happen? Would the Moon get torn up by Earth's gravity? What would this crumbled up Moon look like from Earth? This is What If, and here's what would happen if the Moon fell to Earth. The Moon is Earth's only natural satellite, and the largest object to brighten our night sky. It's the first and only place beyond Earth where humans have set foot. The Moon's gravitational pull causes tides on Earth, tides that might have been the encouragement for life in our oceans to move on land. This pull also keeps Earth from wobbling on its axis, making our climate relatively stable. In short, the Moon makes Earth a more livable place. So, what if it suddenly sped up and started driving in Earth's direction? The Moon's plan to destroy Earth by bumping into it would break into pieces the moment it reaches the Roche limit. The Moon itself would shatter, never making it to Earth's surface. And that's going to look very impressive. But wait, what is this Roche limit? In celestial mechanics, it's the point at which the gravity holding a satellite together is weaker than the tidal forces trying to pull it apart. In other words, the Moon can only get as close as 18,470 kilometers away from our planet before boom,
the tidal forces would tear it apart. All of the footprints and flags we've left on the moon, all of its craters and valleys would scatter to form a breathtaking ring of debris above Earth's equator, 37,000 kilometers in diameter, making Earth the second planet in the solar system, after Saturn, to have this striking ring of beauty. The difference being that our rings wouldn't last long. The chunks of our former satellite, the Moon, would rain down on Earth. It would be as if hundreds of thousands of asteroids were falling down on us and wiping out entire cities in the process. Once the Moon began its trajectory towards the planet, it would increase the tidal impact it has on us. By the time it hit the Roche limit, it would be causing tides as high as 7,600 meters. Our world would be devastated by an army of tsunamis, 10 times a day. But for a short time, hardcore surfers would enjoy riding some tasty waves. On the other hand, this might be a solution to global warming. With the Moon coming closer and closer, Earth's rotation would speed up. Our days would become shorter and shorter. Global temperatures would go down, and no one would worry about climate change anymore. Unless asteroids burned the Earth to a crisp, then there would be no one to worry about anything. I really wouldn't worry about it anyway. In fact, the Moon is drifting away from us at a rate of 4 centimeters per year, so it's unlikely we'll get to see those pretty Saturn-like rings here on Earth. What if we humans could live somewhere outside of Earth? Say the Moon. Obviously, we can't just pack our stuff and move there today, but what if we terraformed it, reshaped it into Earth's image? How long would it take us to turn our natural satellite into a habitable place? What would this Earth-Moon look like? Would this even be possible? This is What If, and here's what would happen if we terraformed the Moon. Wondering why we chose the Moon and not Mars? With water ice buried beneath its surface, the red planet seems to be the best candidate to serve as our second Earth. But with zero experience terraforming, we should consider colonizing our natural satellite first. It gets twice as much sunlight as Mars, and it's just a 3-day trip from us. In short, it would take us less time and money to construct a decent Earth on our Moon. So, how exactly do we engineer a habitable planet? Just to be clear, we're not talking about building a permanent moon base. We'd go nuts and actually transform the Moon into an Earth, just a smaller one. For starters, we'd need to build an atmosphere. And here's the fun part. To do that, we'd need to bombard our Moon with 100 water ice comets, asteroids. We'd find them flying all around the Earth. These comets would crash into the Moon's surface. They'd fill the Moon's plains with water and disperse carbon dioxide along with water vapor and a little bit of ammonia and methane. All these gases would gather near the surface, creating an atmosphere. The newly formed seas would reflect much more sunlight, making the Moon appear 5 times brighter when seen from Earth. These asteroids would also give the Moon a momentum. They'd make our satellite spin close to an Earth-like cycle. The more comets we batter into the Moon, the faster it would rotate. A lunar day would drop down from an incredible 28 Earth days to just 60 hours. Since our satellite wouldn't rotate on its axis at the same rate it orbits the Earth anymore, it would no longer be tidally locked to our planet. For Earthers, this would mean we'd be able to see the dark side of the Moon, although it wouldn't be dark. But how do we save the newly built lunar atmosphere from being stripped away by solar winds? We'd have a couple of options. The first one is easy. Moon's own rotation would generate a dynamo effect. That dynamo could awaken the Moon's once active magnetic field that would keep the atmosphere in place. If that doesn't work out, we'd have to place a gigantic shield in orbit. That shield would work as an artificial bow shock, making up for a missing magnetic field. When that's all sorted, we'd bring in genetically engineered plants, suitable for growing on the Moon's stony ground. We'd also drop some algae that would release oxygen into the air. That would be the start of life on the Moon. Finally, after many decades of hard and costly work, we'd send the first human colony to settle down on the first man-made planet. The terraformed Moon would get very warm from greenhouse effects. It would be mostly cloudy too, and with tides as high as 20 meters, surfers might want to make the trip. Living on the Moon would be just like living in Florida, but with 1/6 of the Earth's gravity. The Moon settlers would be able to jump as high as 3 meters off the ground, remaining in the air for 4 seconds. And if they were really fit and full of stamina, they'd be able to run across the Moon's lake. The Moon is a giant rock that lights up our night and can even change colors. So what would we do without it? Would we all need night vision goggles? How would it affect the ocean tides, our seasons, or our sleep cycles? Or would the consequences be far more dramatic? This is What If, and here's what would happen if we suddenly had no Moon. As As the closest celestial body to our planet, the Moon exerts a gravitational pull that governs much of what happens here on Earth. Take the sea, for example. If you like surfing, you can thank the Moon. When the Moon's gravitational pull tugs on our spinning Earth, the oceans respond, giving us high tides in some parts of the world and low tides elsewhere. And while the wind gives the waves their energy, tides define their shape. The Moon's gravitational attraction also keeps us at a stable 23.5-degree tilt relative to the Sun, giving us 4 seasons and a livable climate. But what if that livable climate were to suddenly become unlivable? With the Moon gone, its stabilizing effect on the Earth's rotation would go with it. Want the good news first? The weekend just got a whole lot closer. If the Moon suddenly disappeared, a day on Earth would only be 6 to 8 hours long. Over millions of years, shifting tides and their pressure on the Earth's continents have slowed our planet's rotation, giving us 24-hour days. But without the Moon's strong gravitational influence, the world would spin 3 to 4 times faster than it does now. Here comes the bad news. Rotating at that speed, we would experience winds up to 480 kilometers per hour. Birds and insects would have no chance of survival. The luckiest land-based organisms would either be deeply rooted plants or very short, very stout animals. Most of our marine life would be wiped out, since sea creatures that rely on ocean currents for survival would lose the privilege of the ocean's pull. Currents help circulate vital nutrients from the ocean floor to the surface, while dragging oxygen-rich surface water deep into the sea. We'd still have tides, but now they'd be governed by the Sun, and from a distance of 93 million miles away, they'd only be 1/3 as powerful. And with the Moon suddenly out of the way, the oceans would rip towards the Sun, causing catastrophic waves, killing thousands and submerging coastlines. At this point, we'd have to adjust to new ocean currents, which, circulating at a slower rate, would be heating up equatorial waters while turning polar waters frigid. These extreme differences would produce a similar effect on land as well, since ocean temperatures influence their regional climates. Along with the Sun, Mars and other nearby planets could also claim a share of gravitational influence over our planet, pulling Earth in different directions and causing it to tilt with increased volatility. Earth's axial plane would vary some 10 degrees, causing dramatic shifts in seasons and rendering our climate uninhabitable. Most crops would die with the drastic temperature changes. We'd experience the worst ice ages known to man, as huge glaciers from the North and South Poles would encroach upon the Earth, covering everything except perhaps a small band across the equator. So while full moons may attract werewolves, that's still better than an alternative world where the Moon doesn't exist.
Buckle up! We're going to take the orbit of this rock and kick it into high gear. Behold the Moon breaking its planetary speed limit. How would this event flood cities? What would happen to the Earth's crust? And why would the Moon go rogue? This is What If, and here's what would happen if the Moon orbited Earth faster. The Moon orbits around our blue marble of a planet at a comfortable and reliable speed of 1 kilometer per second. And if that seems fast to you, well, hold on, you haven't seen anything yet. So how could this happen? If the Moon kept getting closer to Earth, the gravitational pull from our planet would increase. That would make the Moon's orbit speed up tremendously. That's the basis for Kepler's third law. So, if the Moon kept creeping toward Earth, it would orbit faster and faster. And if that happened, how would this event freeze the planet? Every 27 days, the Moon completes a trip around Earth. Well, not anymore. Get ready to see this celestial body more often. And with the Moon's increased visibility and speed, lunar eclipses would be a regular sight. But that lovely view in the sky wouldn't make up for the hell on Earth below. If the Moon moved closer, the gravitational pull would rip into the Earth's crust. This increased force would create earthquakes and increase volcanic eruptions across the globe. And don't think you could cool off by the ocean to escape the heat. Let me explain. The oceans ebb and flow thanks to the moon's orbit, the Earth's gravity, and the sun. So, as the moon inches closer, the ocean tides would become much larger. How large are we talking? They would be 8 times higher than average. Coastal cities would flood, and some islands would become blanketed underwater for most of the day. Almost 700 million people living in low-lying coastal areas would be in constant danger if they weren't evacuated. But what would happen if the moon started to move even faster? Well, remember Kepler's third law. The moon would only orbit faster if it got closer. Now, if it came within 18,470 kilometers, it would reach what's called the Roche limit. That's the point where the moon is so close to Earth that the tidal forces between us would get strong enough to tear this gray rock apart. Thankfully, this wouldn't be able to happen because as its speed increased, our moon would be launched into the cosmos. Yeah, that's because once our natural satellite reached 1.4 kilometers per second, it would have enough momentum to escape Earth's gravity. As it fades from sight, you might feel relieved at first. After all, the Earth's rotation would slow down without the moon, so days would become longer. And finally, you'd see an end to the constant earthquakes and devastating floods, but in reality, this is where the real nightmare begins. The tides would become smaller and weaker without the moon. Any coastal ecosystems that weren't already destroyed by the massive flooding would now be completely upended. Without churning tides, animals that depend on food sources normally floating in the ocean wouldn't get the nutrients they need to live. And without the moon's light, nocturnal predators would have difficulty completing a successful hunt. This could create a mass extinction event of creatures on land and at sea. And while life on Earth would be flipped on its ear, so would the planet. Earth has a tilt of about 23.5 degrees. This angle of its orbit makes the seasons possible. But it's the moon's gravity that stabilizes this tilt from going any further, so without it, the seasons could stop. Weather patterns might hold in place until the end of time. But if the tilt increased, well, it could cause extreme weather conditions, and once again, the Earth could be plunged into an ice age. Yeah, a faster lunar orbit could fast-track all life on Earth to extinction. No, that's not Photoshop. That's an actual video from the International Space Station of the moon looking a bit squished. Wow. So, what happened here? Is the cover-up behind a flat moon an elaborate government conspiracy? How would this affect the oceans? What would happen to our climate? And could the moon fly out into space? This is What If, and here's what would happen if the moon was flat. In 2010, an astronaut on the International Space Station observed a bizarre phenomenon. When he glanced out the window, he saw the moon looked flattened when it appeared in the thickest part of the Earth's atmosphere. And those of you in the Flat Earth Society, don't at me, it's not flat. High above the planet, the air bends light to give the moon this squished look in these very specific conditions. But if the moon were flat, it would explain why we never see the mysterious dark side. And if this was our reality, how would this affect gravity on Earth? Okay, there are no illusions this time. The moon is flat. So, how would that happen? Well, a celestial body would need to spin incredibly fast to become a flat disk. So fast that it would rip into tiny pieces before it would ever have a chance to form. For our purposes, let's say the moon survived this process and formed like a plate. Would this flat moon have the same mass as what we see right now? Well, as a flat disk, the moon could have 25% of the thickness, but the width might remain the same. With so much less mass floating above the Earth, the change in ocean tides could be the first noticeable effect. The moon's gravitational pull generates these tides. Our moon pulls the water on the side of the Earth that's closest to it, but this flat moon would have less mass and less gravitational effect on our planet. And the altered tides would affect more than just surfers. Ocean tides stir up material below the water's surface, allowing coastal ecosystems to thrive. Without the usual strong waves, animal life in the oceans, like crabs, mussels, and snails, could die off in mass numbers. This chain reaction could decimate life worldwide. And that's not all a flat moon would ruin. Remember, the tides also push water back and forth around the planet. When warm waters travel from one area to another, these tidal forces change weather patterns globally. Without the strong tides, we could experience extreme temperature changes. But even with all these devastating changes, the climate still wouldn't change as fast as the days. The moon's mass influences our planet's rotation, giving us a 24-hour day. But with a flat moon, the day could be only 15 hours long. But I think most of us could live with a 5-hour workday. And while we'd get more sunlight, the nights would be even darker. You see, the moon reflects the sunlight to give off that bright glow we all know and love. A smaller moon would reflect less light, making it much dimmer. That would make it harder for nocturnal animals that rely on the moon for navigation and hunting. But maybe none of that would matter since it could potentially crash right into us. Wait, what? Yeah, the Earth and the Moon are locked together in an eternal dance. The motion created by one affects the other. I know, this sounds hippy-dippy, but trust me, we're talking science here. The same tidal forces that move the oceans also affect the Moon's orbit. The tidal bulges in the ocean rotate faster than the Moon orbits the Earth, and this rotation takes energy away from the Earth and transfers that into the Moon's orbit. This is called tidal friction and causes the Moon to drift away from us at the rate of 3.82 centimeters every year. A flat moon with less mass would orbit closer to our planet. So maybe it wouldn't slam into Earth, but our view of celestial phenomena wouldn't be the same. Right now, the sun and moon are positioned just perfectly that when aligned, we get a spectacular image of a total eclipse on Earth. The moon covers the sun entirely in this breathtaking event. A squished moon wouldn't be able to block out the sun entirely during an eclipse, and we would see the top and bottom of the sun peeking out. A flat moon could destroy the balance of life on Earth and threatens every ecosystem and living organism, including humans. Greetings, future, moonling? Yeah, that's right. You are among the first generation of children born on the moon. How would your birth compare to every previous human's? Would your body be physically different from an Earthling's? And what challenges would you face if you traveled to Earth? This is What If, and here's what would happen if you were born on the moon. If you were born on the moon, you'd begin your life 384,400 kilometers away from where every other human being has ever been born. At least as far as we know. The surface of your birthplace would have an extremely thin atmosphere without liquid water. The radiation levels could be up to 1,000 times higher than on Earth's surface, and the scorching daytime temperatures at the equator get as high as 120 degrees and as frigid as minus 130 degrees at night. Of course, your mother wouldn't give birth to you out on the moon's surface. Your life would begin in a state-of-the-art base surrounded by a handful of astronauts. But with 6 times less gravity than on Earth, would being born on the moon be extremely dangerous? Right now, a moon base is only theoretical. Your first home on the moon might be a habitat based on Project Horizon. It was a concept proposed by the US military in 1959. Whether the base got built into caves using pressurized airbags or a high-tech cylindrical airlock dug into the surface, you'd be born into an incredible self-sustaining habitat. You'd harvest the oxygen you'd breathe and the water you'd drink from the moon's natural environment. Your birth wouldn't have been a walk in the park for your parents either. Since you'd be the first space baby, there wouldn't be any research on the challenges of conceiving a child in space. But your folks were successful, and you probably wouldn't want to hear much about that anyway. The moon's lower gravity would have made your birth especially challenging. As a fetus, you'd have developed slower, so the length of time your pregnant mother carried you could have been longer than on Earth. Imagine being pregnant in space for up to 1 full year. Your birth would likely have taken longer than back on Earth, too. For every month your mother has spent in space, she could have lost about 1 to 2% of her bone density. That would have made pushing you out a lot more difficult and dangerous. With the risk that giving birth could fracture your mother's pelvic bone, the doctors in your space habitat would have brought you into the world using a C-section operation. And every baby born on the moon after you would likely be born this way too. This could lead to one of the first big differences between Earth and moon babies. Our heads evolved to be small enough to fit through the birth canal. So, with no traditional childbirths on the moon, future moonlings could evolve to have bigger heads than their Earth counterparts. Moon-born children could even evolve to have different skin color than the folks back on Earth. The melanin in our skin protects us from the sun's radiation. And the darker your skin, the more natural protection you have. But there's no atmosphere on the moon, so you'd live with significantly less protection from radiation. So the skin color of future moonlings could evolve to be extremely dark to provide the protection they'd need. But since a lot of your life would be spent inside a habitat or wearing a spacesuit, well, the opposite could be true. Humans on the moon could evolve to be even paler than some people on Earth. The increased radiation could cause other changes too. If Earthlings and Moonlings didn't produce enough offspring together, you could even see a new species of humans emerge. Okay, well, that could take a few hundred or even thousands of generations, but you'd have been the starting point in this incredible evolution of humanity. How much you interact with people from Earth would be a tricky question for you. Not enough mingling, and your immune system could weaken. You could lose your ability to fight off infections brought to your base by visitors. To be safe, you might minimize your contacts with new astronauts or settlers. The last thing you'd want is to start the first pandemic on the moon. And if you ever made the trip to Earth, you'd find it pretty hard to adapt. First of all, you'd need a week or two just to adjust to the gravity. And you'd be plagued by lightheadedness each time you stood up, since the reflexes that regulate your blood pressure would be accustomed to lunar gravity, not Earth's. Be careful when jumping into any bodies of water, too. You're from a place where you have to live inside and conserve water, so diving could be hard for you. You could get disoriented and accidentally dive deeper instead of returning to the surface. Now, you could find that having a good view of the Earth makes up for the challenges of visiting it. If you live on the near side of the moon, you'd be able to see Earth all the time. Earth would even cast extra light onto you. Yeah, the Earth reflects approximately 37% of the sunlight it receives, so on the moon, your view of the planet could be 43 times brighter than the view an Earthling has looking up at you. Hopefully, you wouldn't grow up to be a light sleeper who needs total darkness.
You awake?
Yeah. You'd be constantly bathed in both sunlight and earthshine. Well, if that happens, maybe you could move over to the far side of the moon and enjoy its constant darkness. And with such a thin atmosphere, you'd see stars even during the brightest parts of the day. Martians might really exist in the future, but instead of the aliens of sci-fi movies, Martians would be humans born and raised on Mars. And in this episode, you're one of them. Why would your skin be orange? Would you be a different species? And would you ever be able to visit Earth? This is What If, and here's what would happen if you were born on Mars. Some of our previous episodes have already looked at what it would take to live on Mars, but that's only half the story. To create a stable settlement on the red planet, people would have to start having babies. How many people would we need to create a healthy, non-inbred population? Well, some say we'd only need 98 people, but others say we'd need a minimum of 10,000. But regardless of the size of the breeding population, it would only take a few generations before we started seeing a huge difference between Earthlings and Martians. Mars is the most Earth-like planet in the solar system, but it's not exactly like the Earth. Its gravity, atmosphere, and magnetic field would create serious challenges for human life. And challenges often go hand in hand with evolution. Children on Earth are born with up to 120 genetic mutations. Move those babies to Mars, and they would start having mutations suitable for Martian living. And those mutations would likely pass on to their children. By the time we settle on Mars, we'll probably have the ability to modify our own genes, putting Martian evolution on the fast track. So, if you were born in the third or fourth generation of Martians, you would be a lot different than you are today. But what are the main reasons why your body would change? Well, first, there's gravity. Mars only has 1/3 of Earth's gravity, so your bones wouldn't experience the same force. Your bones would lose their density and become more brittle. Breaking them would become a common issue. Then there's the atmosphere. On Earth, you're used to a dense atmosphere that mostly contains nitrogen and oxygen, but on Mars, you'd be experiencing a thin atmosphere that's mostly carbon dioxide with only trace amounts of oxygen. You wouldn't be able to evolve a whole new respiratory system, but you could develop other ways of dealing with the lack of oxygen. Like you could have denser capillaries that are more efficient at moving blood and transporting oxygen to your muscles. But even with these advances, you'd still have to live underground or in a thickly insulated house to survive the harsh atmosphere. And since life on Mars would be confined to small spaces, Martians wouldn't need to be able to see far into the distance. Yeah, you would be born nearsighted. And finally, there's the radiation. Earth has a strong magnetic field that protects us from lethal solar radiation, but Mars has a weak magnetic field that's scattered along the planet. On Earth, our bodies produce melanin. It protects us from the radiation that does make it through Earth's magnetic field, but the radiation on Mars would be much stronger, and melanin just wouldn't cut it. Instead, your skin would produce carotenoids. This pigment would help protect you against skin cancer by slowing or stopping the cell cycle. Carotenoids can even make melanoma cells self-destruct. They're also what gives carrots their vivid orange coloring. Yeah, in other words, your skin would be orange. So, with all these changes to your body, would you be able to visit Earth? Well, Mars wouldn't have the same type of bacteria and viruses that the Earth does. So, your immune system would be weaker than that of an Earthling's, which means Earth could be a dangerous place for you. And even if your immune system were strong, the gravity of Earth would be too much for your brittle bones. If you were born on Mars, you'd probably have to stay there. Humans have looked the same for a very long time, but within a few generations of living on Mars, we could have orange, nearsighted humans who could survive on less oxygen. And once we successfully settle on Mars, we probably wouldn't stop there. In the future, humans could have settlements on all sorts of planets, even outside the solar system. When it comes to planets in our solar system's habitable zone, one world is too close to the Sun, another is too far, and Earth is just right. But maybe things would be different if Venus and Mars simply swapped orbits. What makes these planets impossible to live on right now? What changes would they undergo when they traded places? And why would you need Jupiter to give these planets a chance at supporting life? This is What If, and here's what would happen if Venus and Mars swapped orbits. Our solar system's habitable zone, otherwise known as the Goldilocks zone, is the distance from a star where liquid water could exist on the surface of a planet. As long as conditions aren't too hot or too cold, life could be possible, just like on Earth. But simply occupying prime real estate in the habitable zone isn't a guarantee that a rocky planet is actually habitable. Both Venus and Mars orbit within this region too, and yet no life. Despite being of a similar size and with roughly the same surface gravity as Earth, Venus is too hot to hold liquid water. And dense. Its atmosphere is 90 times denser than our own, and the surface temperature is a scorching 462 degrees Celsius. On the other end of the Goldilocks zone, Mars is also quite Earth-like, except way colder, drier, and dustier. Its average surface temperature is minus 46 degrees Celsius, and it has an atmosphere about 1% as thick as Earth's. So, if we swapped things around, would Venus and Mars transform themselves into perfectly livable planets? Bringing the red planet into Venus's orbit would put it at a distance of approximately 108 million kilometers from the Sun. This would bring it halfway closer to the Sun than it was before. Being so much closer, Mars would get a significant boost in the amount of sunlight it receives, and that alone can make the surface temperature climb to a balmy 32 degrees Celsius, just like the Earth's tropics. But without a thick atmosphere or oceans, all this new heat wouldn't stay on the planet. Just like in Earth's deserts, Mars would see extreme temperature differences between day and night. The thin Martian atmosphere would make it difficult for water to stay liquid. With such a low surface pressure, water would boil at a lower temperature. Evaporation would happen much quicker. Looks like if you want to see life flourish on Mars, you'd have to take a slightly more hands-on approach. But first, let's check out how Venus is doing in its new neck of the woods. You'd now find Venus located 228 million kilometers away from the Sun. That's twice as far as it used to be. And naturally, you'd think, surely this scorching planet would be starting to cool down. Well, as it turns out, the planet's high surface temperatures have a lot more to do with its thick atmosphere than its overall closeness to the Sun. Venus has a very high albedo, which means that it reflects about 75% of the incoming sunlight. So it could be that the planet's temperature remains more or less just as hot as before. Even as the upper parts of the atmosphere slowly cool enough for the albedo effect to decrease, that would mean that Venus could now absorb a larger amount of incoming sunlight, so that temperature wouldn't start to drop all that much. Another setback on the road to becoming a life-supporting planet would be that Venus's atmosphere is mostly comprised of carbon dioxide, with small amounts of nitrogen and clouds of sulfuric acid. What you still wouldn't find nearly enough of is water. The concentration of water in Venus's atmosphere is 100 times too low for even the most resilient organisms back on Earth to survive. But since you went through all the effort of bringing both planets from one end of the habitable zone to the other, why not take things a little further? You could try terraforming the planets to make them a little more livable. One way you could increase the surface pressure of Mars would be to try releasing all the carbon dioxide found in its soil and minerals. The only problem here is that the red planet would need to reach temperatures above 300 degrees Celsius. And despite this new location so close to the Sun, Mars wouldn't ever get this hot. Besides, if you could release all of that precious greenhouse gas, it would only amount to an atmospheric pressure of about 10 to 14% of Earth's. There simply isn't enough carbon dioxide on the red planet. Even if you had been successful with that effort, you'd still be unable to breathe on Mars. One option for dealing with this would involve bringing special microorganisms to the planet that could convert the hostile Martian atmosphere into breathable air. This would be similar to what Earth was like 2.5 billion years ago. Back then, cyanobacteria converted our methane and ammonia-rich atmosphere into the oxygen-rich one you enjoy today. But ultimately, this would be a big waste of time and resources. You'd find that with Mars's weak magnetic field, it wouldn't be able to hold on to any atmosphere you could create. That would be thanks to the power of solar winds that would constantly strip away whatever atmosphere you'd managed to generate. And sitting in Venus's old orbit, solar winds would be almost 5 times as dense as Mars is used to. Way out on Venus, the question of creating conditions for life could come down to whether you could manage to form an ocean on the planet. And that would entail bombarding the atmosphere with hydrogen. As hydrogen is introduced to the atmosphere, it would react with the carbon dioxide, leading to the formation of water. Introduce enough hydrogen and you could eventually see Venus with 80% of its surface covered in water. For this to work, you'd need a lot of hydrogen. So much that you'd probably need to find a way to harvest it from a gas giant like Jupiter or Saturn, or maybe one of their moons. Yeah, I'm not sure all this planet moving and hydrogen bombarding was really worth it. You'd still be left with only one Goldilocks planet capable of supporting life.
One day, Mars could look like this, allowing humans to comfortably live on the planet. All we'd need to do is to terraform it. But how? Well, we could nuke it. Would dropping nukes on Mars make it easier to live there? This is What If, and here's what would happen if we nuked Mars. Believe it or not, this is something scientists have considered for decades. Elon Musk of SpaceX seems to think that nuking Mars might be one of the best and quickest options to make it a place where humans could live. The idea is that we would explode thermonuclear bombs in the sky over the planet's two poles. This would heat up the ice caps and release carbon dioxide and water from the poles. Then the greenhouse effect would take place. It would heat up the whole planet, making the surface more habitable. So this all sounds super quick and easy. Why haven't we done this yet? It's because there's a high chance that nuking Mars might not work out the way we want it to. There are many things that could go wrong with this plan. The first problem is it's all just theory, and the theory could be wrong. That's because Mars has been losing its atmosphere for a long time. Earth's atmosphere is almost 100 times thicker than Mars's, and if we're going to live on Mars, it needs a thicker atmosphere. Some scientists think that we could release CO2 from the North and South poles, and this could make Mars's atmosphere more like Earth's, but a 2018 study published in Nature Astronomy found that even if the nukes are successful, it would only increase Mars's atmosphere to 7% of what Earth has. Even if we create more carbon dioxide in Mars's atmosphere, it still wouldn't be nearly enough to heat the planet. And the planet could seriously use more heat, since its current temperature averages around minus 63 degrees. And it would take decades for the red planet to warm up, even after it gained the extra CO2. So, in theory, this could delay humans from ever landing on Mars. Not only that, but this assumes that dropping thermonuclear bombs on the planet would go perfectly. Keep in mind, these are nukes. You know, the things that can destroy entire cities. In fact, the bombs we'd use on Mars would be 1,000 times stronger than the ones used in World War II. If a bomb exploded on the planet's surface instead of up in the atmosphere, some severe damage would occur. Not only would it completely destroy parts of the planet's surface, it would also cause even more radiation, another thing that would delay us from ever settling on Mars. It's also very likely that instead of warming Mars, a bomb could cause a nuclear winter. This could happen from the dust and particles in the atmosphere caused by nuclear explosions. They'd almost entirely block out the sun, causing Mars to cool down even more. So, nuking Mars probably isn't the best idea.
It's one of humanity's most ambitious undertakings, created to extend human exploration to the farthest reaches of our solar system.
The next step in space exploration isn't generations away. It's happening right now. And our destination? That mysterious and desolate world next door. Mars. Imagine starting life over on that tiny red dot, over 265 million kilometers away. What would happen if we built a city on Mars? Would you have to live underground? How many people would you live with? And what would the Martian economy look like? This is What If, and here's what would happen if we built a city on Mars. Since 1975, the only things from Earth making claims on Mars are robots and satellites. But now, Elon Musk and his company SpaceX are looking to change that story. Their goal? To create a city with a government, trade, and culture on Mars. This plan involves 1,000 spaceships and even more brave new recruits. By surviving in lower gravity with fewer people and only limited supplies, living on Mars might change how we could adapt to dwindling resources on Earth. But with so much depending on the early stages of planning and supply runs, could life on Mars be sustainable? Every great city starts small, whether you're talking about the little fishing town of Hong Kong or a hut village named Rome. So, if you want this Martian colony to grow into a thriving city, you're going to need more than a handful of people. According to the Bordeaux Institut National Polytechnique, you would need at least 110 settlers to start this adventure. The SpaceX plan starts with 2 spaceships carrying 100 people each. With this handful of explorers, your city would have just enough people to build more habitats and research stations without putting your resources in danger. If you run out of food at this stage, that's the end of the experiment. The biggest challenge this city faces is becoming sustainable without relying on regular shipments from Earth, which will only come every few years. You see, with the egg-shaped orbit of Mars, it takes 687 Earth days to make one Martian year. Supply runs would only launch when Earth and Mars align, which happens every 2 years, to cut down on travel time between our worlds. And after this nearly 8-month-long trip, there's still a chance of losing all those supplies when the rocket lands. Since the gravity on Mars is only 3/8 of the pull on Earth, landing safely on the surface of Mars would be dangerous. And that doesn't take into account the amount of dust flying in the air. After all, the dust on the Moon was bad enough, and it got into crew members' eyes and damaged systems on their spacecraft. But kicking up the dust on Mars might be even more deadly, since each grain is highly oxidized and electrically charged. But hey, you made it to Mars safely. Now, what are you going to eat? The chlorinated soils on Mars are toxic, and if you ingested them with your food, you might damage your thyroid gland. So that means farming is out. Outdoor farming, at least. Well, before you worry about eating, you'll need to set up protection from the harsh conditions on Mars. With an atmosphere made of 95% carbon dioxide, the air on Mars is toxic. And don't forget about the intense radiation on the surface. With more exposure to radiation and no breathable air, you won't be able to survive without a controlled environment. Thankfully, with the help of those rocks under your feet, you have all the protection you need. Just 5 meters of the surface materials on Mars, called regolith, provides the same amount of shielding from radiation as Earth's atmosphere. This material would be processed into cement to create layered walls using robots and 3D printers. This material would be a protective shell, and underneath that shell, domed science facilities, living spaces, and all your home comforts. Connected by tubes, these domes would provide you shelter from the raging dust storms outside, which might last for months. Even with this technology, Elon Musk claims it could take up to 10 years to establish a colony. But it's during this time that your quaint Martian village would grow into the first human city beyond Earth. Since this world isn't being drilled or fracked, the power grid on Mars can be made sustainable right from the start. We would set up solar arrays for electricity and use natural gases like methane for engines. Our footprint on Mars could start low and stay that way, no matter how many people live there. And now you better figure out a way to feed all these people. The low gravity on Mars might decrease your muscle mass. To keep your body healthy, you'll need to provide more protein. You'll have to serve the equivalent of 110 cooked chicken breasts and 660 carrots every day. If one of these domes contained an indoor farm, you could raise the chickens you need to feed your city. And you would have the most nutrient-rich manure available. If you used this manure in the greenhouses, you'd have a way to fertilize your crops year-round. But how could you irrigate those crops? How would you get water? Scientists still debate whether liquid water exists below the ice caps on Mars. But if it does exist, that freshwater source could be filtered for the colonists to use for irrigation. With less gravity on Mars pulling water down into the ground, you would need less water to keep your plants alive than you would on Earth, since it would stay closer to the surface. And with supplies being transported only every 2 years, having spring water available on Mars would change how the city would operate. It would create a government infrastructure to distribute and oversee the water supply and employ scientists to manage the filtration needs. Now, the city has an infrastructure in place and jobs to fill, so how would you value your time in terms of cash? How could you pay for products or services? Cash weighs too much to travel with in outer space, and credit cards would require Wi-Fi services communicating back to Earth. With a 14-minute gap in communications between Mars and Earth, you're gonna need something more locally based. Well, you might have to use a cryptocurrency known as Mars coin, but you would have need to have bought it with your Earth money before you boarded the spaceship. While Mars coin would only be available to Martians, this money would help build the government, increase trade, and create a standard of living. With society on Mars still new, maybe you could trade your services or learn to barter goods instead of relying on this cash system. If we do things right, life on Mars might be the model for future civilizations, free from the constraints of the culture built on Earth. Or it could be like every sci-fi movie ever made. Thanks, Jupiter. If you were to drill straight down into Mars, what would you find? Would the red planet reveal its true colors? Would you finally discover life on Mars? And how would drilling through Mars compare to drilling on Earth? This is What If, and here's what would happen if we drilled through Mars. This is the Jezero crater on Mars, and 3.5 billion years ago, it looked very different. It used to be an ancient river delta that carried clay minerals into the crater lake. It might have even hosted Martian life. Fast forward to now, and the Jezero crater has become a perfect landing site for NASA's shiny new rover. Meet Perseverance. If I were to search for past life forms on Mars, this is the place I'd start looking too. Only instead of collecting rock samples, I'd send a rover to drill through the surface. What's the worst that could happen? Did you know that Mars has Marsquakes? They're like earthquakes, but on Mars. NASA's Martian lander called InSight detected 480 of these Marsquakes in 2020 alone. Luckily, there isn't much out there to damage. For us, these Marsquakes are a good thing. They create seismic waves that our scientists can study, and based on these studies, they can theorize about the Martian interior.
But you and I would be doing this the hard way. We would drill through Mars to see what secrets it holds inside. If you started drilling through the reddish iron oxide abundant surface layer of Mars, the first thing you'd discover is that the interior is not so red. But don't be surprised. In 2012, NASA sent the Curiosity rover to Mars. It landed about 3,700 kilometers from the Jezero crater. Curiosity discovered that the layer beneath the surface of Mars is slate blue? Yeah, that's because it contains high levels of silicon. Huh. And as you drill, you should continue to expect the unexpected. The next discovery you'd make is that the crust layer on Mars is thinner than the one on Earth. Remember InSight? This little lander indicated that the Martian crust is only around 20 or 37 kilometers thick. Compare that to the Earth's crust, which is approximately 40 to 50 kilometers thick under the continents. If water still exists in liquid form on Mars, it could be several kilometers inside this crust. And there are radioactive elements in the liquid mantle below the crust. These elements release geothermal heat through their decay, and it should be enough heat to melt thick sheets of subsurface ice. This geothermal heat could be why there was liquid water on Mars 4 billion years ago, even though the surface temperatures were below freezing. But enough theory, let's keep drilling. Boring through Mars would be even harder than drilling through Earth. The deepest we've ever drilled on Earth was 12.2 kilometers into its crust, and that came with high budget costs, technical difficulties, and plenty of bad luck. But on Mars, this would be an unimaginably tricky endeavor. The InSight lander tried drilling, but it encountered unexpected soil properties. The drill probe was trying to go 5 meters deep, but could only go a fraction of the distance before popping out. Then there was Curiosity. It experienced a mechanical error. The drill feed mechanism that was supposed to move the drill bit forward wasn't moving when commanded. Luckily, scientists designed a new, more human form of Martian drilling. Now, the rover uses the force of its robotic arm to push the drill bit into the surface as it spins. But don't get your hopes high about reaching the mantle of Mars too soon. It took Curiosity the entire day to drill a mere 5-centimeter hole. Based on that, going 5 kilometers down would take up to 300 years. And you'd need a bigger drill. There's still so much we have to learn about Mars, but maybe drilling isn't the most effective way to do it. Especially since we haven't gotten very far into the crust of our own planet.
Congratulations! You've taken the 7-month-long journey and have finally landed on Mars. And it turns out, you're the first person. Better start cleaning the place up and getting it ready for human colonization. Will you ever make it back to Earth? How will you gather resources for survival? And will this happen someday? This is What If. And here's what would happen if you were the first person on Mars. A trip to Mars might happen sooner than you think. NASA is hoping for it to be as soon as 2033. Think about that. The first person on Mars might be watching this video right now.
Hello, future Martian.
And NASA may not be the first to get there. There are plenty of other space companies trying to get to Mars around the same time. Similar to what we saw in the 1960s with the Moon, it's very likely that we'll see another space race, only to Mars this time. But getting there is the boring part. Now that you've landed, what happens next? Your first goal will be to set up base. And it can't just be anywhere. Researchers believe that the best place for a camp on Mars is near the planet's poles.
There, you'll find massive ice deposits, which are thought to contain large amounts of water. We need water to survive, but it's heavy and it takes up a lot of room on a spacecraft. So, to solve this problem, we could potentially turn this ice into water that we could drink, study, and use. Scientists suspect that the ice deposits may also contain iron and sulfur, which could be used for manufacturing in the future. But that's in the long term. For now, let's worry about your base being built. Luckily, you won't be building it, as space companies intend to send a team of robots up there to assemble the base for you. After that's done, you can finally move in. The base will be roughly 12 meters high and 5 meters in diameter. That may sound pretty roomy, but you won't be alone. Space companies are planning to send 6 people to Mars for the first expedition. At least you'll have people to talk to while you're there. Once you've landed, you'll quickly notice how different Mars feels from Earth. Mars has just 1/3 the gravity that the Earth has. NASA says that a person who weighs 45 kilograms on Earth would only weigh about 17 kilograms on Mars. You'll be able to jump all around the planet. But if that's all you expect to do, this trip won't be for you. The first people on Mars will be unlike any astronauts we've seen before. Apart from knowing everything about physics and spaceships, they'll also have to be farmers, botanists, and excellent problem solvers. One massive problem they'll all need to solve? Food production. Let's hope you like your vegetables, because aside from astronaut food, that's pretty much all you'll be eating. A university in the Netherlands simulated crop growing on Mars and found out that potatoes, peas, carrots, and radishes could all grow on the planet. You'll be able to use the soil on Mars, and water will come from recycling urine and whatever other water products were brought onto the planet. And speaking of human waste, unfortunately, you'll have to use your poop to fertilize the crops you're growing. Now that's recycling. After about 9 months of researching, farming, and exploring Mars, you'll then begin your journey home. This is arguably the hardest part of the trip. You and your crewmates would hop into this Mars Ascent Vehicle, or MAV for short. Then, you need to line it up perfectly with the larger spaceship, which is orbiting Mars. The ascent up to your spaceship could last as little as under a half an hour, or it could be several days. It all depends on whether you can line up the MAV with the larger spaceship. And if not done correctly, things could go very, very bad. But if all goes according to plan, think of what you've just done. You were the first person on Mars. And after living there for months, what you've learned will make it easier for future generations to live on the red planet. Permanently. Did you know that Mars has polar ice caps just like we do here on Earth? With the right technology, they might be our water source should we ever move to the red planet. But in their current state, these caps could be a source for extreme interplanetary sport. Want to ski on snow unlike anything else in the universe? Want to test your skills on the biggest mountain in the solar system? Bring your 80s snowsuit if you must. Just be sure to pack a good helmet. This is What If, and here's what would happen if you could ski on Mars. Even though Mars is much smaller and much colder than our planet, its abundance of water ice makes it a compelling option for life on another planet. And with the concept of a future Mars colony gaining popularity, homes on the red planet might soon be on the market. If we do end up living on Mars someday, what would we do for fun? Technology will have advanced, so there'll be a lot on offer. But what about the classics, like enjoying the great outdoors? Could we go skiing on Mars? Lucky for you, Mars is home to the highest mountain in our solar system. Olympus Mons is a shield volcano that's 21,000 meters tall. That's more than 4 times higher than the highest ski slopes on Earth. But if you call yourself a black diamond devil, then this isn't the hill for you. It turns out Olympus Mons is more boring than the Bunny Hill. It has an average slope of just 5 degrees. And considering that Martian gravity is just 1/3 of what we experience here on Earth, it might take you a while to get started. On the flip side, because of that weak gravity, you could jump 3 times as high. So this could be this. let's not get ahead of ourselves. We haven't even started moving yet. With an average temperature of minus 60 degrees, it's definitely cold enough to snow on Mars. But considering its dry, low-pressure atmosphere, snow barely reaches the surface and never stays for very long. That said, Mars does have two poles that consist of water ice and carbon dioxide, which in solid form is dry ice. And at Mars's south pole, there's a dry ice deposit that's 1,000 meters deep. But before you give it a go, it's important to note that the friction from your skis will heat up the dry ice and turn it into a gas, causing you to lose control. If you really wanted to, you could try your luck on the water ice, but its density brings it closer to the ice skating conditions you'd find on Earth. So why use a flat ski when you could go further with a sharp blade? Then again, there's more than one way to ski, so if you're that determined to make this work, then just slap on some hard wax and take things cross-country. Or is that cross-planet? Whichever style you choose, it's a double-edged sword. Shorter and thinner skis are your best bet for reaching fun speeds, but they're also going to have to support your clunky space boots. And if you don't get the balance right, well, you had a good run.
Mars didn't always look like this. It may once have been covered in oceans. But what if we brought all the Martian water back and transformed the red planet into one that's half blue? What would Mars look like if it was 50% land and 50% water? Where would we even find enough water to fill Martian oceans? And why might we have no choice but to nuke the red planet? This is What If, and here's what would happen if Mars was half land and half water. Long ago, Mars could have been covered by a massive ocean, and there may have been rivers, streams, and lakes spreading out across the planet too. It might be that billions of years ago, Earth and Mars had similar climates. Except the Martian ocean covered only 20% of the planet compared to Earth's 71%. And the surface temperature was a bit cooler. All of that thanks to an atmosphere that didn't stick around long enough. 4 billion years ago, Mars lost its protective magnetic field. And the solar winds started to carry all of its atmosphere off into space. A few 100 million years later, Mars changed from a warm, wet world to what we know it as today. Cold and dry. Only 18% of its ocean remains, trapped in frozen polar ice caps. So if you wanted to turn Mars into a half-land, half-ocean kind of planet, you'd need to add a whole lot of water. Unlike Mars, most of Earth is covered with oceans. So what do you say we donate some of that water to our red neighbor? Well, let me tell you, that's a very, very bad idea. To make Martian oceans as deep as Earth's, you'd need to ship out about 20% of our ocean water. And this would suck for our marine life. Yeah, leave the Earth's oceans where they belong. Besides, there are a few other places in the solar system where you could find water, like Saturn's moon, Enceladus, and Jupiter's moon, Europa. They might have twice as much water as Earth, but to transport some of that precious H2O, you'd need to move massive ice blocks through space. This would be difficult to pull off, to say the least. You'd need rockets capable of transporting huge amounts of weight, and you'd need money. Yeah, a lot of it. 'Cause the price could be as high as $1,500 per kilogram. And considering how much water you'd require, well, the final price tag for this operation would be well into the trillions. Yeah, expensive, I know, but there might be another way of bringing Martian water back. And you'll love this one because it involves nukes. Yeah, you heard me right. You're about to nuke the red planet. And yes, this would give it some water. How? Well, all that energy would release frozen Martian carbon dioxide. This would cause temperatures to climb and thaw out the poles. It would be kind of like causing controlled climate change. Only you'd need to detonate around 3,500 nuclear bombs every day. And this would mean shipping twice as many bombs daily as the United States currently has in its entire arsenal. That's an enormous amount of radioactive material to release. And it wouldn't exactly make Mars habitable. Plus, you'd still need a lot more water to cover half the planet in oceans. Okay, it seems like nuking everything in sight isn't the best idea. Maybe you should take a little planetary history lesson instead. About 4 billion years ago, during the late bombardment period, a non-stop barrage of asteroids collided with Mars. This created enough water to eventually make an ocean 300 meters deep. So all you'd need to do is recreate this event today. You'd have to redirect at least 1 million comets and meteors so that they'd end up on a collision course with Mars. As the comets crashed into Mars, they'd burn up and release water vapor. Rinse and repeat until you get enough water to cover half the red planet. But where would this water go? Well, looking at Mars's topography, you'd find that all this new water would settle mostly above its equator. Mars would have new land masses that would look like continents. There would even be mountains sticking up on some parts of the planet. Olympus Mons, the tallest volcano in the solar system, would now tower high out of Mars's new northern ocean. But just because you were able to bring enough water to cover half the planet, that wouldn't mean it would last. Because of Mars's low atmospheric pressure, all this water would easily boil away. Well, wait, how would it boil away if water's boiling point is 100 degrees Celsius? Aha, well, that's the boiling point on Earth. On Mars, the water would start to boil at 0 degrees Celsius. That's frustrating, especially after all the work you put in bringing all this water to Mars. You'd have to hope that this water vapor would work as a greenhouse gas. If it could trap enough heat in the Martian atmosphere and turn Mars into a lush, terraformed world, maybe then you'd be lucky enough to be the only Earthling ever to go for a swim on another planet. Scientists theorize that many millions of years ago, Mars had rings, just like Saturn. And it looks like the red planet could be due for a new set of rings in the future. How exactly would this happen? Would these rings clutter up Martian orbit? And how soon would these new rings start raining down on Mars? This is What If, and here's what would happen if Mars had rings like Saturn. The 4 gas giants in our solar system, Jupiter, Uranus, Neptune, and Saturn, all have ring systems surrounding them. Of those, Saturn has the largest. And Mars could join the club. Scientists studying Martian moons Phobos and Deimos suggest that Mars could have had several more moons, including one up to 20 times larger than Phobos. Over billions of years, these moons could have been destroyed and become part of an ancient ring system. Could Phobos and Deimos be next on the Martian moon chopping block? Phobos is orbiting Mars only about 6,000 kilometers from the planet's surface, and it's slowly losing altitude. Eventually, it will reach the Roche limit. This is the closest a big space body can come to a planet and still be held together by its gravitational forces. For Phobos, the estimated Roche limit is 5,470 kilometers from Mars. At this point, the tidal forces of Mars would start to pull the Moon apart. After breaking into carbonaceous chondrite meteorites, the stony rocks and dust would form a thin, dark ring around the planet. You'd find that the smaller Martian moon, Deimos, would still exist. That's because it orbits Mars from a comfortable 20,069 kilometers from the surface. Deimos would now mark the outer edge of this new ring. This dramatic reshaping of objects in Mars's orbit could have a big impact on any plans you could have to leave Earth and settle on Mars. Well, maybe not your plans, but more like the plans of your future descendants. Scientists expect that Phobos won't get ripped apart into rings for about 50 million years. The development of rings around the red planet would be a challenge for space flights. It would be difficult to navigate or transport people and resources. Even the most routine trips on or off Mars would become hazardous rides. And a ring system would block some sunlight, having huge effects on our human settlements on the surface. Mars is already a frozen planet with an average surface temperature of minus 63 degrees. So things would get even colder. Let's hope your descendants brought enough warm spacesuits. And even more danger would lie ahead. Eventually, all the objects in the ring would come crashing down on Mars. Big rocks would leave massive new craters on the planet's surface. If it's anything like what happens on Saturn, Martian settlers could face massive storms of rock and dust, falling to the surface at 10,000 kilograms per second. The future of humanity would depend on our ability to create new technologies to blast apart these falling objects before they crush us. Luckily for us, this would happen sometime between 1 million and 100 million years after the ring forms. Yeah, we'd have plenty of time to come up with a solution. Body-crushing pressure, toxic atmospheres, unbearable temperatures. That's what would be in store for you if you visited other planets in our solar system. But what other environmental hazards would you encounter? Which planets would be the safest and which would be the most dangerous? And how long could you survive on any of them? This is What If, and here's what would happen if you spent a day on every planet in our solar system. Before you get started on your journey through the solar system, you should pack a bottle of water. Earth is the only planet known to have consistent bodies of liquid water on its surface, so if you pack enough, you could probably survive a few days just about anywhere, right? Well, sorry to say, I've got some bad news for you. Let's start with a visit to Mercury, the smallest planet in the solar system. This rocky, crater-filled planet is only slightly larger than our moon, and it's located extremely close to the Sun at a distance of 58 million kilometers. Now, even though a day on Mercury equals about 59 days on Earth, your trip wouldn't last anywhere near that long. Due to this slow rotation, you could land on the sunny half where the temperatures reach 430 degrees Celsius, or maybe you'd aim for the dark side where temperatures drop to minus 180 degrees Celsius. Your best bet would be to find a cozy spot somewhere in between. But with an atmosphere mainly composed of oxygen, sodium, hydrogen, helium, and potassium, good luck breathing for very long. even in this middle ground, you wouldn't likely survive more than 2 minutes. Okay, let's check out what a day would be like on the second planet from the Sun, Venus. Well, you should expect a very warm welcome because surface temperatures are a piping hot 475 degrees Celsius. And one day on Venus lasts 243 Earth days. Unless you've got an impossibly robust spacecraft, you couldn't get very close to the surface. And even if you did, you wouldn't last very long. Venus has a thick and toxic atmosphere with 154,000 times more carbon than the atmosphere of Earth. And it's shrouded in yellowish clouds of sulfuric acid. You could say the Venusian atmosphere is a runaway greenhouse effect. Between the toxicity and the heat burning you to a crisp, you wouldn't survive 1 second on Venus. Now, let's skip on over to Mars. Unless you wanted to stop back on Earth for a couple breaths of fresh air. On Mars, you'd find comfort in a day that is a little over 24 hours. What you wouldn't find comfortable is an atmosphere of carbon dioxide, argon, nitrogen, and a little bit of oxygen and water vapor. The surface of Mars is cold, with an average temperature of minus 62 degrees Celsius. Combine the low surface temperatures with the unbreathable air, and you wouldn't survive much more than a few minutes here either. On the next planet, you wouldn't be able to reach the surface. That's because there isn't one on the gas giant Jupiter. This planet is more than twice as massive as all the other planets in our solar system combined. And its atmosphere is primarily hydrogen, helium, and cold, windy clouds of ammonia and water. Jupiter might be bulky, but it rotates fast. One day lasts a mere 10 Earth hours. And because it's so fast, Jupiter's atmosphere has strong jet streams. Plus, the Great Red Spot that is actually a storm, bigger than the size of Earth. If you fell into the planet, you would enter the atmosphere at a whopping 49 kilometers per second. And as you kept falling, the atmosphere would become denser and more turbulent. You might feel like you were slamming into a wall again and again. If you made it 692 kilometers down, you would find pressure levels higher than at the bottom of the Mariana Trench, the deepest place on Earth. If the pressure didn't kill you, the temperature, which averages minus 145 degrees Celsius, certainly would. You wouldn't survive on Jupiter for 1 second. Wow. Now, if you continued on to Saturn, you'd find another gaseous giant without a surface, and like Jupiter, a day lasts about 10.7 hours. Here, you would experience deadly strong winds, reaching up to 1,800 kilometers per hour. With an unbreathable atmosphere made of hydrogen and helium, Saturn is incapable of supporting life. Maybe you'd have more luck on one of its moons, like Titan or Enceladus. These two moons have internal oceans, which could theoretically support life. Okay, moving on to the first of the ice giants in our solar system, Uranus. No surprise here that it also has an unbreathable atmosphere of hydrogen, helium, and methane, which gives the planet its signature blue-green color and the stink of rotten eggs. There are some other unusual hazards on Uranus you'd need to be prepared for, such as mysterious flares of X-rays and lethal diamond rain. Yeah, you heard that right. highly compressed diamonds of carbon atoms raining down from the atmosphere. But don't worry about that. The immense pressure on this planet would kill you in less than a second. Alright, last but not least, Neptune. A dark, cold planet with supersonic winds as strong as 2,000 kilometers per hour. That's faster than the top speed of a fighter jet. So if the pressure didn't kill you, those supersonic winds would probably do the trick. A day on Neptune would last for 16 Earth hours, but your life there wouldn't last a second. Okay, there it is. So in case it isn't clear, Earth would be the only planet you would want to visit anytime soon. Just about anywhere else, you could look forward to a deadly cocktail of high pressure and toxic gas.
Imagine never being able to dream of landing on Mars or traveling to Saturn. Not because it's impossible to get there, but because they didn't exist. Because Earth was the only planet in our solar system. What would the night sky look like? Where would the Earth be located? And how would humanity evolve? This is What If. And here's what would happen if Earth was the only planet in the solar system. The other 8 planets in our solar system aren't just pretty to look at, or something that we strive to travel to one day. Even though they're billions of kilometers away, they've played an essential role in life here on Earth. So, what would happen if they never existed? Each planet in the solar system played a vital role in the development of Earth billions of years ago, and they continue playing a vital role in keeping Earth safe today. For example, take the placement of every single planet. They all have their own little space in the galaxy, and that's not by accident. Our planets work together to keep each other in place. For example, if Mercury and Venus ceased to exist, Earth might drift closer to the Sun. And if Jupiter or Saturn disappeared, instead of getting closer to the Sun, the Earth might drift further away from it. This would cause a number of issues for us Earthlings. Right now, we're lucky enough to live in what scientists call the Goldilocks zone. They call it that because Earth sits in the range of orbits around the Sun that are just right to sustain life. If Earth were to move closer to the Sun, it would get a little bit hot. We might burn to a crisp. The farther away we get, the more the temperature would drop. Earth would be too cold to sustain life. The position of Earth in our solar system not only affects life, but everything that happens on our planet. It affects our seasons, the length of our days, and how long our year is, but unfortunately, the time we wake up will be the least of our worries. With Earth being the only planet in our solar system, there's no telling where it might end up. We could be all the way in the back, where Uranus and Neptune used to be, or somewhere right up front, where Mercury once was. It's safe to say that no matter where we end up, if it's not the Goldilocks zone, there's a pretty good chance there wouldn't be any life here on Earth. If life did form somehow, it would definitely be aquatic. That's because without any other planets keeping us in check, Earth's gravity would be severely different. When we say no other planets, we mean no moons either. The moon's gravitational pull is responsible for the tides here on Earth. Without it, our waters would remain still. The oceans wouldn't rise or fall, they would just stay where they were. So really, Earth as we know it wouldn't exist if there were no other planets. There's virtually no chance that humanity would be living today, but what if, instead of the planets never existing in the first place, one day they suddenly disappeared? Well, apart from Earth violently moving around, not knowing where to go, we'd also have another huge issue to worry about: asteroids. It's clear that every planet is critical to life on Earth. If just one planet suddenly disappeared, a number of issues would go along with it. There are 2 planets that have a very special role in keeping Earth safe: Jupiter and Saturn. That's because while Earth is hanging out, thriving with life, Jupiter and Saturn are getting beat up by millions of asteroids. Flying through our solar system, there are hundreds of millions of asteroids that are trying to kill Earth. Luckily, we hardly see any of these, and that's thanks to Jupiter and Saturn. Because of their enormous size and gravity, they do an excellent job of pulling asteroids into them so that they never make it to Earth. With these planets gone, Earth would be bombarded by asteroids. Not good. In case you've forgotten, a single asteroid hit Earth millions of years ago, wiping out the entire dinosaur population. So this would end up being pretty bad. Earth would soon be covered with massive craters, and once again, life would cease to exist. Luckily, you won't have to worry about any of this. You can rest easy knowing that Earth sits comfortably in this perfect little spot in the universe, where we can all live and thrive.
Make room, Earthling! We're moving the other planets in our solar system into our planetary neck of the woods. Would all the planets fit into this Goldilocks zone? What kinds of gravitational chaos would this cause? And does this mean life would exist on the other planets? This is What If, and here's what would happen if all the planets of the solar system were in the habitable zone. Liquid water is a key ingredient for life, and in our solar system, Earth is the only planet with liquid water on its surface. That's because our planet is located in the habitable zone of our sun, also known as the Goldilocks zone. And the conditions here are just right. Any closer and water would boil away. Any further, it would freeze. The size of this area depends on how hot or cool a star is. Scientists have discovered 4,000 exoplanets within habitable zones, but only 24 of them might be able to support life. In our solar system, this zone is within a range of 0.9 to 1.2 astronomical units from the Sun. So, if we parked all the other planets within this 45 million kilometer patch of real estate, could we kickstart extraterrestrial life? With 8 planets to squeeze in the Goldilocks zone, you'd need to get creative. The last thing you'd want to do would be disrupt the conditions for life on Earth, right? Well, to start this scenario off, you'd need to move Mercury to the innermost portion of the habitable zone. At around 0.9 astronomical units, that would be more than twice as far away from the Sun as Mercury orbits now. Not much would change on this rocky planet, except for a refreshing coolness after billions of years of scorching hot temperatures. Venus already orbits relatively close to the habitable zone at 0.72 astronomical units. When our Sun was a young star and dimmer, Venus was essentially located in a habitable zone. It could even have had conditions for life, with a shallow ocean of its own. But as the Sun got hotter, that Goldilocks zone was pushed further back. Temperatures increased and the oceans boiled away. Maybe relocating Venus to a cooler spot away from the Sun could make it habitable once again. Now, it would be time to do some calculating. You've got 5 more planets to squeeze in. It could be a good idea to make sure all the planets are an equal distance apart. With our narrow Goldilocks zone, you could place each planet 6.5 million kilometers from each other. That would be equal to about 30 times the distance between the Earth and the Moon. Moving us away from our current location would make this whole experiment a little less chaotic, but at about 0.97 astronomical units, things would get warmer here. Bad news for the climate crisis. Ignoring that for now, you'd move on to Mars. You'd be excited to see if this cold, rocky planet could have life. Well, sorry to say, it would still be barren. You see, liquid water isn't the only thing that life needs to thrive. Mars lacks a magnetic field. That means solar radiation would strip away the chances of it having an atmosphere. You'd still have to terraform it. You'd likely not see any life popping up on the remaining gaseous planets either. The gas giants, Jupiter and Saturn, have atmospheric pressures and temperatures far too intense for molecules like DNA to be stable. But you could probably take a cold dip on one of Jupiter's moons, Europa. Its new proximity to the Sun would allow its thick ice layer to melt. Feeling refreshed, you'd realize that the last planet in our solar system, Neptune, is now even closer to us than Mars is today. That means, in our new solar system arrangement, planet hopping would be a reasonable adventure. Even with current technology, you could travel between the planets in 90 days. And beyond the exploration, there are all kinds of resources you could extract from the other planets. You could get hydrogen fuel from Jupiter and Saturn to help us transition to a low-carbon future. You could mine cobalt from asteroids. This would be important to developing renewable energy systems. But this new solar system would be a little unstable, to say the least. Especially with a massive planet like Jupiter so close to us. It has 2.5 times the mass of all the other planets in our solar system combined. Scientific reports indicate a star similar to our Sun could have 6 Earth-sized planets within its habitable zone. With Jupiter, gravitational stability would be all out of whack, and all these imbalances could result in the planets or moons getting ejected from orbit or reshuffled completely. Billions of years from now, the Sun will become a red giant, and then it will slowly die. That's right, it's the end of the solar system, and this is your survival guide. What will happen when Earth becomes too toasty to sustain life? Where else in the solar system could human civilization live? And what would the Sun be like in its final days? This is What If, and here's what would happen if you survived the end of the solar system. For around 4.5 billion years, our Sun has been the bright center of our solar system. It's fueled by the nuclear fusion in its core, and it burns through 661 million tons of hydrogen every second. During its stellar lifespan, the Sun has burned through about half of its fuel source. That means our Sun has another 5 billion years left in it. As the Sun uses up its hydrogen through nuclear fusion, it becomes more saturated with helium, and that makes it spit out even more energy. Every billion years that it burns hydrogen, our Sun gets about 10% brighter. Eventually, all that energy will push out the Sun's outer layers, and our star will swell in size. Then we'll have a red giant at the center of our solar system. Game over, right? Let's fast forward to around 1.5 billion years from now. Sorry to say, but things won't be looking too good for life on Earth. The Sun's increased brightness will set off intense global warming. Our planet will become so hot that our oceans will start to boil. The increasing heat and radiation of our Sun will shift the habitable zone of our solar system. And now, the area where liquid water could exist will move out toward Mars. Yeah, Mars will now become habitable. And it could be humanity's first destination for settlement. But to create a breathable atmosphere, we'd still have to terraform the red planet. At this point, Mars could remain habitable for as long as 5 billion years. That'll give us plenty of time to make our next move. But in about 7.5 billion years, our solar system will have a giant problem. A red giant problem, of course. Our star will run out of its hydrogen fuel and start burning helium instead. The sun will expand, completely vaporizing Mercury. The atmosphere of Venus will burn up. Eventually, the expanding sun will swallow Venus whole. And our Earth? Well, it will get reduced to a dense, hot iron core. Our new home on Mars won't be habitable anymore either. Humanity's best hope would be to hop over to Europa, Jupiter's fourth largest moon. Its thick layer of ice will melt from the sun's increased heat. Europa could become a wonderful water world. Jupiter's moon could be our home for a few 100 million years. That's when the sun will reach its maximum size as a red giant. It will shine about 3,000 times brighter than it does today. And its surface could extend well beyond Earth's orbit. 8 billion years from now, the sun could make life intolerable as far as Pluto. Our best hope at that point would be to find a home on a distant dwarf planet in the Kuiper Belt. The temperatures there could be similar to what we were used to on Earth. Life on Earth would be a thing of the very, very distant past for this generation of humans. 2 billion years after that, our sun's fuel reserves will completely dry up. The sun will become unstable and will start to pulse. This will cause it to shrug off its outermost layers. The sun will change from a red giant to a white dwarf. This means it will shrink until it becomes the size of Earth today. It will blast off massive amounts of X-ray radiation, but less heat. So the habitable zone will dramatically shift once again. It could go from the Kuiper Belt to about where Mercury used to be. For human civilization to continue, we'd have to move onto another star's habitable exoplanet. Our white dwarf star would radiate for quadrillions of years, so moving back to its new habitable zone wouldn't be a good idea. When our former sun used up the last of its energy, it will no longer be able to shine or radiate heat. But it will still have mass and gravitational pull. It may become a black dwarf. Scientists have yet to find any such stars, as they would have to be much older than our 14 billion year old universe. When I say jump, you say how high. Okay, let's put this to the ultimate test by hopping around the solar system. Literally. What differences in gravity would you experience? On which planet could you jump as high as a house? And on which planets would jumping lead to your demise? This is What If. And here's what would happen if you jumped on every planet in the solar system. Every object with mass is subject to gravity. This includes you, of course. Whether you're standing on your 2 feet or lounging on the sofa, the Earth's gravity is pulling you toward the center of the planet. When you jump, the force of your muscles allows you to overcome that gravity and accelerate upward. Once you're in the air, gravity slows you down, and eventually your velocity hits zero and you fall back to the surface. The planets in our solar system come in all sizes, so the force of their gravity differs too. Your mass would stay exactly the same, but from one planet to the next, your weight would be very different.
You guys lost a pound.
So, could you bound gracefully over mountains on one while on another you'd barely be able to lift a toe? Your interplanetary jumping experiment would begin right here on Earth. Okay, not the most exciting place to start, but a good place of comparison. If you're close to the average jumper, you should be able to squat, swing your arms, and leap about half a meter high, all in about 1 second. But don't let me underestimate you. If you're an extremely talented athlete, like Javier Sotomayor, you could set a new world record by jumping over 2.45 meters. Whoa, not too shabby. Making a quick first stop on the moon, you'd find gravity 6 times weaker than it is on Earth. Well, that's because the moon has about 80 times less mass. Here, you'd only need to jump at a velocity of 2 kilometers per second to lift off the surface. And with your average jumping velocity, you should be able to jump about 3 meters high. Meanwhile, Earth's most talented jumper would be able to bound over an entire house. Okay, moving on to the rocky surface of the planet closest to the Sun, Mercury. With a spectacular close-up view and temperatures hitting 430 degrees, you'd be drenched in sweat already. Mercury is smaller than Earth. The gravitational pull is about 1/3 of what you're accustomed to here at home. So, despite exhausting conditions, you'd be able to jump about 3 times as high. Okay, let's get out of the frying pan and into the fire by taking a leap on an even hotter planet, Venus. Very similar in size to Earth, this planet has a surface gravity about 91% of Earth's. Here, you'd be able to jump ever so slightly higher than you could back home. But you definitely wouldn't want to hang out for too long in this thick, scorching hot atmosphere. So, time to cool off on Mars. You better keep your leg muscles warm though. The average temperature on the red planet is minus 62 degrees. But the good news, you'd feel lighter. Mars has about 10 times less mass than Earth, and for this reason, you'd be able to jump to nearly the exact same height as you did back on Mercury. Okay, now leaving the rocky planets behind, it would be time to test your skills on a gas giant, like Jupiter. This planet is so large that all the other planets of the solar system could fit inside it. Jupiter has very intense gravity, so you'd be feeling a lot heavier than you do right now. If you tried to jump here, you'd only be able to get a pathetic 20 centimeters off the ground. Now, if it helps your ego, this scenario would be impossible for a simple reason. It's because the gas giants have no surface to jump from, so you'd have to stay on top of your spaceship. And if I can offer some advice, don't fall off. On Saturn, you'd be surprised to find that you can jump only about 3 centimeters less than you could on Earth. Despite the planet having 95 times the mass, Saturn's surface gravity is quite similar to our home planet. Okay, now heading toward the dark, cold edges of the solar system, you'd take your leaps on Uranus and Neptune. Just be sure to avoid slipping on these ice giants. On Uranus, you'd find a relatively familiar gravitational pull. Because of this, you'd be able to jump about 6 centimeters higher than you could on Earth. Then finally, you'd reach the bleak, foggy surface of Neptune, and despite your aching muscles, you'd power through for one last jump. And that could be tough, considering the severe winds that dwarf even the largest hurricanes back on Earth. But you'd take your best shot, and struggling against the slightly stronger gravity, you'd reach 44 centimeters, roughly the same as back home. speaking of back home, I think it's time to head back.
What would happen if our planet got too close to a black hole? Well, according to science fiction, we'd be sucked into a parallel universe. Or maybe even the future. But in reality, it wouldn't be nearly that fun. Instead, our planet would be ripped apart piece by piece, starting with our atmosphere. So, what if we moved a little further back? Instead of the black hole being right beside us, we move it to the center of our solar system. Would our planet still be destroyed? And what would that do to our solar system as a whole? This is What If, and here's what would happen if the solar system orbited a black hole. This black hole has the same mass as our Sun. If we were to place it next to our Sun, the two objects would orbit each other at a close distance, about 1/10 the distance between Earth and the Sun. This would mean that our solar system was now orbiting a local point with twice the mass of the Sun. As a result, the planets would have to orbit faster to avoid getting pulled inwards. A year on Earth would decrease from 365 days to 258 days, and the amount of energy from the Sun would vary as it orbited closer to and farther away from Earth. Other than that, life would pretty well be the same. But what if we replaced our Sun with a black hole completely? Well, we'd have a lot more to worry about than just the length of a year, which, by the way, would be over in the blink of an eye. The biggest problem we would face if we replaced the Sun with a black hole would be the absence of incoming solar energy. The planet Earth would go completely dark. Thanks to our planet's infamous greenhouse gas effect, the global temperature wouldn't be reduced instantaneously. But after the first week, Earth's average surface temperature would drop to 0 degrees, and then to negative 101 degrees by the end of the first year. You'd think that our planet quickly becoming an ice world would be bad enough, but we're just getting started. Without sunlight, there would be no photosynthesis, the process by which all plants generate food. Small plants would die in a matter of days. This would create a ripple effect throughout the entire food chain, causing us all to starve to death eventually. But maybe there is a way we can get usable energy from a black hole, and it all starts with something called CMB. CMB, also known as cosmic microwave background, is the weak radiation left over from the Big Bang. Theoretically, if a black hole spins fast enough, it can compress the CMB radiation into optical wavelengths, the same wavelengths that are emitted by the Sun. The wavelengths would funnel into a narrow beam, and before you know it, our planet would have usable energy once again. All right. But there is a small catch. The faster rotation of the black hole would also pull the planetary orbits in closer to the point of no escape. For the planetary orbits to remain stable and avoid being sucked up, the orbital velocity of the planets would need to be close to the speed of light. This means that a year on Earth would be over before the blink of an eye. So much for your big New Year's Eve party. But there's no time to worry about that because we've got bigger issues coming our way. If any material like meteors, satellites, or space debris gets sucked into the black hole, it will result in a blast of radiation coming our way. And when the radiation arrives at our planet, it will blow away our atmosphere, killing anything in its path. So, even though the Sun can be annoying sometimes, when it comes to things to orbit around,
we could do a lot worse.
Unlike Earth, which is orbiting the Sun, there are billions of rogue planets roaming the Milky Way, not bound to any host star. One of them has been spotted on the edge of our solar system. What if this interstellar object swung through it? How would this space invader affect the orbits of the planets? Could it possibly push Earth out of the habitable zone? This is What If, and here's what would happen if a rogue planet entered our solar system. If a planet doesn't belong to any star system, it's considered a rogue planet. This is an interstellar planet with a catchy name, just 20 light years away from us. It's nearly 17,000 times the size of Earth and has a powerful magnetic field that makes the planet glow with incredible auroras. What if this massive alien planet trespassed the borders of our solar system? Would this mean the end of life here on Earth? Once the interstellar planet invaded our solar system, things could go very wrong. This rogue planet would likely be moving at hundreds of kilometers per second. If we were unlucky enough to be on a collision course with this massive alien object, the Earth would be completely demolished. But don't worry, our solar system is quite big, and the chances of the rogue planet bypassing us without a fatal collision are pretty high. Instead, our interstellar guest would be busy disturbing the orbits of all the planets in the solar system. That's because a rogue planet nearly 13 times bigger than Jupiter would have a huge gravitational impact, making other planets' orbits, including Earth's, more elliptical. And that's when the bad news begins for life here on Earth. The Earth is orbiting the Sun's relatively narrow habitable zone. Within this zone, also known as the Goldilocks zone, it's not too cold, so our water doesn't turn to ice, and not too hot, so it doesn't get vaporized, and neither do we. Just perfect. Change the Earth's orbit, and the conditions for life won't be so great. The rogue planet may not push us out of the habitable zone, but it would bring us much closer to the Sun for very short and exceptionally hot summers. Those extreme summers would be followed by long and super cold winters. Quick summers would leave us less time to grow crops. By the end of our first never-ending winter, humanity could face food shortages, even extinction. The Earth might be thrown into the next ice age. Instead of global warming, we'd be worried about global cooling. We'd rethink our energy sources and try to pump out more greenhouse gases to warm the planet up a little. Solar energy, on the other hand, would be considered very inefficient in the wintertime, but could be used very effectively during the short blaze of summer. Count on things being much worse if the Earth gets knocked out of the habitable zone. At that point, the Earth would considerably cool down. All our water would freeze, and so would we. This would be the end of most life on Earth. The only way we could survive would be if we learned to live at the bottom of the ocean, next to deep-sea thermal vents that push out extremely hot water. Maybe eventually we'd evolve into a different life form that would take control over the frozen planet. Lucky for us, the universe is enormous. There's a lot of space between rogue planets and other objects in our galaxy, and that makes this scenario very unlikely.
Moving. It's never easy. The packing and unpacking, having to start fresh and make new friends, all this can be challenging. But let's face it, whether it's a nasty landlord or imminent threat to humanity, sometimes you just have to move. In another What If, we looked at moving the Earth to avoid certain danger, but what if that wasn't enough? What if we had to build a stellar engine to move our entire solar system? How could we do it? Where would we go? And what would happen to us here on Earth? This is What If, and here's what would happen if we moved the solar system. To move our solar system would require an incredible amount of energy and careful planning. We could potentially do this with a stellar engine, a class of hypothetical megastructures using a star's radiation to create usable energy. Thankfully, with our planets locked in orbit of the Sun due to its immense gravitational pull, we only have to find a way to propel the Sun, and our planets and moons will follow. Russian scientist and aeronautical engineer Leonid Shkatov proposed an ingenious method to move our Sun using a giant parabolic mirror
known as the Shkatov thruster. It works by harnessing the sun's photons and reflecting them back around the sun, creating thrust. Each photon carries a tiny amount of thrust, meaning if you were in space and you turned on a flashlight, you would eventually move. Just very, very slowly. The sun produces 10 to the power of 45 photons per second. This impressive energy makes the sun the most powerful nuclear reactor ever. As a result, we would have to position this parabolic mirror exactly over the sun's poles to avoid burning one of our nearby planets. This limits the direction we could move, and it would likely take us 230 million years to move 100 light years. That's an astronomical amount of time, so is there a faster and more efficient way we could move the sun? Astrophysicist Matthew E. Kaplan of Illinois State University has proposed a new type of engine called the Kaplan thruster. This stellar engine requires 1 quadrillion satellite mirrors, known as a Dyson swarm, to orbit the radius of the sun. These would reflect the sun's energy in a concentrated area, heating it up and shooting the sun's mass and solar winds outward, allowing us to utilize the billions of tons of hydrogen and helium collected using large electromagnetic fields. A thermonuclear reactor on board could conceivably convert the helium and hydrogen into radioactive oxygen used as exhaust to propel the craft. And any leftover hydrogen from the sun would be shot in a jet of plasma using a particle accelerator, pushing the sun forward and keeping the thruster from being sucked into the sun's gravity. This delicate balancing act would allow us to move in any direction we want at much greater speeds. The real challenge might be building the Dyson sphere itself. For one thing, we would have to mine Mercury for its rich supply of metals and minerals. This would take a considerable amount of time and effort, but could provide us with an almost infinite energy source. Learn more about that in our other video, What If We Built a Dyson Sphere? Now, what would it feel like on Earth when our entire solar system goes surfing through space? Well, turns out everything might feel more or less the same. Researchers at Illinois State University believe that shifting the solar system wouldn't disrupt our planet's orbits, since the thrust of a stellar engine would create just a small acceleration overall. As we orbit the sun orbits the galactic center of the Milky Way. We don't feel this movement because it's constant. If the Earth suddenly stopped moving, however, we'd be in cosmic trouble. With so many travel destinations in the universe, we'd still be limited to only a small portion of it, known as the local group. This collection includes our massive Milky Way galaxy, the Andromeda and Triangulum galaxies, and about 50 other dwarf galaxies. Now, due to the mysterious force of dark matter, scientists have discovered that the universe is rapidly expanding. Even though we can see them, all the other galaxy groups are moving farther away from us at speeds we'll never be able to reach. We'd be better off looking for other habitable planets like ours within our own galaxy. In approximately 4.5 billion years, our Milky Way will eventually collide with the Andromeda galaxy, forming Milkdromeda. At this point, galaxies outside the local group will be so far away we won't even be able to detect them like we can now. Future civilizations born in the Milkdromeda universe may think that the local group is all that there is. They wouldn't be able to learn about the Big Bang and may think that the universe is static and never-ending. So consider yourself lucky to be living in a time where we can research the past and possible future of our own universe.
This blue marble-like planet looks just like Earth, but only 5 seconds on this hostile death orb would kill you. Welcome to HD 189733b. This planet is enormous, even larger than Jupiter. And to keep comparing it to the largest planet in our solar system, it's also entirely made of gas. That's why scientists classify HD 189733b as a hot Jupiter. This planet is located so close to its star that it completes its orbit in just over 2 days. Yeah, HD 189733b is 13 times closer to its sun than Mercury is to our sun. And even though its star is cooler than ours, this fake Earth is still way outside its star system's habitable zone. That means no liquid water can exist on a planet's surface. Just how this giant gaseous planet developed so close to its star is still a mystery. One theory is that HD 189733b formed right next to it during the star's earliest moments. Or it could have developed further away, only to be pulled in as the rest of the planetary system formed. But there's one thing we know for sure. A visit to HD 189733b would be a plunge into hell with no chance of escape. Now, even if you knew there wasn't a single drop of liquid water on this planet, you'd have a hard time believing it as you approached the giant blue marble. With an average daytime temperature of nearly 1100 degrees Celsius, this planet is twice as hot as Venus, and Venus is the hottest planet in our solar system. One of the reasons for this intense heat is that the planet is tidally locked to its star, just like our own moon is to Earth. That means HD 189733b takes as much time to spin on its axis as it does to revolve around the star. So one side of the planet is constantly in daylight, while the other side is shrouded in darkness. The inviting look of this world doesn't come from its oceans like it does here on Earth. No, this hellish planet gets its color from clouds of molten silicate particles. These particles scatter more blue light than red, making the planet appear blue. Silica is the primary ingredient in glass, and you should bring a heavy-duty umbrella because you'd need to take cover from what would essentially be hot, molten glass rainstorms. But that's not the only danger. You'd need to be ready to brace yourself against the extremely powerful winds that you'd find sweeping across the planet. With speeds up to 7,000 kilometers per hour, these gusts are almost 30 times stronger than even the most powerful Category 5 hurricanes on Earth. Compared to the strongest winds on other planets in our solar system, HD's winds are almost 4 times stronger than those on Neptune. But hey, they might smell a little better than the ice giant's hydrogen sulfide clouds. Those carry a whiff of rotten eggs. HD's winds are so fast that they'd whip past you at about 6 times faster than the speed of sound. They would be extremely loud, but I think you'd be more worried about them tearing your body apart. You might be long gone by now, killed by that molten glass rain. In any case, you wouldn't last too long on HD 189733b. I really don't recommend traveling there. But there are some planets out there that can kill you even faster. Check out OGLE TR56b. This gas giant sits in a galaxy nearly 100 light-years away from Earth. It's even larger than HD. Its mass is nearly 1.4 times as much as Jupiter's, and somehow, it's even closer to its star, too. You'd find this world to be incredibly scorching hot. Surface temperatures on this planet average around 1,700 degrees Celsius. That's so hot that it turns metal to gas. Of all the planets in the universe, Earth is clearly the best for life, right? Wrong. Earth may be great, but scientists have discovered a few worlds that could be even better for life. Behold, KOI 5715.01. Most of the contenders on our Superhabitable Planet list aren't the ones you could visit anytime soon. They are very far away. The top spot is held by one 3,000 light-years away from our solar system. KOI 575.01 would appear to satisfy the most basic requirement for supporting life. It exists in the Goldilocks zone of its star, so conditions wouldn't be too hot or too cold for a key life-supporting ingredient to exist on its surface: liquid water. But it would also check off many boxes to be considered superhabitable. The planetary system it belongs to could be 5.5 billion years old, which would make it around 1 billion years older than our own solar system. And the planet would almost fit the size requirement. When looking for superhabitable worlds, scientists keep their eyes peeled for planets that have a mass up to 1.5 times of our planet. And they should be about 10% larger, too. This size difference would help the planet retain heat. And if its average temperature was about 5 degrees Celsius higher than Earth's, well, this planet could have even richer biodiversity. Now, being almost double the size of Earth, KOI 5715.01 might overshoot this condition a bit. Besides, studies indicate that this planet is actually colder than Earth. But there's still hope. With the right atmospheric composition, a strong greenhouse effect could raise temperatures to the desired level. And as far as superhabitable worlds go, well, we're just getting started. Approximately 2,700 light-years away is Kepler 69c. This super-Earth could be around 7 billion years old. This puts it perfectly in the estimated 5 to 8 billion year old age range for superhabitable planets. This range is based on the 3.5 billion years it took for complex life to appear on Earth. So the best chance for finding life could be on a planet a little older than us. Only this exoplanet could be a little too big to be superhabitable. It has a mass almost 4 times that of Earth. A rocky planet this big could have a single colossal continent that would have huge deserts in its center. But the coastline, washed by Kepler's ocean, could be your perfect spot to move to. Our next super-Earth shares a similar name, Kepler 1126b, except it would be located ever so slightly closer to home. Yeah, this planet is about 2,073 light-years away, and it belongs to a system that is 7.5 billion years old. It also orbits a yellow dwarf star, much like our own. Only Kepler 1126b is 2.5 times closer to its star than Earth is to the Sun. But that's no big deal because the star Kepler 1126b orbits is cooler than ours, so the habitable zone would exist in a range much closer in proximity to it. If you aren't feeling this nearness to a scorching hot star, there's another super-Earth on our list. And it's at a reasonable distance from home. Speculos 2c is located only 106 light-years away. Not that its proximity gives it any kind of advantage. It would still take you well over 200,000 years to travel to this super-Earth. And that's if you moved at the speed of NASA's Parker Solar Probe, the fastest probe ever launched. Speculos 2c does look promising, though. It's about 40% larger than Earth. There's also the potential for it being a rocky planet, just like ours. Now, despite the fact that it also exists in a habitable zone, its red dwarf star is still very small. It's only about 15% the size of our Sun. So this planet orbits around its star at a very close distance. And this close distance could mean that Speculos 2c is tidally locked to its star. This super-Earth takes 8.5 days to make one full rotation on its axis, as well as one orbit around its star. That would leave one side of the planet in constant daylight and the other in endless night. This means that life could be possible in the Terminator Zone, the thin strip of land between the two sides. We just need to get a better look to find out for sure.
You know, of all those planets, I'd be most interested in exploring Speculos. I imagine it smells like gingerbread and cinnamon, and it tastes delicious. My Belgian friends know. Speculos is a famous cookie originating in Belgium. But this planet wasn't named after the cookie. It's actually named by Belgian astronomers after the Speculos planet hunting telescopes. In this case, Speculos is an acronym for Search for Habitable Planets Eclipsing Ultra-Cool Stars. Okay. More great space discoveries ahead, including a look at the Bermuda Triangle of space. But first, I've got something even scarier than that. The closest black hole to Earth, at least that we know of.
Black holes are dark, matter-devouring balls of gravity. Most of them are so far away that we don't need to worry about them, but not this one. Meet Gaia BH1. This enormous black hole sits right outside our solar system. More specifically, 1,600 light years away from us. Now, that might sound like a huge distance, but it's way closer than any other black hole on record. What's worse, we didn't even know about it until now. Despite Gaia BH1 being 10 times more massive than our Sun, we couldn't see it. Scientists usually discover these monstrosities by spotting the gas that a black hole feeds on. These hungry giants are called feeding black holes. Only Gaia BH1 isn't anything like that. This black hole is dormant. It hides in the darkness, patiently waiting for the galaxy to throw it some cosmic matter to feast on. But there's one thing that gave away Gaia's presence. You see, most star systems in the universe are binary. That means they have not one, but two stars orbiting each other. Our black hole neighbor is also part of a binary star system, except instead of two stars, this system has one star and one black hole. Yeah, Gaia BH1 was disguising itself as a star. But even though this monstrosity doesn't feed on any gas or matter yet, it still couldn't help but jiggle its star counterpart a little. Yeah, good try, Gaia, but we still caught you. Out there in space, there are black holes a lot scarier than Gaia BH1. And some are so bizarre that they shouldn't even exist. A team of scientists discovered an unbelievable black hole and gave it the melodic name LB1. The weird thing about this black hole is that it's just too massive to be true. Okay, let's get some facts straight. We know of two types of black holes. Stellar black holes are what massive stars become when they die. They're everywhere in the universe. Even in our Milky Way galaxy, there could be as many as 1 billion of them lurking around. These beasts can be between 10 and 24 times as massive as our Sun. The other type of black holes are supermassive ones. These enormities sit at the center of almost every galaxy, including our own. We don't really know how they form, but we do know that they're unimaginably gigantic, billions of times more massive than our Sun. But LB1 doesn't fit either of these types. At 70 solar masses, it's too enormous to be a stellar black hole, yet it's too tiny to be a supermassive one. Scientists were scratching their heads trying to explain this phenomenon. Some theorized that it might not be a single black hole, but two black holes orbiting each other. Others guessed that LB1 was born of a gigantic star that was still in the middle of becoming a black hole. Well, the answer was simpler than we thought. LB1 isn't a black hole at all. It's an optical illusion caused by two rare stars orbiting each other. It's a unique star system to stargaze. But when scientists said they found an improbable black hole, well, they were wrong. But please, how could you blame them? It's pretty hard to study an object 15,000 light years away. Mistakes happen. The good news is that LB1 didn't upend our understanding of black holes after all. Now, that doesn't mean that black holes can't blow your mind. Remember the one at the center of the Milky Way? Yeah, it's called Sagittarius A star, and it's as massive as 4.5 million suns. But there's always a bigger fish in the universe. Sagittarius A star might be the most massive monster lurking in our galaxy, but it's not even close to some of the really big players out there, like Ton 618. This black hole is devouring matter 10 billion light years away from us. It's as bright as 140 trillion suns. So bright that it outshines its own galaxy. And its mass? Yeah, 66 billion times that of our sun. Yeah, that's right, 66 billion. Ton 618 is horrifyingly big. When scientists discovered it, they began to wonder if even more massive black holes were possible. Of course, the name supermassive wouldn't do bigger black holes any justice, so astronomers came up with a cool name for them too. Stupendously large black holes, or slabs. Yeah, and then they found one. Move over, Ton 618, there's a new gargantuan black hole in town. This stupendously large monstrosity sits at the center of Phoenix A galaxy, around 8.5 billion light years away from us. It's almost impossible to imagine how enormous this thing is. Scientists think it has a mass of 100 billion suns. That's more massive than some galaxies out there. And it won't stop growing. The event horizon of this black hole at the center of Phoenix A is unimaginably huge too. It has a diameter of about 100 times the distance between the Sun and Pluto. If you jumped on a SpaceX Starship and tried to fly across this black hole, it would take you 2,500 years to complete that journey. Yeah, we're lucky that this monstrous slab is so far away from us that we don't have to worry about it swallowing our solar system whole. But there are two more supermassive black holes very close to Earth. And they're on a collision course with each other. Okay, when I say very close to Earth, I mean 500 million light years away from us, but still closer than a lot of the other scary things out there. Seriously though, we don't know what exactly happens when two supermassive black holes collide. We've never observed a full merger of supermassive giants. Scientists think that they'll dance around each other for about 200 million years before finally becoming one. But this would be a violent marriage. As the black holes spiral together, they'll send enormous gravitational waves through space. Waves so big that we'll be able to detect them from our planetary neighborhood. But that's not the scary part. Mergers like that happen all the time, and right now, the Milky Way is on a collision course with the Andromeda Galaxy. When our two galaxies become one, what will happen to the supermassive black holes at their centers? Will they merge too? Would an event like this tear everything in its vicinity to shreds? Yeah, I bet that's what keeps astronomers up at night.
Just north of the Martian equator lies a 45-kilometer wide impact crater that scientists believe may have been the site of an ancient lake. Here at Jezero Crater, scientists theorize that its frozen soil may contain the most significant discovery of humankind: life. On February 18th, 2021, NASA's Perseverance rover started searching this crater to find out if we're truly alone. What is the likelihood of life on Mars? What would these Martians look like? And how will we send samples back to Earth? This is What If, and here's what would happen if we discovered life on Mars. As Scientific American puts it, it would take a near miracle for Mars to be sterile. Astrobiologist Chris McKay at NASA believes that Earth and Mars have been sharing materials for billions of years. Kind of like using your roommate's spice rack. What? I thought you said it was communal. Comets or large meteorites that have hit Earth may have also sent debris onto Mars. A tiny fraction of this debris on Mars could have carried the same microbes that kick-started life as we know it on Earth. But what would this alien life look like? Many scientists agree that whatever life on Mars we might find would need to be incredibly robust. With the combination of radiation and freezing temperatures on Mars, could any life form survive such a harsh environment? As far-fetched as it sounds, microbiologists have discovered many organisms that thrive in extreme environments. The tardigrade, or water bear, is a highly resistant extremophile. It can withstand heat, cold, pressure, radiation, and even a complete lack of oxygen. There are also certain types of bacteria on Earth that rapidly produce spores when faced with hazardous conditions. The bacteria can then hibernate during an extended period of drought and withstand intense ionizing radiation. A team of 1,000 geologists, chemists, physicists, and biologists worldwide have drilled 4.8 kilometers into the Earth and discovered robust life forms. Mars has a similar geological past to Earth, so looking underground could be a great place to start. By drilling into the Jezero crater, we could encounter spores associated with a relatively recent geological era. And on future missions to Mars, we may dig deeper and uncover fully vegetative microbes. To find rock samples that might support life, NASA's Perseverance rover uses an array of lasers called a supercam. It can study the surface of Mars at a distance. One of the lasers will heat a rock sample and vaporize it. This creates a plasma that can be analyzed to understand its elemental composition. Another laser will reveal which compounds are in the dirt. If the supercam detects organic molecules or elevated concentrations of elements like nitrogen or phosphorus, the rover will head over to take a closer look. It will then scan the soil in greater detail to detect any organic material hiding in the dirt. NASA's team on Earth has only one shot at picking the right spot to gather these samples. With limited space on board the rover, only a few dozen samples can be collected. So, no pressure and fingers crossed. If all goes well, NASA plans to bring back samples known for preserving biosignatures on Earth.
biosignatures are faint molecular traces left behind by microbes billions of years ago. Once the samples are collected, NASA and the European Space Agency plan 2 missions to get them back to Earth. This involves blasting tubes of rock and soil samples into orbit to be collected by another spacecraft and then returned to Earth. Whoa, this looks kind of fun. If Perseverance's mission is successful, the discovery of life on Mars would be as groundbreaking as the discovery of DNA. In 1543, Copernicus boldly shook the status quo with his theory that the planets orbited the sun. His discoveries completely changed our worldview, no longer putting Earth at the center of the universe. Discovering life beyond Earth could be just as powerful. But not finding any life could raise more questions. Is the Earth truly special? Are we alone out here? Even if we don't discover life, these Martian rock samples will allow chemists to study the geochemistry, mineralogy, and foundational bedrock materials of Mars in detail. This could provide us with essential insights into the climate history of Mars and help us better understand Earth's climate as well. In 1976, 2 Viking landers became the first spacecrafts from Earth to touch down on Mars. They too probed for life in the Martian soil, and the results are still debated to this day. One experiment indicated that the Martian soil tested positive for metabolism. On Earth, this would almost certainly suggest the presence of life. But another related experiment found no trace of organic material whatsoever. While most scientists have not reconciled the conflicting results, the consensus is that there's no conclusive evidence of life on Mars. But several researchers disagree. Recent discoveries of terrestrial microorganisms surviving outside of the ISS indicate that life may be resilient enough for Mars. And methane in the Martian atmosphere could be a sign of microbial methanogens, a type of microorganism that produces a significant amount of methane. Stinky aliens. Mind you, it's possible that life on Mars didn't have the right conditions to start at all. Or maybe it died off from an extinction event, similar to the asteroid that wiped out the dinosaurs. Or it's even possible that we might end up finding life that was accidentally brought to Mars by one of our many rovers. Let's hope this Perseverance mission doesn't turn into a $2.7 billion facepalm. If Mars is your bag, well, have you ever thought about setting up shop there? With recent developments in rocketry, colonizing Mars might be possible in our lifetime.
Okay, colonizing Mars sounds like a fun idea, but in reality, would you really want to move there? I wouldn't consider it a spare Earth. It's pretty inhospitable. Now, it's possible we could make it habitable, but if we have that kind of capability, why don't we look at something else in the universe that's a little more people-friendly? Well, later on we'll explore one possible friendly candidate, Kepler 22b, but it's 635 light-years away. You want to make that move? I'm happy to move if the planet has beaches and long summers and waterfalls and mangoes, but unless this planet is better than Earth, I say we stay right here. Watch this.
Could there be an even better planet for us than Earth? Scientists are searching for a super habitable world that wouldn't just rival Earth, but be a place where life could thrive even more easily. And they're looking at exoplanets. How would we discover Earth 2.0? What would make an exoplanet habitable? And how long would it take to get there? This is What If, and here's what would happen if we discovered Earth 2.0. You wouldn't be able to find an exoplanet by looking through a telescope. All you'd see is the bright glare of the stars they orbit. NASA built the Kepler telescope to discover exoplanets. And before it ran out of fuel, the Kepler telescope surveyed our region of the Milky Way galaxy. Its technology uses the transit method to find planets hundreds of light years away. How? It measured the fluctuation of light coming from distant stars. When a planet transits or passes in front of a star, the star isn't as bright, so the Kepler telescope uses that to detect exoplanets. This is not an easy thing to do, but during its 9-year lifetime, the Kepler telescope confirmed the existence of 4,367 exoplanets. Could any of them be Earth 2.0? If you're a longtime fan of What If, you've probably heard this before, but Earth is a very special place. And even if a planet is deemed to be habitable, it doesn't mean that it resembles Earth very much. A habitable planet is a rocky planet located in the habitable zone, allowing water to stay on the planet's surface in its liquid form. That's it. Venus and Mars are habitable planets, but they are definitely not like Earth. So let's talk about 3 major conditions that we'd look for when searching for an even better version of Earth. First, it would need to have sunlight. Our sun's lifespan is about 10 billion years, and it took 4 billion years for anything more complex than the simplest life form to pop up on our planet. But K-type dwarf stars have lifespans of about 70 billion years, so if we found an exoplanet orbiting a K-type star, there would be more time for life to evolve and live on it. The second major condition is temperature. A planet that's too hot or too cold wouldn't be able to host the life forms we'd need to survive. But if we find a planet that's a mere 5 degrees warmer than Earth, and it has more water, we could be looking at Earth 2.0, covered in a lush, biodiverse rainforest. The third major condition we'd be looking for is size. Gravity retains a planet's atmosphere, and there's a direct relationship between gravity and a planet's size. So, if we find a planet that's only 1.5 times larger than Earth, it would be able to hold on to its interior heat and maintain its atmosphere for a longer time. But bigger isn't always better. While Earth-sized exoplanets are usually rocky, about 50% of the exoplanets larger than Earth are gas giants. And if an exoplanet is too small, it would likely be barren, like Mars. So, are there any exoplanets out there that meet these requirements? Okay, I found a planet that could be superhabitable. Kepler 1649c could be a contender to become Earth 2.0. It's 300 light years away and orbits a red dwarf star. It gets sunlight, but only 75% as much as Earth, so it might be a bit cooler there. And there wouldn't be any seasons on Kepler 1649c. A full orbit only takes 19.5 Earth days, so we'd need to get used to that. Oh, and it could be tidally locked, which means one side of the planet constantly faces its sun, while the other side faces space. Also, living on a planet that orbits a red dwarf star could be risky. Sometimes red dwarf stars send out massive flares, dousing an orbiting planet in UV light and creating huge temperature fluctuations. But if we decide that Kepler 1649c is worthy of becoming Earth 2.0, what would happen next? Well, using our current technology, it would take at least 2,000 years to reach this Earth 2.0. And since this planet is so far away, we only know about its size, the distance to its star, and the makeup of its atmosphere. So we could pack up humanity, take the multi-generational trip to Earth 2.0 and discover that it's more like a Neptune 2.0. Yeah, there's no way we could survive on a gas giant. We'd need much more information before we send humans to any possible Earth 2.0s. So, right now, NASA is developing a tiny probe to travel at 1/5 of the speed of light. It could greatly expand our knowledge of exoplanets. And we shouldn't limit ourselves to looking just at exoplanets. A moon receives direct solar energy from its star, and the planet it orbits reflects solar energy toward it. So maybe a moon could be more suitable for human life than an exoplanet. The most Earth-like planet in our solar system is Titan, Saturn's largest moon. So if we want to save thousands of years of traveling, maybe Titan could make a good second home for us. Rockets are incredibly powerful. You can launch yourself into orbit, fly the moon, and soon enough, travel to Mars. But to go beyond our solar system, you're going to need something else. Solar sails. How exactly would sails work out in space? How long would it take you to travel to the edge of the solar system? And why could this journey end with your slow and lonely demise? This is What If, and here's what would happen if you sailed the galaxy on solar winds. To launch a spaceship, you need a rocket to push you up into the sky. That push is called thrust. Being launched from Earth with the power of a rocket gives a spacecraft most of its momentum. After this, you'd need more fuel to change your speed or course. But there are no gas stations out there in space for you to refuel, and that means you can only go as far as your fuel takes you. You see, more fuel means more weight, and in space, your reserves are limited. In other words, it would be really hard to get to your interstellar destination with rockets alone. But all of that is about to change. All aboard! You're set to sail across the galaxy. On Earth, sails have been moving boats around the globe for centuries. They work without any fuel, only the power of wind. But out in space, there are no air particles moving around, so you'd need to harness a different kind of wind. Solar winds carry charged particles ejected by the sun. These particles fly across the solar system at a blisteringly fast 1.6 million kilometers per hour. But with a special type of sail, you could take advantage of that power to get yourself across the solar system and beyond. And no, those special sails wouldn't look much like the sails you're familiar with. Are you ready to have your mind blown? This is the contraption that could take you across the galaxy. It's called electric sails, or e-sails. They're kind of like an umbrella without fabric, only these ribs would be made of electrically charged aluminum wires, and they can be as long as 20 kilometers, while also being no thicker than about half of one strand of hair upon your head. Now, all you'd need is the solar wind, and you could sail across the deep, dark sea of outer space. Wait. There's one catch. You see, you'd still need chemical rockets to launch you off into space to begin with. That's because electric sails don't work within Earth's magnetosphere. The magnetosphere is the area around the planet that's under the influence of its magnetic field. It's up to 10 times larger than Earth itself. And to escape it, you'd need a little boost from the old school rockets. Or you could build a spaceport around Earth. It would have to be far enough so that the planet's magnetic field doesn't reach it. But that would get too expensive and take too long to construct, and we want to send you on this journey right now. So you'd launch your ship from Earth and out of the magnetosphere's limits. From there, it would be smooth sailing. With a 1,000 kilogram spacecraft like yours, you'd have about 100 wires to catch solar wind particles. You'd be a pioneer voyaging through space with this fantastic new technology. After 1 year of sailing, you'd reach a speed of at least 30 kilometers per second. And you might even go as fast as 150 kilometers per second. Yeah, and that's really fast. Faster than Voyager 1, the fastest space probe humans have ever sent off-world. The Voyager 1 probe is hurtling through space at about 17 kilometers per second. After spending 3 years getting past Mars, Jupiter, Saturn, and Uranus, you'd end up beyond the orbit of Neptune. You'd navigate by simply changing the voltage levels on different wires of your electric sails. Yeah, well, you'd still have to be a navigational genius to sail safely, especially when you get closer to the outer edges of the solar system. Here, you have to pass through the Kuiper Belt. This area is filled with icy comets, and if you're not careful, these comets will do some hefty damage to your electric sails. Yeah, your interstellar trip might end before you even get out of our planetary neighborhood. After that, you've still got a long way to go to the very end of the solar system, the heliopause. It's 4 times further away from the Sun than Neptune. So fasten your seatbelts and power through a pretty uneventful view for about 10 more years. Yeah, I know, you'd prefer a view of Jupiter or Uranus instead. But hey, it's almost time to explore worlds you've never seen. Ooh, I just remembered I was supposed to tell you something important. Yeah, you know how your electric sails need solar winds to sail? Well, now you'd be the furthest from the Sun you've ever been, and that means there won't be as many solar particles pushing your spaceship forward. Your sailing might just come to a complete stop, leaving you stuck forever in the outskirts of the solar system. Cold, lonely, and hopeless. Yeah, I'm not gonna lie, this could be how your days come to an end. So, while you still have some life left in your sails, you'll need to navigate to another star. If I were you, I'd head to the Alpha Centauri star system. It's the closest one around, and it has not 1 but 3 stars. Now, you should also know that not all stars are equal in providing you the powerful solar winds you so desperately need. Passing by a red dwarf star like Alpha Centauri C, also known as Proxima Centauri, you'd experience luminosities that could be anywhere from 1/10 to 1/10,000th as strong as our own sun. But despite this, you might be able to gain enough accelerating power to reach super high speeds once again. And all this without any chemical fuel. Yeah, going green is the cool new thing everyone's talking about.
Yeah, sailing across the universe is fun until the solar wind dies down. Most Earth sailors will have a propeller as a backup, but just make sure it's not a combustion engine because there's no oxygen in space. Hey, you like my shirt? Well, you can have one of your own. You know we got a merch store, don't you? You didn't know? Well, check out what's in it by going to shop.underknown.com. There's shirts, mugs, stickers, our book, The What If 100, hats, hoodies, and more. We've got it all. All right, one of the spookiest places on our planet used to be the Bermuda Triangle, but over the last few decades, people have lost interest in it. So now there's a new, more mysterious triangle, bigger and better than before, and it's in space.
Did you know that there's a mysterious area in space where astronauts are unable to communicate with home base? They're exposed to extreme levels of radiation, and their spaceships start to malfunction. It's being dubbed the Bermuda Triangle of Space. This area has perplexed scientists for decades, but astronomers may have finally solved this outer space anomaly. What exactly is the Bermuda Triangle of Space anyway? Well, its official name is the South Atlantic Anomaly, or SAA for short. It's hovering above the South Atlantic, stretching from Chile to Zimbabwe, and this area has a considerably weaker magnetic field when compared to the rest of the Van Allen radiation belt. The Van Allen radiation belt is a pair of cosmic donuts surrounding Earth. This is a unique location where the radiation belt comes closest to the Earth's surface. These belts trap particles that shoot from the sun, which protects the Earth from harmful radiation. The solar radiation within the South Atlantic anomaly isn't held back to the same degree, though. But why? Well, to explain that, first let's dive into what happens if you wander into this terrifying part of our solar system. The SAA is known for causing electronic malfunctions in spaceships and extreme radiation exposure for astronauts. It can completely destroy spacecraft. In 2016, the Japanese satellite Hitomi came crashing down to Earth after satellite operators began getting mixed signals from the ship. It was reporting inaccurate data about how it was performing up in space, making people down on Earth think that everything was fine, but this was happening as it traveled through the SAA, so operators weren't aware that there was a problem and couldn't take steps to correct it. The Hubble telescope, luckily, has managed to avoid any issues while traveling through the SAA. That's despite spending a whopping 15% of its time in the space anomaly. To protect the telescope, satellite operators power it down. If they didn't, the SAA could corrupt any precious data that's being collected and potentially crash. But how do astronauts deal with these heavy levels of radiation? Well, their radiation levels are constantly being monitored, so if they do end up in the anomaly, they have what's known as a water wall. Certain rooms on ships are filled with these massive bags of water, and if you stand behind them, they'll protect you from radiation. Water is the best thing to shield you from this harmful energy because of its high hydrogen content. Now, if they didn't have this water wall, they could get severe radiation poisoning or even cancer. So we know the radiation levels are much higher and more dangerous in this specific part of space, but why is it happening in the first place? Well, despite what pictures might show you, Earth isn't completely round. It bulges around the center, like me. And because of this, the Earth's physical center and its magnetic center are slightly off by about 500 kilometers. This offset means things like cosmic rays can get closer to the Earth's surface near the bulging area. Luckily, the Earth's magnetic bubble can still keep all those dangerous rays from getting to us, but that's not the case for people in space above the South Atlantic. Because of this, stronger radiation levels can reach this point up in space, and what's even more concerning, due to the fact that the magnetic poles here on Earth are constantly changing, the South Atlantic anomaly keeps growing. It's also gotten weaker by 15%, meaning the radiation has gotten stronger in the area. So NASA has been carefully monitoring the SAA since 2019. They've noticed that the anomaly is moving west. And what's even weirder, the anomaly is also splitting in two. If this continues, it could make things even more complicated regarding space travel and data collection. But luckily, for it to change significantly would take millions, if not billions of years. So, this Bermuda Triangle of space isn't as mysterious as it sounds, and astronomers are getting better at handling it with every new ship launch and every piece of data recorded. "635 light years from where you are sitting, way out there in outer space, lies a planet. The first planet to be discovered within the habitable zone of a sun-like star. Its name is Kepler 22b. When a planet is located within a star's habitable zone, It means there's a chance that liquid water exists on its surface. And where there's water, there's also the possibility of life. Human life. How long would it take to get to Kepler 22b? What would the weather be like over there? And why would you need to get jacked before arriving on this new planet? This is What If, and here's what would happen if you lived on Kepler 22b. Kepler 22b is what scientists call an exoplanet. It's a planet outside our solar system. Spotting an exoplanet like Kepler 22b is often not easy. The bright glare of the stars they orbit tends to keep them hidden from our telescopes. What did scientists come up with to get around it? Looking at the stars themselves to see if they can find anything unusual about them. They spotted Kepler 22b using what's called the transit method. They watched Kepler 22, the star this exoplanet orbits around, and noticed that its brightness changes over time. That was because Kepler 22b was blocking the star's light. With this, scientists were able to learn both the size of 22b and how it orbits. And it looks like this distant space rock could become our next home. Okay, but what do we really know about Kepler 22b? Its mass is 36 times that of Earth, with a radius of 2.5 times larger than ours. 1 year on Kepler 22b is 290 days. It's also located 15% closer to its star than we are to the Sun. If Earth scooched over that close to our star, you'd be fried. Kepler 22b, on the other hand, is lucky to have a sun that is remarkably similar to ours, but also smaller and cooler. This close proximity to its star allows the planet to receive about the same amount of sunlight as we get over here. The temperature on Kepler 22b could be about 15 to 22 degrees Celsius. Similar to Earth's spring weather, and quite habitable if you ask me. But our galaxy can be a cruel place, and not everything is good news. Some models suggest Kepler 22b is rotating on its side, kind of like our very own Uranus. This may sound insignificant, but it adds potentially deadly complications. This would mean that its north and south poles are shrouded in either darkness or sunlight for half a year. And this ain't simply a matter of whether you're a daytime or a nighttime person. A world like Kepler 22b spinning on its side means that temperatures could change from boiling to freezing, which wouldn't be great for human life. I know, what a bummer, but don't despair yet, because our galaxy is also big enough to include some hope. New studies suggest that Kepler 22b might be covered in an ocean 50 meters deep, and that ocean would be able to act as natural climate control, keeping the wild temperatures at bay. You see, an ocean can store heat in the summer and release it during the winter, which results in a mild climate. Like you needed another reason to live close to the water. But hold on, how would you even make it all the way to Kepler 22b? I mean, even if you were traveling at the speed of light, it would take you 635 years. Your best bet could be to hibernate through the trip inside a device that preserves your body way past its natural lifespan, like cryogenic sleep. NASA has already developed a cryosleep chamber that can lower an astronaut's body temperature to as low as 32 degrees Celsius. This would trigger natural hibernation, during which catheters would provide your body with nutrients and remove any waste. But even in cryosleep, it would be quite the long, risky trip. This leads us to the most dangerous part about this journey. all that remains unknown about Kepler 22b. For starters, we still don't really know what gravity is like there. It could be twice as strong as our planet's. If that was the case, a 10-kilogram sack of potatoes would now weigh 20 kilograms. And your body would also factor into the mix. Is your current weight 75 kilograms? Well, good luck suddenly dealing with 150 kilograms of you. And just for safety, settlers such as yourself would need to bulk up. Really bulk up. Only through intense strength training would you increase your chances of being able to walk on Kepler 22b. And once you got jacked on Earth, you'd have to figure out ways to preserve that muscle through all 635 years of lightspeed travel. But humans aren't the only life form that would be affected by a stronger gravity. Plants brought from Earth for oxygen and nutrition might not survive on Kepler 22b when you try growing them there. And if you brought any animals with you, they'd need to step up the evolution process. Higher gravity could lead to creatures developing additional legs to move around. It could also determine the location and size of internal organs. But the mysteries don't end there. Scientists still don't know for sure that Kepler 22b is even a rocky planet. It might be gaseous, similar to Neptune, or it could be entirely covered with water. If you and the other first settlers woke up from your cryosleep and found yourself on a gas planet, yeah, that would be a downer. You wouldn't have a solid surface to even land your ship, not to mention a place to set up camp. In that case, you and your crew would need to figure out how to build a cloud city orbiting the planet. If you landed on an ocean planet, a submarine town would be in order. Discovering Kepler 22b is a rocky planet would be hitting the jackpot then, right? Well, not so fast. Venus is also made of rock, and yet its dense atmosphere, consisting of greenhouse gases, makes it uninhabitable, with scorching temperatures far too hot for liquid water. If this was also the situation with Kepler 22b, our only chance at thriving on this exoplanet would be to employ robots that could build underground shelters. The place where maybe, just maybe, the temperature might be cool enough for you to bear. It just goes to show you that a prime location is no guarantee for human survival. And as exciting as it might seem to find other worlds to inhabit, our own Earth remains the perfect habitat for humanity.
In the center of our galaxy, the Milky Way, there's a supermassive black hole feeding on nearby stars. It's called Sagittarius A star. And if a giant gravitational monster slowly eating the galaxy isn't terrifying enough, there's another cosmic monstrosity lurking around it. Is it possible that one day they would get a little too close and collapse on each other? What would be left of the Milky Way if they did? Would there be even a slight chance that the Earth could get out of that safely? This is What If, and here's what would happen if a magnetar collided with a black hole. This monstrosity creeping through the Milky Way is a remnant of a giant exploded star. But it's not just any remnant. It's an extremely dense and very magnetic collapsed stellar core, a magnetar. Let me refresh your knowledge of magnetar. Times more massive than our Sun, reaches its expiration date, and explodes in a beautiful supernova. Much of that star is gone, but the dense core of it remains. Most of these remnants become neutron stars. They spin very fast, usually a few times per second, and they're composed of neutrons. Some neutron stars have such strong magnetic fields that they emit electromagnetic radiation from their poles. That makes them pulsars, and you can observe them with a telescope when their poles face the Earth. Only a few pulsars develop such an extremely powerful magnetic field. They become the strongest magnets in the universe, the magnetars. They spin once every 10 seconds, but their magnetic field is 100 times stronger than that of a neutron star. If one of those magnets came halfway between the Moon and the Earth, well, it wouldn't be pretty. But would it be as bad from a distance of 26 light years away? Well, what I'd like to know is, would a magnetar swallow a black hole, or would a black hole gobble up a magnetar? The collision of these two giants wouldn't end up in an explosion, but in a quiet cosmic merger, stretched over billions of years. Although magnetars are incredibly powerful, they would lose the battle with a black hole. Depending on the trajectory of the magnetar, as well as the size and mass of both the magnetar and the black hole, the magnetic monster would be eaten up either whole or slowly, piece by piece. As the magnetar was being torn apart by the black hole, it would be sending gravitational waves throughout the universe, disturbing the curvature of space-time. Once the black hole consumed the magnetar, its mass would increase and expand its event horizon. And thanks to this expansion, more and more stars would be flung into its dark density. The black hole would be slowly eating our galaxy, star by star. Eventually, after quadrillions of years of star consumption, the black hole could gobble up the Milky Way, all of it. By that time, humanity would most likely be long gone anyway. Nearly 800 million light years away, something has been forming. Scientists aren't exactly sure what it is, but have dubbed it the Black Neutron Star. And now, it's headed for Earth. What is this strange object? How would it change our planet? And what makes this new discovery so dangerous? This is What If, and here's what would happen if a black neutron star entered our solar system. What is a black neutron star exactly? Well, scientists aren't entirely sure just yet, but they do have some theories. It all has to do with this mass gap that's found in space. When a star dies, two things can happen. If the star is more than 5 times the mass of the Sun, it becomes a black hole. And if it's under 2.5 times the mass of our Sun, it becomes a neutron star. But what exactly happens when a star is too small to become a black hole and too big to become a neutron star? That's where our new space object comes in. Scientists from the Laser Interferometer Gravitational Wave Observatory and the European Virgo detector have discovered an object 2.6 times the mass of our Sun. Scientists think there's a chance this object is either the heaviest neutron star ever or the smallest black hole. Regardless of what it might be, scientists also discovered that this mysterious space object merged with a black hole of 23 solar masses. This happened 800 million light years away, but the gravitational waves it created were detected here on Earth. This could have created the most massive black hole to ever exist, but let's say this object, which is 2.6 times the mass of our Sun, didn't merge with a black hole. Instead, it came toward our solar system. What would happen then? Well, as the black neutron star came on the scene, gravitational disturbances would disrupt nearly every object within the solar system. All planets, comets, asteroids, and everything else in space would be thrown into chaos. There's a good chance that this would throw the Earth out of the habitable zone. Our planet could end up wandering in the far corners of space. And with the planet being so far from the Sun, Earth's temperature would drop significantly. Luckily, this wouldn't happen right away due to all the greenhouse gases in our atmosphere. But soon enough, Earth would become a frozen wasteland. And since we're not entirely sure what this object is, the results could be very different. If the black neutron star were a kind of magnetar, then we would experience intense solar flares as well. A magnetar can release as much energy as our sun has emitted in 100,000 years in less than 1 second. As Earth is completely frozen, it would then be quickly heated up as the black neutron star gets closer, vaporizing nearly everything on the planet. Not to mention, it would also cause tidal heating. The strong gravitational pull coming from this massive space object would deform Earth by heating our planet's core. This would also give rise to massive earthquakes and volcanic eruptions. And what if the black neutron star were just a really small black hole? Well, the results of it entering our solar system wouldn't be any less destructive. The black hole would slowly suck up everything in our solar system. It would grow larger and larger, making its way toward Earth. And once it gets to us, its enormous tidal force would pull Earth apart, and there's nothing we could do to stop it. There's also a chance that this black neutron star could be a regular neutron star that then becomes a black hole. This would result in Earth being quickly destroyed by all those consequences from before, and of course we'd all die. So yeah, sorry, we killed you a bunch in this one, but it just goes to show that we definitely wouldn't want these objects coming anywhere near us.
A rogue star is headed straight for our sun. If these two stars slam into each other, it could spell the end of all life on our planet. How could a rogue star end up in our solar system? What would this epic collision look like? And how much time do you have to live? This is What If? And here's what would happen if a rogue star collided with the sun. As the name would suggest, rogue stars drift through space. They don't belong to any particular galaxy, or if they once did, they've been ejected from their homes at some point by supernovas or two galaxies ramming into each other. Whatever it is that sends these stars hurtling away from the gravitational pull of their original galaxies, it fires them off at very high speeds. In order to break free of our own Milky Way galaxy, a star would need to move as fast as 550 kilometers per second. Luckily, our sun is only moving at a mere 200 kilometers per second, not nearly fast enough to become rogue. But these wandering stars aren't all that uncommon. They may even account for as many as half of the 200 billion trillion stars in the universe. And one of them could be headed toward our sun right now. Meet Gliese 710. This rogue dwarf star is on a trajectory that would bring it close to our solar system in around 1.3 million years. When Gliese 710 eventually reaches us, it would enter the outermost section of our solar system, the Oort cloud, at a speed of about 51,500 kilometers per hour. It could send the icy bodies out there flying in different directions, maybe even right toward Earth. once it has reached Neptune, the countdown to the epic collision would begin. T-minus 10 years till the impact with the Sun. At this point, you'd better just plan to live your best life while preparing for the upcoming apocalypse. The gravitational pull of Gliese 710 would destabilize the orbits of our planetary neighbors, nudging them left and right. This could go as far as pushing Earth out of the habitable zone. Or it could turn us into a rogue planet after unceremoniously being catapulted out of the solar system. After 10 years, it would finally be getting close to collision time. As each day passes, things are only going to get worse. One possibility is that the Sun and Gliese 710 would merge into a red nova. This would result in a violent explosion that would unleash nearly 500,000 times more light than what the Sun does right now. Given the amount of time light takes to travel from the Sun to the Earth, you would be blissfully unaware of this destructive explosion for 8 minutes. But the moment you do find out, all that light would likely blind you in a millisecond and then immediately fry you on the spot. That's because directly behind this blinding light would be super hot gas. This wave of heat could be powerful enough to wipe out nearly everything in its path. Bye-bye Mercury, Venus, and yeah, Earth too. Our atmosphere and oceans would be completely blasted away. This would leave our planet as nothing more than a barren rock. The explosion would also have created massive amounts of high-energetic neutrinos. These would be able to boil you from the inside out. Earth would also be shrouded in lethal levels of UV and gamma radiation. Even if you somehow managed to survive the explosion, you wouldn't last long from the harmful effects of all this radiation. You'd have damage to your eyes, skin, and even DNA. Now, if an alien species was watching this all unfold from a distant galaxy with an incredibly powerful telescope, they'd see a single bright star surrounded by an excess of reddish-colored gas. And the infrared light left behind from the explosion would be visible for a long time after. But that wouldn't be the only way all this could possibly go down. There is a possibility there could be a more peaceful alternative. Yeah, if the two stars are moving a bit slower relative to each other, they could end up merging into one massive new star as they orbit each other. Our Sun would strip mass from its smaller companion, Gliese 710, and swallow it in a process known as stellar cannibalism. Then, this extremely hot and bright star would be called a blue straggler. Though it may sound many times more peaceful, this option would still likely spell out the end of life on Earth. With our Sun now a massive blue star, the habitable zone of our solar system would be pushed further away. It's invisible, deadly, and sucking up every bit of matter in its path. The most massive black hole in the known universe is headed right toward Earth. What would you see as it started to slurp up the Milky Way galaxy? What kind of tasty dish would Earth become? And when it's finished with us, where would it go next? This is What If, and here's what would happen if the largest black hole entered our solar system. Black holes aren't that much different from any other object in the universe that has mass, except that they are really, really dense.
At their center is a singularity, an infinitely small point where all its matter is compressed. The more matter that's condensed into this singularity, the stronger the gravitational pull. Most black holes are the remnants of massive stars and generally range between 10 to 100 solar masses. For the record, one solar mass is the equivalent of 333,000 Earths. That's a lot of gravity. But supermassive black holes, which lurk at the centers of many galaxies, could contain millions or billions of solar masses. And scientists think that there are black holes as large as 100 billion solar masses, aka stupendously large black holes or slabs. Catch one of these moving toward our solar system and get ready to wave bye-bye to all your conceptions of space and time. The largest known black hole, Ton 618, has begun its long trek directly toward our solar system, with its 66 billion solar masses in tow. And long trek is no overstatement. It would be traveling at least 10 billion light years to reach us. As it steamrolled through space, it would gobble every bit of dust and gas in its path. It would also snack on many stars before it even reaches the Milky Way. Depending on its route, this could mean hundreds of billions of stars added to its size. Before making first contact with our galaxy, it would have pulled in enough matter to disrupt its neatly organized spiral. You'd be able to detect its initial approach toward us as you observe the increasingly intense radiation it emits. Eventually, it would come bearing down on the last of the Milky Way's spiral arms, the Orion Arm. Ton 618 would gobble up its entire 20,000 light-year length. It would be like an unbelievably long buffet line straight to the center of our galaxy. Somewhere along this line, it would finally knock on our front door. The Oort cloud is a spherical shell of icy debris that surrounds the solar system. Or at least it was before Ton 618 showed up. It would then continue on its way and consume the Kuiper belt just beyond the orbit of Neptune. The danger to Earth would steadily increase as hundreds of thousands of icy bodies would be sent hurtling this way. As Ton 618 kept pushing forward, it would devour the ice giants, Neptune and Uranus. And the gas giants, Saturn and Jupiter, would be pulled apart atom by atom. Not only the planets, but their moons and every asteroid that the giant black hole comes across. Any future plans by us to settle on Mars would be squashed, as the red planet would end up right smack in the middle of this black hole too. And now there would be nothing left in the way of Ton 618 and Earth. Now, while the center of this stupendously large black hole would be almost 295 billion kilometers away, we'd finally be right up against its event horizon. That's the boundary marking a black hole's point of no return. The pull of its gravity would now be totally inescapable. Our whole planet would stretch out while simultaneously getting more and more compressed. Eventually, Earth would become like a strand of spaghetti, slurped into an empty black void. Then, this black hole monstrosity would gobble up the sun in one big gulp. And now, at the center of what was once our solar system, Ton 618 would occupy nearly as much space. It would extend almost all the way to the inner edges of what used to be the Oort cloud. And since it's not polite to leave any food on your plate, Ton 618 would continue on its path toward the black hole at the center of the Milky Way, Sagittarius A star. As these
two massive black holes collide, the collision would be so powerful that it could cause ripples in the very fabric of space-time.
Imagine you're out for a walk on a lovely day with not a care in the world. The birds are singing and the sun is shining. Actually, the sun seems brighter than usual. And come to think of it, your skin feels kind of funny. It turns out that's not the sun at all, but the radiation and gamma ray filled light coming from a quasar. So, in short, you're in serious trouble. How did a quasar even get here? And what would happen to Earth if a quasar moved into our neighborhood? This is What If, and here's what would happen if a quasar entered our solar system. I hope you didn't have any plans today, because the brightest object in the sky has set up shop in our solar system. So what exactly is going on anyway? A quasar is the result of two black holes colliding to form a supermassive black hole, with a central mass that outweighs our sun by 1 billion times. When black holes merge, everything goes out of whack. The two black holes begin to consume all the gas and dust from each other, along with anything else in the area. Okay, so if they're eating each other, why are we seeing that bright light? Well, the material that's thrown off begins to glow from pressure and friction, resulting in the blinding light you're seeing. If this were to happen in Earth's vicinity, it would be a result of the black hole in the middle of the Milky Way galaxy smashing into the black hole at the middle of the Andromeda galaxy, which is 2.5 million light years away. If these two met, we'd be looking at a massive amount of infrared light being expelled into the universe. Oh, and it's also a harbinger of death and destruction, too. What would happen to our planet? Well, brace yourself, because this is going to be a doozy. Quasars throw off jets of particles that are so bright they outshine all the stars in their galaxies. So our sun would essentially turn into a candle in the middle of a very bright spotlight. The illumination from a quasar, along with all the radiation it throws off, would mess with Earth's atmosphere. The light is enough to energize particles that make up the atmosphere and free them from Earth's gravity. Our atmosphere would be destroyed, and we really need our atmosphere. It's our protective layer that keeps things in order and regulates the temperature. Without it, the oceans would dry up, Arctic ice would turn into water vapor, and everything would get much, much hotter. In addition to it being blindingly bright, we would have no safe air to breathe, no plants to eat or feed animals, and there would be no water to drink. Life on Earth would be a write-off. This would all happen very quickly, so you wouldn't have to live through a long, drawn-out apocalypse. At least you can look forward to that. But could this sort of doomsday scenario actually occur? Well, yes, but not for another 3 or 4 billion years. At that point, the sun will be flickering out. And by that time, we're pretty sure something else we've covered on What If would have taken us out first, so we won't even be around to see it.
A dark, mysterious object has appeared at the outer edges of our solar system. It looks like the remnants of a dying star, but it behaves like a black hole. Your mission? Traveling right into its heart of darkness. What makes this mysterious object unique? How dangerous would it be to experience such powerful gravity? And how might this turn into one of the strangest experiences in the universe? This is What If, and here's what would happen if you fell into a black neutron star. I know we've talked about black holes before, but let me do a quick recap. A black hole isn't much different from any other object with mass, except that it's really, really dense. All the matter it contains is compressed into one point called a singularity, which is so small and so dense that our understanding of time and space within it breaks down. That singularity is what causes black holes to have enormous gravity. And then there are neutron stars. These form when a large star collapses at the end of its stellar life. A star that was once 1.5 times more massive than our own sun would now only be about 20 kilometers wide. That's no bigger than a city. But what you have lurking on the outskirts of the solar system is something else entirely. Too massive to be a neutron star, too small to be a black hole. This is a black neutron star. Not much is known about these objects, and what we do know, you're about to learn the hard way. For this scenario, let's ignore the fact that it would take you thousands of years to travel all the way to the outskirts of the solar system. Let's imagine that the best scientists on the planet came up with a way to roam our planetary neighborhood really fast. And now you'd be observing this gravitational monster up close. You'd know exactly where a black neutron star was making its catastrophic approach because of all the radiation it emits. This is the same way you'd find either a black hole or a neutron star. And just getting close enough to observe this star won't be enough. You need to venture right into its center. Your mission would require some protective gear, and this gear would need to keep you safe from some of the most intense forces of gravity in the universe. So don't take this preparation lightly. The black neutron star would be pulling you toward it with gravity about 2 billion times stronger than what you're used to on Earth. The problem is that the kind of intense gravity protection gear you need doesn't exist. Without it, your mission would be of the suicidal variety. As you got closer, different parts of your body would experience different gravity. If you were diving into this monstrosity head first, your upper body would get stretched a lot more than your legs. As you got closer to its center, you'd be spaghettified. Yeah, you'd become long and thin from your head down to your toes, just like spaghetti. Only this would be one brutally painful plate of pasta. But since you'd be on an incredibly important mission, you'd have the best equipment you could ever imagine. The best NASA scientists would supply you with a suit resistant to the extreme pressures, temperatures, and radioactive matter inside the black neutron star. Now would be the time for the task at hand. You'd dive layer by layer into an object of incredible mass. It would be like falling into our sun if it was squeezed into the size of a small city. On the outside, the black neutron star would look like any other kind of star, except that it would be really toasty. Your regular neutron stars are extremely hot, usually about 1 million degrees Celsius. A black neutron star? Well, you'd have to find out its temperature on your own. I bet it would be just as scorching. First, you'd pass through a gaseous layer of hydrogen and helium. After that, you'd find yourself on more solid ground. Scientists think that the second layer would likely be composed of iron and silicon. To continue your mission, you'd need to somehow punch through this blazing solid surface. Well, lucky for you, NASA equipped you with a super powerful drill that can withstand the heat. And things would start getting dangerously dense. Hope those guys at NASA made you an extremely durable suit, too. Down at the heart of the black neutron star, you'd notice a unique material, one of the strangest in the universe. Scientists call it nuclear pasta. Inside the neutron star, the nuclear clusters get packed so densely that they create the hardest matter ever known. At least this time it's not you that's turned into spaghetti. If all this talk about you being turned into some sort of food item has you worried, well, brace yourself. The madness would just be getting started. Now you'd be so deep that the intense levels of pressure around you would be about 3 times higher than the density of an atomic nucleus. Protons and electrons would combine into neutrons. Hey, well, now you know how neutron stars got their name. As these newly formed neutrons start to overlap more and more, you'd keep traveling further and further down. Eventually, you'd find yourself face to face with the squished components of neutrons and protons, quarks. Finally, approaching the core of the black neutron star, you'd be nearing maximum bizarreness. Of all the squishy quarks surrounding you, there would be some so weird that scientists call them strange quarks. These quarks are heavier than other quarks, and they've earned their name by possessing a property known as strangeness. All it means is that strange quarks have less chance of being torn apart by the black neutron star's electromagnetism. Inside this core, the strange quarks would form a soupy mixture known simply as strange matter. And encountering strange matter would be the very end of the journey for you. Strange matter is contagious. That means when it comes into contact with ordinary matter, like you, it would generate more strange matter. So as soon as you'd touch it, it would instantly dissolve your protective gear and immediately after that, your whole body.
This is the most powerful object in the universe. The biggest spinning magnet to ever exist. It's the cosmic equivalent of a great white shark. But it wouldn't eat you. It would just turn all your atoms to dust. This is What If, and here's what would happen if a magnetar entered our solar system. If you thought neutron stars were big and scary, well, you haven't heard of their more powerful stellar cousins yet. Like neutron stars, magnetars are leftovers from supernova explosions. They're just packed with a lot more matter. Their density is so high that a single teaspoon of a magnetar could weigh in at 1 billion tons. They're also the most magnetic stars we know about. We use a unit called a Gauss to measure the strength of a magnetic field. Earth's magnetic field is only about 0.6 Gauss. The magnetic field of a magnetar can be as strong as 1 quadrillion Gauss. How long would it take a stellar monster like that to rip our planet apart? It wouldn't be the worst thing in the world if a magnetar was sitting quietly in our galactic neighborhood, but if it decided to stop minding its own business, there are 2 ways a magnetar could end all life on Earth, together with the planet itself. It could get too close to the planet. You'd start to feel its presence when it was about halfway between the Moon and the Earth. At that distance, a magnetar would erase the information off all your credit card's magnetic strips. Whatever you do, try not to get closer than 1,000 kilometers from a cosmic invader. Because if you did, your atoms would get stretched out of shape. Your bioelectric field would get scrambled, disintegrating your molecular structure. And your body would just disappear. Alternatively, a magnetar could destroy us from much, much further away. As if being the biggest spinning magnets in the universe isn't enough, magnetars can also be affected by something called starquakes. Starquakes happen when a star's crust cracks, letting massive amounts of radiation out into space. This blast of radiation could compress the Earth's magnetic field and partially ionize the Earth's atmosphere, even from 50,000 light-years away. We know this because we've already come a little too close on at least one occasion. In 2004, gamma radiation from a magnetar reached our planet from outside our Milky Way galaxy. In just 1/5 of a second, it released more energy than our Sun has released over the last 250,000 years. Move that magnetar and its starquake up to 10,000 light-years away, and things would get much worse. First, it would destroy our ozone layer. Then, it would wipe clean most of the planet's surface, along with all life as we know it. The truly scary part of this is that we wouldn't even know the magnetar was heading towards us. It would be a blink and you're gone scenario. I won't lie to you, there are magnetars close enough that if one had a violent starquake right now, we'd all get wiped out very fast. When scientists began their search for these interstellar monsters 40 years ago, they didn't realize how many of them exist out there. You might find some comfort in the fact that most magnetars don't make it much past their 10,000th birthday. Their short lifespan ends with them becoming neutron stars. Still dense and still magnetic, but not nearly as dangerous as a magnetar.
What would happen if you flew into a wormhole? Would you ever hear back? Where would you end up? Back in time? Another galaxy? This is What If, and here's what would happen if a wormhole formed in our solar system. You've probably heard of wormholes through Thor, Interstellar, Star Trek, or if you're really old school, Albert Einstein. In 1935, Albert Einstein and physicist Nathan Rosen came up with the idea of bridges in space-time. WTF? OMG. Sounds like you're catching on, because an Einstein-Rosen bridge, or a wormhole, is also a shortcut through space-time. A wormhole is less like a bridge and more like a tunnel. It's a tunnel that links two different points in space-time. And if you were to pass through it, you could end up in a different galaxy, a different universe, or 14th century Europe. Ugh. But only if you found a way to keep the wormhole from collapsing on you. The trouble is, no one's ever seen a wormhole before, and we probably won't find one anytime soon. The other problem is, if wormholes do exist in our solar system, they're probably microscopic. Any wormhole that could accommodate human travel would require a crazy amount of mass. Think about it. The smallest black hole is thought to be the size of an atom, but with the mass of a mountain. So, while we can't really calculate the mass of a wormhole that could fit a few of us in a spaceship, just know that it would be astronomical. And its gravitational pull would probably redirect the tilt and rotation of all the planets in our solar system. But things would go back to normal soon enough. Wormholes are incredibly unstable and are prone to collapse quickly. This is because the walls of a wormhole attract each other, which is why the wormhole would probably close shortly after it opened. Unless you had some exotic matter. Don't get too excited. Exotic matter is negative energy, and it's what you'd need in order to repel the gravitational forces trying to bring the walls of the wormhole together.
You shall not pass!
Unfortunately, it's unlikely that such matter even exists in our universe. But if you're already set on making a trip across the universe, there's just one more thing you should know. The laws of physics say that you wouldn't be able to put enough negative energy into a wormhole to keep it from collapsing. But on the bright side, that rule hasn't been tested yet. So, giddy up, space cowboy. Ride on, prove their existence, and we'll try to develop the necessary technology in your absence. But even if we could create wormholes and travel through them, would it be worth it? Is it worth tilting the Earth and rearranging the solar system just to visit another galaxy? Or go back in time? Read your history, read your science fiction, see all the movies, and play all the games you want. But let's be glad our solar system is the way it is. Would we even be here if it wasn't?
What would happen if you took the most energetic light source in the universe and smashed it into a massive gravitational monster? Well, you might reverse the flow of time. How would this event unfold? how could it affect time as we know it? And what would happen if you got too close? This is What If, and here's what would happen if a gamma ray burst hit a black hole. Meet your first fighter, a black hole. Not so different than your average object with mass, except that it's extremely dense. Most black holes are the remnants of massive stars, and they have lots of gravity. The mass of this black hole is compressed to a point called a singularity. At this infinitely small point in the center, conceptions of space and time break down. Today's challenger is a gamma ray burst. Not so different from your average burst of visible light. Oh yeah, except way more energetic. Gamma ray bursts are the strongest and brightest explosions in the universe. In 1 second, gamma ray bursts emit as much energy as the sun will emit during its entire 10 billion year lifespan. So, if these two powerful phenomena collide, would space and time cease to exist? There are a couple of things you should know before we get underway with our space-time obliterating cage match. The first is that our two contenders already interact pretty often. A black hole releases a burst of gamma ray light when it's created. This burst spreads out evenly in all directions across the universe. So some of these gamma rays will certainly encounter another black hole or two. And these gamma ray bursts happen about once a day. They could flash for less than 2 seconds, or they could last for up to 30 seconds. The difference is whether the burst results from two neutron stars colliding to form a black hole, or whether it's the result of a star collapsing directly into a black hole without a supernova explosion. So, if you managed to observe these phenomena, would you witness a magnificent explosion about 1,000,000 trillion times brighter than the sun? Well, not quite. While some photons have just the right amount of frequency to be visible to your eyes, the frequency of gamma rays is way too high. Your eyes aren't advanced enough to see their beautiful bursts. But if you could see them, this insane amount of light would probably leave you blind. Now, surely this explosion must be loud, right? Well, once again, I come bearing bad news. It would technically sound like nothing. Yeah, sound doesn't travel in the vacuum of space. It needs a medium with particles to carry sound waves. But thanks to the scientists at NASA, a gamma ray burst would sound a little something like this. Okay, not exactly like this. These beautiful cello and piano notes translate the gamma ray frequencies into musical notes. Pretty mellow for such a massive explosion, right? But if you were close to this explosion, things would be anything but mellow for you. Gamma rays are hazardous. They can penetrate lead, concrete, and certainly whatever spacesuit you'd be wearing. As they pass through your body, they deliver an extremely high dosage of radiation. You'd suffer radiation sickness. You'd become nauseous, lose your hair, and even bleed. The energy could cause damage to your tissue and your DNA, leading to cancer or, worse, death. The gamma rays could cook you from the inside out. So you'd want to back up a little bit. Or better yet, reverse time. In 2018, researchers observing gamma ray burst pulses found that some events repeated themselves in reverse. That's right, it was as if they were moving backward. So, what does this mean for you? Did you just stumble on a way to travel back in time? Again, I have bad news. This is merely an optical phenomenon. Light has the fastest speed in the universe, but this is only true for the speed of light traveling through empty space. In other mediums, like water, it would be possible for electrons to travel faster. That means if gamma rays could travel faster than the speed of light, they would give the illusion of reversing time. So yeah, it's possible I oversold you a bit on the idea that if a gamma ray burst collided with a black hole, it would result in the brightest, loudest, time-destroying explosion of all time. But in some ways, it's all true. Stars are gigantic balls of fire holding planets, asteroids, and meteorites in their firm gravitational grip. And their fire sends light into the farthest reaches of their galaxies. But how did they get here? I mean, these incredible orbs must have come from somewhere, right? What would it be like to witness this epic birth? What would it feel like at the center of the action? And why would this beautiful event have a funny smell? This is What If, and here's what would happen if you saw a star being born. The Milky Way galaxy spans about 100,000 light years across, and it contains somewhere around 200 billion stars. If there are that many stars in our little section of space real estate, imagine how many there are in the entire universe. Now, depending on where you look in the night sky, you could see around 5,000 stars just with your naked eye. The brightest ones have melodic names like Polaris, Alpha Centauri, and Betelgeuse. Looking further out into the universe with the help of telescopes, there are simply too many stars to name.
That's the North Star. Well, what is that?
That's why many of these are now identified more generically, like WASP 50, HD 28678, and HAT P23. But today, you're not just going to look into a telescope and name some baby stars. You're going to be in the thick of it. The hot, dense thick of it. Every year, 7 new stars are born in the Milky Way alone. Now, that might not sound like a whole lot, but keep in mind that our galaxy has already used up 90% of its star-making material over the billions of years of its existence. And yet, new stars are still being born all the time. Now, to witness their birth, you need to travel to one of the many star nurseries in the universe. These are known as nebulas. Nebulas are huge clouds of gas and dust that can span light years across. So, hop into your interstellar spacecraft and set your coordinates for one of the most famous stellar nurseries of our galaxy, a mere 1,344 light years away. The Orion Nebula. Yeah, it's here that you'd find the necessary ingredients for a star to be born. Gas, dust, gravity, and turbulence. Sounds like my car. Being in the middle of a nebula would feel like being in the clouds. You'd be surrounded by over 200 different kinds of molecules. There would be hydrogen and helium gas, as well as microscopic grains of silicon and iron. And I hope you packed some warm clothes because conditions in this cloud would be frigid. You'd need a spacesuit thick enough to withstand temperatures as low as minus 270 degrees Celsius. But don't worry, things are about to heat up. Suddenly, you'd be hit by a blast. This would be a ripple effect from an exploding nearby star, and it would cause the nebula to become turbulent. All it means is that the gases around you would start to mix and swirl together. It would be the beginning of the epic event you're here for. First, dust particles would begin to clump together. These clumps would become denser and denser, forming knots. Once these knots gain enough mass, they'd start to collapse under their own gravity, and their internal pressure and temperature would increase. Yeah, at around 2200 degrees Celsius, these high-pressure knots would emit a dull red glow. You wouldn't be able to see it because that light would be infrared, but you would be uncomfortably aware of the temperatures starting to rise. And things would keep heating up. Eventually, the protostar before your eyes would emit its first rays of visible light. Wait, do you smell that? Well, no, of course you don't. You're wearing a heat-resistant spacesuit, but if you could, you'd learn that this hot mass of dust and gas would also smell.
It's disgusting.
But not necessarily in a bad way. Depending on the mixture of compounds around you, you could detect hints of sweetness, lemon, or even alcohol. But be careful, your baby star wouldn't only be pulling things inward. Every now and then, it would shoot powerful jets from its poles at supersonic speeds. These would flash brightly as they come into contact with the surrounding gases. All the while, the protostar would simultaneously grow and collapse under its own weight. This would make the core continue to heat up. Yeah, once it reached the scorching hot temperature of 5 million degrees Celsius, you'd witness your baby star's first nuclear fusion. Deep within the center of the star, 4 hydrogen atoms would fuse together to form helium. This would release a ton of energy. And with all that energy, the protostar's pulsations would come to a halt. It would finally become a star. Now, during the excitement of witnessing a star being born, you'd have seriously lost track of the time. If the star that formed in front of your eyes was similar to our sun, well, you'd have just watched 50 million years fly right by you. And you might want to get your hearing checked after experiencing all this. Of course, there's no sound in the vacuum of space, we all know that, but in the stellar nursery filled with gas and dust, sound waves may have a medium to travel through. And if you were wondering what the birth of a star sounds like, well, it would be deafening. If we could hear our own sun, it would be a lot like Earth was covered in constantly wailing sirens, except multiplied by 10,000. A new star created by a series of violent contractions of superheated gas? Ugh, forget about it. Okay, now that your baby star is all stabilized, it could burn bright for another 10 billion years. We've thrown a lot of disasters at Earth over the years, from asteroids and aliens to the sun's death. But hey, the universe is a dangerous place, and we're not done yet. Now we're going to throw a black hole into the mix, and not just any black hole, but a blazar. How old is the oldest blazar? Why can we see some blazars but not others? And what is the Doppler effect, and how would it let us know that a blazar is on its way? This is What If, and here's what would happen if a blazar entered our solar system. Black holes are found at the center of most galaxies. The Milky Way has a black hole that is 4 million times the mass of the Sun. But that's small compared to other black holes out there. For instance, there's PSO J0309 plus 27. This galaxy is the oldest ever discovered at around 13 billion years old. And since the universe is only 13.8 billion years old, PSO J0309 plus 27 has basically been around almost since the beginning. At the center of this galaxy is a supermassive black hole that could fit 250 black holes from the Milky Way. Because of this crazy big black hole, PSO J0309 plus 27 is considered to be a blazar. And blazars are the most extreme type of active galactic nuclei, or AGN for short. But what are active galactic nuclei? Well, there are different types, a blazar being just one of them. But basically, they're galaxies with supermassive black holes that spew tons of energy, which could range from radio waves to gamma rays. Because they give off so much energy, they are the brightest objects in the universe. So, what makes a blazar special? Blazars are extremely rare. There are anywhere from 200 billion to 2 trillion galaxies in the universe, and only 1 out of every 10,000 galaxies are blazars. But what makes them really spectacular are the jets of material shooting out from the top and bottom of their rotating disks. These jets are supercharged with magnetic fields and radiation. The material inside them can travel just under the speed of light, and their lethal radiation beams are pointed straight at Earth. Let me be clear, it's not just some blazars that are pointed toward us, but all of them. Any blazars that aren't pointing their deadly jets in our direction are invisible to us. So, what blazar would be the most likely to enter our solar system? Well, let's go with the closest one to Earth, Markarian 421 at 400 million light-years away. How would we know it's coming, and when would it start affecting Earth? Well, scientists would know that Markarian 421 is getting closer to Earth almost right away. The light from the blazar would change from red to blue. Changes to the light's wavelength would cause this, and it has to do with the Doppler effect. This is a hard one to explain, so I'm going to use a metaphor. You've just pulled over to clear a path for an ambulance, and as the ambulance approaches you, its siren has a higher frequency, but once it passes and speeds away from you, its siren has a lower frequency. Both sound and light behave like waves, so you can use the same idea for the Doppler effect. When a galaxy moves away from you, the frequency of its wavelengths become lower and shift toward red. When a galaxy moves toward you, its wavelengths have a higher frequency and shift toward blue. Most galaxies in the universe are red-shifted because the universe is expanding. So, if Markarian 421 suddenly changed to blue, astronomers would know right away that it was heading toward us. How long would we have? Well, even at the speed of light, it would take Markarian 421 400 million years to reach Earth. But it doesn't have to reach Earth to cause damage. Its jet could be hundreds of thousands of light-years long. Our galaxy is only 100 light-years across, so Markarian 421 would begin blasting our solar system with radiation before it even entered the Milky Way. Blazars are also known to blast off from time to time. This giant flare can last from minutes to months. If Markarian 421 blasted off within a range of our galaxy, its jet would punch a hole straight through our solar system. It would be a doomsday scenario, and there wouldn't be anything we could do to save ourselves.
This is the Sun. And this is a neutron star. But don't let its size fool you. Neutron stars are massive gravitational monsters, and orbiting one wouldn't end up well for our planet. But what if we took just a spoonful of it and transported it to Earth? Such a tiny amount of a neutron star couldn't possibly destroy us all. Or could it? This is What If, and here's what would happen if a spoonful of neutron star appeared on Earth. When a star about 4 times the size of our Sun explodes in a supernova, it propels its outer layers into space, leaving only a dense, collapsing core behind. A neutron star. Neutron stars are very, very dense. They could have the diameter of a small city, but their mass would be 1.4 times the mass of our Sun. Of course, no neutron star will ever appear on our planet by itself. First, you'll have to grab a spoonful of it and bring it back to Earth. You'll find the nearest neutron star, nicknamed Calvera, 617 light-years away from Earth. If you jumped in the fastest spaceship we've ever built, it would still take you 11 million years to travel to Calvera. I'll have to fast forward here and meet you in the neutron star's neighborhood. You'd be trying to get your spacecraft through a magnetic field that's tens of millions of times stronger than Earth's. Your ship's computers would be useless if they had any ferromagnetic materials like iron, nickel, or cobalt in them. You wouldn't want any of those materials anywhere in your craft. You'd have to dodge the electromagnetic radiation beams shooting from the star faster than you can blink. And then, when you finally manage to get to the surface of Calvera, you'd be immediately vaporized due to the temperatures being around 1 million degrees. Celsius, Fahrenheit, at this point, would it even matter? Any part of your craft that wasn't vaporized would be crushed by the star's intense gravity. But let's not end your story right there. Instead, let's equip you with a supersuit that could withstand the insanely hot temperatures and the extremely high pressure of a neutron star. And here you have it, a spoonful of Calvera loaded on your ship. Now what? If you tried to scoop the Sun with a teaspoon, you'd only get about 2 kilograms of it. The same amount of a neutron star would weigh anywhere from 1 billion to 6 billion tons. You wouldn't be able to lift that spoon in the first place. And that's not even the worst part. Because the gravity of a neutron star is so intense, it fuses protons and electrons together. Only neutrons are left in that stellar core. When they aren't buried down inside a star, neutrons don't last too long. After 10 minutes, the scoop of a neutron star would break down into protons and neutrons and release as much energy as the Sun produces in 2 or 3 seconds. Good thing you didn't have enough time to bring that stuff back to Earth. Leave neutron stars where they belong, far, far away from us. And if one ever comes a little too close to Earth, jump on a spaceship and escape to another planet outside the solar system. But that would be a story for another What If.
One minute, you're setting up a new space station orbiting Jupiter, and the next, you're plunging right into the middle of a giant red cyclone of death. What would the storm of all storms look like on the inside? How would it compare to storms back on